Hey guys, good morning and welcome back again to your Unacademy NEET English channel. I hope all of you are doing amazing, all of you are doing great. So people, quickly let me know in the chats if all of you can hear me, if I'm perfectly audible and visible to every one of you. Quickly let me know in the chats with some fire emojis. Everyone. Quickly let me know in the chats with some fire emojis if all of you can hear me, if I'm perfectly audible, visible to everyone. Quick people, quick, everyone in the chats. Perfect. I want you guys to call up everyone whosoever is preparing for NEET 2024 because this particular session is definitely going to be beneficial for everyone. And my dear students, let me tell you from this particular session, expect 30 to 35 questions directly or indirectly in your upcoming NEET 2024 examination. Right? Expect 30 to 35 questions directly or indirectly, right? From this particular session. Trust me on that. So are you all ready for this amazing marathon? Are you all ready for this amazing marathon? Yes? Perfect, guys. Perfect. So basically, what I have planned in the today's marathon. Let me give you the context of that. My dear students, you know, in your every chapter of chemistry, there are almost like 20 to 30 different types of the questions which can be asked. Not more than that, right? I'm talking about the types of the question, patterns of the questions, right? So in every chapter, there will be almost like 20 to 30 different problem patterns which can be asked. In this particular session, I'm going to discuss all those problem patterns with the concepts, right? With the concepts. I believe all of you would have seen one of my sessions in which I gave you some 55 short concepts of chemistry. Do you remember that? 55 short topics of chemistry. Perfect. Right? So basically in this particular session, in every chapter, as I told you, there are some 20 to 30 different problem patterns. In the today's session, I shall be discussing them one by one with the concepts as well. Wherever I would feel that I'll have to do the concept in depth, I do that. Wherever I would feel there is no need to discuss the concept, I will avoid the concept there. Perfect. I just want you guys to be ready with your pen and paper because trust me, this particular session is going to be absolutely beneficial for all of you. And in this particular session, I have taken some 11 to 12 high weightage chapters. Let me show them to you. These are the chapters which I shall be covering, starting with mole, redox, atomic, chemical bonding, thermodynamics, equilibrium, GOC, chemical kinetics, solution, electrochemistry, coordination chemistry, right? And one chapter is missing here, that is periodic classification. That is periodic classification. That is periodic classification. Right? This is one more chapter which will be done in this session itself. So in total, we are going to do some 12 chapters today. And my dear students, 12 chapters, right? 30 to 35 questions for sure from the today's session, for sure. Take it in writing, right? But the questions can be asked directly or indirectly. Perfect. And through this session, your every chapter will be revised properly. You just have to solve the questions with me. Okay? And the duration of this particular session, I do not know exactly. It can take some 8 hours, 10 hours, 12 hours. I don't know exactly. Yeah? Perfect. So are you all ready for the session? See, apart from these chapters, there is class 12th organic part, DF block elements and hydrocarbons. There will be a separate marathon for this, and this particular marathon will be taken by HSP sir. This particular marathon will be taken by HSP sir. Rest all the chapters I'll be doing today. Okay? Perfect. I can see not everyone has, oh sorry, one more chapter, that's P block. That is P block, sorry, I forgot that. All right. Perfect. So I can see not everyone has liked the session yet. I would want every one of you to like the session, right? And share this particular video with everyone. I'm doing good, guys. Thank you so much. I'm doing good. I'm doing good. I'm doing good. Aldehydes, ketones, carboxylic acids will come in class 12th organic part, right? These are the chapters which I've mentioned over here. These 12 chapters I shall be doing today, right? In every chapter, there are some 20 to 30 different problem patterns. I shall be discussing all of them with you, right? And trust me, nothing is going to be asked apart from those 20 to 30 problem patterns which I shall be discussing from every chapter. Just trust me on that. So please be ready with your pen and paper. Perfect. PDF I'll share at the end of the session on my Telegram. You know that already. You're already added in that, I believe. Yeah? Right? So people, should we start? Should we start? Okay, before starting the session, can you let me know in the chats, like, how many of you have watched the earlier marathons which we have taken on this channel? Are you following that? Honestly, say yes or no. Honestly, you can say yes or no. Honestly. There is no need to bluff or something. Honestly, you can say yes or no. I just want to know that first. So majority have watched those marathons. That's great. That's wonderful. Perfect, guys. Perfect. Amazing. Amazing. All right. And few more things which I have planned for all of you. In the upcoming days, I have given you the schedule as well, right? There will be separate sessions for top 5-year PYQs for every subject, right? There'll be 3 sessions for that: physics, chemistry, biology. Sorry, 4 sessions, zoology, botany, separate. Apart from that, there are other things which we have planned, like top 1000 questions of PCB. That's going to be one more combined session, perfect, which we are going to take in upcoming days. And apart from that, it's not going to be only top 1000 PYQs. I mean, top 1000 questions of your PCB. There is a session which we have scheduled, right, in the upcoming days. That is going to be completely NEET replica. The way we discussed the NEET replica last year, in the similar way, we shall be discussing the NEET replica and NEET 2024 predicted paper as well. Okay? So in 3-4 days, your whole syllabus is getting completed. Then we'll come to those sessions. Perfect. Then we'll come to those sessions. All right, people. So should we start? Already, I would want some fire in the chats quickly. I would want some fire in the chats quickly. Quickly, guys. Quickly. I want the Josh to be high. And I want the chats to continuously run today. Okay? Are you all ready? Some fire emojis in the chats. Everyone. I should see the Josh in the chats first. Right? Perfect, guys. Perfect. Wonderful. Chalo then. Let's get going. Let's get started with the first chapter. And the first chapter is your mole concept. Right? My dear students, the first question, which is very simple and basic. You all must be knowing this. 1 atomic mass unit. 1 atomic mass unit. 1 atomic mass unit. First of all, if I talk about 1 AMU, 1 AMU is also what we call as 1U. 1U is what you call as 1D. And how exactly you are going to define this 1 AMU? You should know it. 1 AMU is defined as 1/12 of the mass of carbon-12 atom. 1/12 of the mass of carbon-12 atom. And let me tell you, this 1 AMU in grams is going to be 1.66 into 10 raised power minus 24 grams. Or you can write the same thing in terms of Avogadro's number. It is 1 divided by Na grams. Anything can be asked from this particular statement, which I have noted over here. Right? 1 atomic mass unit, which is also called as 1U, unified mass. D stands for Dalton. It is equal to 1/12 of the mass of carbon-12 atom. And its value in grams is going to be 1.66 into 10 raised power minus 24. Right? So what is the correct answer of this particular question? I would want your answers in the chats continuously. What is going to be the correct answer? It is 1.66 into 10 raised power minus 24 grams. Right? The first thing. And what is this 1 AMU here? 1 AMU is a standard. 1 AMU is the reference with which we compare the masses of different atoms. 1 AMU, let me tell you, it is a standard. It is the reference It is the standard. It is the reference with which we compare the masses of different atoms. Okay? Simple and basic. But yes, students, look at the second type of the question that can be asked. Second type of the question. Look at the question carefully. Look at the question carefully. Look at the question carefully. What mass of sodium chloride, what mass of sodium chloride would be decomposed by 9.8 grams of sulfuric acid if 12 grams of sodium bisulfate and 3.65 grams of hydrogen chloride were produced in the reaction? What do you think about this one? This is going to be theory plus problems. Wherever I would require theory, I'll be discussing theory with you. First of all, I would want you guys to read this particular question. It's a very simple and basic one. It might look different, but it's simple. Trust me on that. It's very simple. It is very simple. What do you think about this particular question? What do you think about this particular question? What do you think about this particular question? Quickly. Quickly, my dear students. Quickly, everyone, think over it. Think over it once. Think over it once. First of all, I'm going to write the reaction, and the reaction is simple like this. NaCl plus H2SO4. And as per the question, what does it form? It forms sodium bisulfate, NaHSO4. And with sodium bisulfate, what do we get? We get hydrogen chloride. This is the reaction that's given to us. Correct? Now, my dear students, if you look carefully, what mass of sodium chloride would be decomposed by 9.8 grams of sulfuric acid? Would be decomposed by 9.8 grams of sulfuric acid. If 12 grams of sodium bisulfate, and 3.65 grams of HCl are formed, right? Have you heard about law of conservation of mass? What is the law of conservation of mass all about? What is law of conservation of mass all about? In the reactions, if I talk about, mass of reactants has to be equal to mass of products. That's all, right? I can say mass of reactants, it has to be equal to mass of the products. Perfect. Let's say we have taken here the X grams of NaCl. So I'll be simply equating things, nothing else. So mass of reactants is going to be X plus 9.8 is equal to mass of products is just going to be 12 plus 3.65. Perfect. So from this particular equation, you can get the value of X, and X is the mass of NaCl which has participated in this particular reaction. I believe these sort of questions you should be able to solve on your own. Am I clear with this? Am I clear with this? So when you solve this particular equation, the value of X over here comes out to be 5.85 grams. 5.85 grams. Right, people? Right? Again, it was a very simple and the basic question. Okay. Look at this type of the question. These sort of questions can be easily asked as well. The number of atoms in 0.1 moles of triatomic gas. What is the triatomic gas? For example, I'm taking A3 gas over here. It is triatomic. Perfect. What is the example of the triatomic gas? Let's say you have got ozone. Ozone is the example of the triatomic gas. Ozone is the example of the triatomic gas. As per the question is concerned, you have got 0.1 moles of triatomic gas. So number of moles of the gas which is given to us, how much is that? That is 0.1. What are we supposed to calculate? The number of atoms present in 0.1 moles of triatomic gas. First of all, if we have 0.1 moles of the gas, can you let me know how many molecules of A3 will be having? Molecules of A3. How do we convert moles into molecules? Moles multiplied by Avogadro's number. It gives us molecules. So basically, in 0.1 moles of the gas, there will be these many molecules. Correct? Now you tell me one thing. In one molecule of A3, how many atoms are there? There are 3 atoms in total. One molecule of A3 contains 3 atoms. If one molecule of A3 contains 3 atoms, 2 molecules will contain, multiplied by 2. 3 molecules multiplied by 3. How many molecules do we have? 0.1 Na. So 0.1 Na molecules will contain 3 multiplied by 0.1 Na. The value comes out to be 0.3 Na atoms in total. Is it simple, guys? You can put the value of Na over here, which is 6.022 into 10 raised power 23, and get the exact value. Right? You can put the value of Avogadro's number here. I believe this sort of equation you can easily solve from now on. Whenever moles are given, right, and you have to calculate atoms, convert moles into molecules by multiplying by Avogadro's number, then at the end you can easily calculate the atoms. Perfect. So when you solve this, the correct value will come out to be option B. Moving ahead. Look at this type of the question. This is our fourth type of the question from the chapter mole concept. One atom of an element X weighs these many grams. Right? This is the mass of one atom of X. Number of moles in 20 kg of X. Number of moles in 20 kg of X. So we have to calculate number of moles of X. Number of moles of X. Right? As you know, number of moles is equal to given mass of the substance in grams divided by what? Divided by molar mass of substance. You know it. Given mass of substance in grams divided by molar mass of substance. Number of moles of X is equal to given mass of X, that is 20 kg, so it has to be 20,000 grams, right? 20,000 grams divided by. Are we given with the molar mass? We are not given with the molar mass of X. But let me tell you what is molar mass. If I write molar mass of X, what is molar mass? Molar mass is basically mass of 1 mole of substance. So molar mass of X means mass of 1 mole of X. Mass of 1 mole of X means mass of 6.022 into 10 raised power 23 atoms of X. Or I can say it is nothing but mass of 1 atom of X. Mass of 1 atom of X, and you need to multiply that with Avogadro's number. Now tell me, what is the mass of 1 atom of X? That is 6.6 into 10 raised power minus 23 grams. You just need to multiply it with 6.022 into 10 raised power 23. So this term cancel, and this will approximately come out to be how much? This will approximately come out to be how much? 6636, 6636, 39. So 39.6 grams. This is the molar mass of X. This is the molar mass of X. So you need to divide this particular term with approximately this particular term, right? And whatever value you get after solving, that is giving you the number of moles of X which I was supposed to calculate. Am I clear, people? Simple, I just use the formula. Number of moles is equal to given mass by molar mass. Mass is given as 20,000 grams. Molar mass I was supposed to calculate first of all, right? Well, I was not given with the molar mass directly. I was given with the mass of 1 atom of X. I multiplied that mass of 1 atom of X with the Avogadro's number. I got the mass of 1 mole of X. And mass of 1 mole of X is what you call as molar mass of X. So I divided it with molar mass of X and got the number of moles which I was supposed to calculate. So approximate answer is going to be 500 in this particular question, right? I believe I'm pretty much clear in this particular question as well. This was our type 4. My dear students, very simple and basic type. Very simple and basic type. Look at this carefully. Look at this carefully. Number of atoms of helium in 100 U of helium. We are given with 100 U of helium. 100 U of helium. We are not given with 100 grams of helium. We are given with 100 U of helium. Now, first of all, tell me, if I ask you, what is the atomic mass of helium? Atomic mass of helium is 4U. Atomic mass of helium is 4U. What does that mean? What does that mean? That means 4U is the mass of 1 atom of helium. 4U is the mass of 1 atom of helium. If I use the unitary method here, 4U is the mass of 1 atom of helium. Therefore, 1U is going to be the mass of 1 by 4 atoms of helium. The mass of 1 by 4 atoms of helium. Am I given with 1U in the equation? No, I'm given with 100U. So tell me, 100U will be the mass of 1 by 4 multiplied by 100. The value comes out to be 25 atoms of helium. So 100U is nothing. 100U means that you have got how many atoms of helium? You have got 25 atoms of helium. Correct? This is how you can solve this sort of equation as well. This was our type 6 or type 5. This was our type 6 or type 5. Okay. Look at this particular question, guys. Here you might do a mistake. Look at the question carefully. The question is the number of gram molecules. What is meant by gram molecules or gram atoms or gram ions? Gram atoms or gram molecules. Let me tell you that gram atoms, sometimes they'll give you gram molecules. Sometimes they'll ask about gram ions, right? This is nothing but these are the names of what? Moles. You call moles sometimes as gram atoms. You call moles sometimes as gram molecules. You call moles sometimes as gram ions. Correct? So remember, don't get confused whenever you get this sort of a question. Gram molecules means moles. So as per the question, the number of moles of oxygen, right? The number of moles of oxygen. We have to calculate number of moles of oxygen. In 6.02 into 10 raised power 24 CO molecules. How exactly you're going to solve this? Quickly have a look at the question. You should be in a position to solve this question, guys. See how exactly I'm going to solve this question. And this sort of a question can be asked again, right? Dear students, first of all, I'll be calculating the number of moles of carbon monoxide. The number of moles of carbon dioxide will be equal to given number of molecules divided by Avogadro's number. The value comes out to be 10. So these are the number of moles of what? These are the number of moles of carbon monoxide which we have. Now tell me one thing. If I'll be having 1 mole of carbon monoxide, in 1 mole of carbon monoxide, how many moles of O2 are there? See, I'll say in 1 mole of carbon monoxide, I'll say 0.5 moles of O2 are there. Is it clear? 1 mole of carbon monoxide contains 0.5 moles of O2. Or I can say it like this as well. 1 mole of carbon monoxide contains 1 mole of O. But here they have mentioned gram molecules. So I have taken oxygen in the form of O2. I hope I'm clear. 1 mole of carbon monoxide contains 0.5 moles of O2. Or I can say 1 mole of carbon monoxide contains 1 mole of O. Right? But here I have to take in terms of O2. Now you tell me, if 1 mole of carbon monoxide contains 0.5 moles of O2, therefore 10 moles of carbon monoxide will contain 0.5 multiplied by 10. The value comes out to be 5 moles of O2. 5 moles of O2. Or you can write, in place of moles, you can write 5 gram molecules of oxygen. 5 gram molecules of oxygen. This is something I was supposed to calculate, right? So the answer comes out to be 5 gram molecules. I believe this sort of a question can be done by you whenever it is asked, right? One more thing, people. If they ask you about the gram atoms, of oxygen, then you have to write here in terms of gram atoms. Then you have to write 1 mole of CO contains 1 mole of O, right? Therefore, 10 moles of CO will contain 10 moles of O. Perfect. If the question was calculate the gram atoms, then the answer will be 10 gram atoms. But here they are asking about gram molecules. Therefore, the answer is 5. I hope I'm clear to this particular question as well. This was one more type which can be asked. Right? This was one more type which can be asked. All right. One simple conceptual question. Guys. 3.011 into 10 raised power 22 atoms of an element weighs 1.15 grams. The atomic mass of the element is. Look at this. As per the question is concerned, look at it carefully. 3.011 into 10 raised power 22 atoms of an element. Let's say that element is X. Of an element has got the mass of 1.15 grams. Correct? Right? 3.011 into 10 raised power 22 atoms of X have got the mass of 1.15 grams. Therefore, what is going to be the mass of one atom of X if you use the unitary method? Mass of one atom of X is nothing but 1.15 divided by 3.011 into 10 raised power 22 grams. Right? Unitary method I'm using. This is the mass of one atom of X. How many atoms are we given with? We are given with these many, we are given with how many atoms? 3.011 into 10 raised power 22. Look again. 3.011 into 10 raised power 22 atoms of X. They have got the mass of these many grams. One atom of X have got the mass of these many grams. Therefore, 6.022 into 10 raised power 23 atoms of X. 6.022 into 10 raised power 23 atoms of X will have the mass of how much? 1.15 divided by 3.011 into 10 raised power 22 multiplied by 6.022 into 10 raised power 23 grams. Am I clear? Yes. My dear students, when you solve this, so this is 1, this is 2, right? This is 1 and this is 10 here. Perfect. When you solve this, the value approximately comes out to be 35.5 grams. Can you let me know what is the meaning of this 35.5 grams? Can you let me know quickly? Can you let me know quickly? Just a second. I did some calculation mistake. This will come out to be 23 grams. Can you let me know what is the meaning of this 23 grams? I would say this 23 grams, it is the mass of 6.022 into 10 raised power 23 atoms of X. So that means this is the mass of 1 mole of X. This is the mass of 1 mole of X, right? This is the mass of 1 mole of X. And mass of 1 mole of substance is what you call as molar mass. So this is the molar mass of X. I believe that's something which I was supposed to calculate. This is the molar mass of X, 23 grams. Now, if the molar mass of X is 23 grams, how do you convert molar mass into atomic mass? Just change the units. Just change the units. I'll write 23 AMU or 23 U. This is the atomic mass of X, right? If you want to convert atomic mass into molar mass or molar mass into atomic mass, you just need to change the units. When you talk about atomic mass, write the unit as U. When you talk about the molar mass, write the unit as grams. Nothing else. Right? Nothing else. This was one more type of question which can be asked. Right? Which can be asked. One simple and basic question which will make all of you happy. One simple and basic question which will make all of you happy. What do you think? What do you think, guys? Simple and basic question. Number of moles in 11.2 liters of carbon dioxide at STP. Everyone should at least answer this question. Quickly. Quickly, everyone in the chats. We are given with the volume of gas at STP. We are supposed to calculate its moles. Guys, is this question? Do you want me to solve this question? No, right? Number of moles is equal to given volume of the gas in liters divided by 22.4. The value comes out to be 0.5. Right? The value comes out to be 0.5. That's all. Okay. Look at this particular question. You would have seen these sort of questions as well in your books. Right? And these questions are comparatively time-consuming ones, you know it. The number of atoms in 558.5 grams of iron. So first of all, if I ask you how many moles of iron do we have? Given mass of iron in grams divided by molar mass of iron, right? The value comes out to be 10. I just calculated the number of moles of iron. If I ask you how many iron atoms do we have? Number of atoms of iron. Number of atoms of iron. I have calculated the moles. I'll multiply those moles by the Avogadro's number, right? So these many iron atoms do we have actually. Now, if you look at the first one, why is that 60 grams of carbon? If you look at the first option, 60 grams of carbon means how many moles of carbon? Given mass of carbon in grams divided by molar mass, right? The value comes out to be 5. These are the moles. Perfect. How many atoms do we have? How many atoms of carbon? Atoms of carbon will be equal to 5 multiplied by Avogadro's number. But he's asking about twice that in 60 grams of carbon. In 60 grams of carbon, you have got 5 Na. So 2 times that will come out to be 10 Na. So both the things are matching, correct? Both the things are matching. So what has to be my answer here? I'll stop here. It's going to be option A only, which is the correct answer of the question. Isn't it simple, guys? Isn't it simple and basic? Right? I am moving ahead to one more type of the question which can be asked. One more type of the question which can be asked. One more type of the question which can be asked. Okay, look at this one. You might do certain mistakes. Maybe in this type of the question. What do you think? What do you think? Let the molar mass of an element be A grams. The mass of 10 atoms of element would be. What do you think about this one? Think over it once. Think over it once. My dear students, molar mass of element A is A grams. Molar mass of element X is A grams. So, if I ask you, what would be the atomic mass of element X? What would be the atomic mass of X? I would say atomic mass of X, you just have to change the units as I told you. Instead of A grams, you have to write AAMU. Right? Now, this is the atomic mass of element X. This is the atomic mass. This is the mass of one atom of X. This is the mass of one atom of X. We have to calculate the mass of 10 atoms of X. If the mass of one atom of X is AAMU, the mass of 10 atoms of X will be simply 10 times AAMU. Right? This is the mass of 10 atoms of X. Do you see any option like that? Absolutely, option C is the one which is going to be the correct answer of this one. Right, people? Very simple and basic. Mass of one atom of A is AAMU. Mass of one atom of X is AAMU. So mass of 10 atoms of X will be 10 times AAMU. Simple. Got it? Got it, people? Got it? Got it, people? Quickly, quickly, quickly. Got it, everyone? So this can be one more type of question which can be asked, right? All right, if you look at this one, it's one basic question, but I want you to give it a try. Simple and basic question this is. Simple and basic question this is. Simple and basic question this is. You have got a mixture that contains 5.4 grams of aluminium, right? 1.2 grams of magnesium and 4.6 grams of ethyl alcohol, right? 4.6 grams of ethyl alcohol. So we are given with 5.4 grams of this, we are given with 1.2 grams of this, and we are given with 4.6 grams of ethyl alcohol. The ratio of their moles, we are supposed to calculate the ratio of their moles. We are supposed to calculate the ratio of their moles, right? How do you convert masses into moles? See guys, given mass of aluminium divided by molar mass, right? Given mass of magnesium divided by molar mass. Now, given mass of ethyl alcohol divided by, what is the molar mass of ethyl alcohol? Check it out. This is 24. 24 plus 5 is 29. 29 plus 1 is 30. 30 plus 16 is 46. 46, right? Correct, guys? Correct? This value, 5.4 divided by 27, it will come out to be 0.2, right? 0.2. 0.2 is to 1.2 divided by 24 will come out to be 0.05, and this value will come out to be 0.1. Now, if you look at the options are not in this manner. Tell me one thing. Which is the smallest value among all these three? Smallest value is 0.05. So I'll be dividing throughout by 0.05. I'll be dividing throughout by the smaller value. I've divided throughout by the smaller value. See what exactly I'll be getting. This value will be 4. This value will be 1. And this value will be 2. So 4 is to 1 is to 2 is going to be the correct answer of this particular question. So whenever you get the ratio in this format, take the smaller number, divide all these terms by the smaller number, you'll be getting the actual ratio in the whole number form. Right? This can be one more simple type of the question which can be asked from the chapter mole concept. All right. This I believe everybody would already know. You have got the element whose atomic number is 89 and its atomic mass is 231. We have to calculate proton, neutrons and electrons. Right? This is your atomic number. This is your, you'll say atomic mass. Perfect? Perfect? Quickly solve this, people. What do you think about this one? Quickly. See guys, in one atom of Y, if you ask me how many electrons are there, right? How many electrons are there? You'll say there'll be 89 electrons. There'll be 89 protons as well, right? Whatever is the atomic number, same is the electrons, same is the protons, if the atom is neutral. But what is the mass number? What is the number of neutrons? How do you calculate number of neutrons? Mass number minus atomic number. So it is 231 minus 89. This will give you the number of neutrons, right? Whatever is the atomic number, same electrons, same protons. But neutrons will be mass number minus atomic number. You should be knowing it. You should be knowing it. So when you solve this, this is going to be the final answer which you get, which I can see majority of the students already wrote. Okay, this was one simple and basic question, I would say. Now, this sort of a question frequently you would have solved, and this sort of a question frequently is asked as well. The question is, we are given with the element iron. We are given with the element iron, and iron has got how many isotopes? Iron has got 3 isotopes, as you see over here. Iron has got 3 isotopes. One is Fe54, one is Fe56, and one is Fe57. Iron has got 3 isotopes, correct? As per the question is concerned, the percentage abundance of these isotopes is also given. Percentage abundance. This is 5%, this is 90%, and this is 5%, right? What are we supposed to calculate? We are supposed to calculate average atomic mass of this particular iron, MAV. How do you calculate it? Whenever the element, I hope you remember, whenever the element exists in the form of isotopes, we do not calculate the normal atomic mass of element. What do we calculate? We calculate average atomic mass of element. And that average atomic mass of element is calculated with the help of formula M1A plus M2B plus M3C divided by what? Divided by A plus B plus C, which is always 100. So in the denominator, it's always 100. So people, if you look carefully, this is the value of M1, this is the value of M2, this is the value of M3, this is the value of A, this is the value of B, and this is the value of C. Correct? So MAV is equal to M1. M1 is 54, right? A is 5. M2 is 56. B is 90. M3 is 57. And C is 5. Divided by A plus B plus C is 100. So MAV, when you solve it, how much it comes out to be? People are coming up with the option B. When you solve this, absolutely you'll be getting the final answer as 55.95 AMU. That is the average atomic mass of this iron, which I was supposed to calculate. Right? Am I clear, people? Am I clear? Am I clear? Am I clear? This sort of a question you should be able to solve from now on. Even these sort of questions are asked frequently. I'm giving you one more similar type of question, but over here, differently you have to approach. Chlorine exists in 2 different isotopic forms, right? Average atomic mass of chlorine is given. The ratio of Cl37 and Cl35 is approximately. Quick, people, quick. You should be solving this particular question as well. It is a similar type of question. Chlorine, it exists in 2 different isotopic forms as per the question is given. One is Cl35, one is Cl37. Correct? One is Cl37. Average atomic mass of chlorine is also given. How much is that? 35.5 AMU. This is the average atomic mass of chlorine. Perfect. My dear students, let the abundance of this particular isotope is X. Therefore, this will be 100 minus X. Right? Because the sum of percentage abundances of all the isotopes of a particular element, that's always 100. That is always 100. The sum of isotopes, the sum of percentage abundances of all the isotopes of a particular element, that's always 100. That is always 100. Now, if you use the formula, this is the value of M1, this is the value of M2, this is the value of your A, and this is the value of your B. Perfect. The formula is MAV is equal to M1A plus M2B divided by A plus B. It is equal to 35.5. It is equal to 35.5. Now, M1 is nothing but 35, right? A is equal to what? A is equal to X. M2 is 37. B is equal to 100 minus X. Divide by what? Divide by A plus B is 100. The value comes out to be 35.5. When you solve this particular equation, you get the value of X over here as 75. And you get the value of 100 minus X here as 25. If you take the ratio over here, ratio will be how much? It'll be 3:1. It'll be 3:1 because this will be 1, this will be 3, right? So ratio over here will be 3:1, which I was supposed to calculate. This sort of a question you can get in your examination, right? Perfect. Well, I gave you the ratio of 3:1. This is the ratio of Cl35:37. Cl35:37. But in the question, we are asked reverse. Cl37:35. So 37 is to 35 will be 1 is to 3. It will be 1 is to 3. Okay? Be careful with all these things as well. Be careful with all these things as well. They might play, right? See, you did the question correctly, right? But at the end, you have to see, first of all, what ratio they are asking. Are they asking about 35 is to 37 or 37 is to 35? Accordingly, you note down your answer. Right? They can play with all these things as well. All right. Okay, this sort of a question you can easily get, right? The percentage of oxygen in CH2O. My dear students, remember one thing, whenever in the question, whenever they do not mention it, like what kind of percentage? Is it percentage by mass? Is it percentage by moles? Like whenever you are not given with the clear information, assume that it is percentage by mass. It is percentage by mass. Now, let me give you one result. You know, percentage of an element in a compound. How do you calculate it? Remember the formula from now onwards. Percentage of an element in a compound is equal to molar mass of the element multiplied by Z. What is Z? I'll let you know in some time. Divided by molar mass of compound multiplied by 100. What is Z over here? Remember, this Z is equal to the number of moles of atoms. Number of moles of atoms of the element in 1 mole compound. What is meant by this? In 1 mole compound, what is meant by this? Try to understand. In this question, we are supposed to calculate percentage of what? Percentage of oxygen. Percentage of oxygen by mass is equal to molar mass of oxygen, 16 grams, right? Tell me, in 1 mole compound, how many moles of O are there? In 1 mole compound, there is 1 mole O. In 1 mole compound, there is 1 mole O divided by. What is the molar mass of this whole compound? Molar mass of this whole compound. This is 12. 12 plus 2 is what? 14. 14 plus 16 is 30. So divide by 30. Multiply it with 100. You'll be getting the percentage of oxygen here in the given compound. As simple as that. Right? So people are saying it is coming out to be, right, 53. So absolutely it has to be 53. Simple question, basic question this is. Right? It is just, you need to remember the formula, that's all. It is just, you need to remember this particular formula. So whenever you see this sort of equation, remember this formula and try to solve this. That's all. That's all, my dear students. Okay. Look at one more type of question which can be asked. My dear students, as per this particular question is concerned, what volume of O2 measured at 0 degree and 1 atm is needed to burn 1 liter of propane under the same conditions? So you are doing the combustion of propane. What is the formula for propane? C3H8. You are doing its combustion. You know, when a hydrocarbon undergoes combustion, what are the products do we get? Products over here will be carbon dioxide plus water. Right? Whenever your hydrocarbon, it undergoes combustion. Perfect. Its end products will be carbon dioxide plus water. Right? It will be carbon dioxide plus water. You should know it now. Now, my dear students, if you balance this particular reaction, you'll write this as 3 times, you'll write this as 4 times, and this has to be 5 times. And over the stoichiometric coefficient is 1. Now the reaction is given in the balanced format. If the reaction is given in the balanced format, stoichiometry is telling you that 1 liter of propane requires 5 liters of oxygen for the complete combustion. Right? 1 liter of propane requires 5 liters of oxygen for the complete combustion. What was asked? What volume of O2 is required? So I'll say for the complete combustion of 1 liter of propane, I would say 5 liters of O2 are required. Done and dusted, nothing else. Right? Simple stoichiometry you'll use and kill the question. Isn't it simple, guys? Isn't it very simple? Okay. All right, this is one more type of question which can be asked. I'm giving you different types. I'm not repeating the types. These are different problem patterns. These are different problem patterns. As per the question is concerned, if 0.3 moles of zinc is added to 0.52 moles of HCl, how many moles of H2 is produced? Look at the question. Let me write the reaction first of all. The reaction is pretty much simple. Your zinc solid plus 2 times HCl aqueous. What does it give? It gives ZnCl2 aqueous plus what? Plus H2 gas. Plus H2 gas. Right? Plus H2 gas. Okay. Now, my dear students, at time t is equal to 0. At time t is equal to 0. How many moles of zinc are we given with? 0.3 moles. Understand how I'm going to solve this question? How many moles of this are we given with? 0.52 moles. Now tell me, since I have written time t is equal to 0, that means the reaction has not started. If the reaction has not started, that means product formation right now will be 0. Now, my dear students, remember, whenever in a reaction you are given with the amounts of all the reactants, whenever in a reaction you are given with the amounts of all the reactants, at that point of time, you will use the concept of limiting reagent. At that point of time, you'll use the concept of limiting reagent. Whenever in a question, amounts of all the reactants will be given. These amounts can be in terms of moles, in terms of mass, in terms of volume, in terms of particles, whatever. Whenever the amounts of all the reactants are given, you'll be using the concept of limiting reagent, right? And my dear students, in the limiting reagent concept, we try to balance the reaction first. The reaction is balanced. Now, it is the time to identify the limiting reagent. How do we identify the limiting reagent? Given moles divided by their stoichiometric coefficients. Have a look. 0.3 divided by 1. 0.3 divided by 1. That comes out to be 0.3. 0.52 divided by 2. That comes out to be 0.26. Which value is lesser? This value is lesser. The one which gets the lesser value, that is the limiting reagent. So HCl here is the limiting reagent. Simple trick. Given moles by their respective stoichiometric coefficients. Right? Now, you got to know HCl is the limiting reagent. If HCl is the limiting reagent, it would have got completely consumed. So I'll be left with nothing. I'll be left with nothing. My dear students, in the reaction, the entire product formation is decided by the limiting reagent. Limiting reagent is the one which decides the entire product formation, right? So basically, at the end of the reaction, if you need to check how many moles of H2 have got formed, limiting reagent is going to give you that idea. How exactly? See, use the stoichiometry. This is 2 here, this is 1 here. Can I say 2 moles of limiting reagent gives 1 mole of H2? 2 moles of limiting reagent gives 1 mole of H2. Therefore, 1 mole of limiting reagent should give 1 by 2 moles of H2. Therefore, 0.52 moles of limiting reagent should give 1 by 2 multiplied by 0.52. The value comes out to be 0.26 moles of H2. So we got to know 0.26 moles of H2 would have got formed at the end of the reaction. Isn't it simple? Can you let me know how many moles of ZnCl2 would have got formed? You can do that as well. You can calculate the moles of zinc which will be left in the container as well. Perfect. Why a lot of adds are coming in between? Perfect, guys. So this is how you solve the question of the limiting reagent. Perfect. So by the way, one more thing. It is not necessary they'll ask you to calculate the moles of H2. They can ask you to calculate the molecules of H2. Once you calculate moles, multiplied with Avogadro's number, you'll be getting the molecules. They can ask you to calculate the volume of H2 at STP. You got the moles, multiplied by 22.4 liters, you can get the volume. Correct? Anything can be asked. It is just you should find the data for moles. Once mole data is calculated, then everything can be easily sorted out. I hope I'm pretty much clear to everyone. This was one more type of question that can be asked, right? Now, similarly, guys, one more type of the question which can be asked. One more type of the question which can be asked. Look at the question carefully. Calculate the minimum mass of Cl2. Calculate the mass of Cl2. So that means I would calculate moles first, then multiply those moles by the molar mass. Okay. Calculate the minimum mass of Cl2 in grams required to produce 37.25 grams of KCl. Required to produce 37.25 grams of KCl. See how exactly you're going to approach this sort of a question. Calculate the minimum mass of Cl2 which is required. to produce 37.25 grams of KCl. 37.25 grams of KCl. First of all, what is your given quantity? You are given with the mass of KCl. You are given with the mass of KCl. First of all, let me convert the given quantity to number of moles. Right? Let me convert the given quantity into number of moles. So number of moles of KCl is equal to given mass of KCl divided by molar mass of KCl. The value comes out to be 0.5. So as per the question, you can say it like this. 0.5 moles of KCl should get formed. As per the question, 0.5 moles of KCl should get formed. And in order to form 0.5 moles of KCl, what is the mass of Cl2 that is required? See exactly how I'm going to solve this. Stoichiometric coefficient here is 1, here is also 1. Can I say 1 mole KCl? As per stoichiometry, I got to know 1 mole KCl is produced from 1 mole Cl2. Do you agree with this? Stoichiometry is telling me that 1 mole KCl is produced from 1 mole Cl2. Therefore, as per the question, 0.5 mole KCl will be produced from 0.5 mole Cl2. From 0.5 mole Cl2. So can I say 0.5 moles of Cl2 are required? 0.5 moles of Cl2 are required to produce 0.5 moles of KCl. But as per the question, am I supposed to calculate moles of Cl2? No. What am I supposed to calculate? I am supposed to calculate mass of Cl2. Do you know how to convert moles into mass? Yes, you know it. So mass of Cl2 required is equal to moles of Cl2 required multiplied by molar mass of Cl2, 71 grams. The value comes out to be 35.5 grams. So I would say 35.5 grams of Cl2 are required to produce these many grams of KCl, these many moles of KCl. This sort of a question can also be asked. I hope this particular type of the question is clear to you. Right? Is clear to you? Now guys, a question can be asked on the percentage yield of the reaction as well. A particular type of the question can be asked on percentage yield of the reaction. That is one more topic which you find in the mole concept, right? And my dear students, let me first of all tell you how do we calculate the percentage yield. Once you get to know how to calculate the percentage yield, then you can solve the question easily, right? Try to understand. Try to understand what I'm going to say. I'll write the formula first of all. Percentage yield of the reaction is equal. Percentage yield in the reaction is equal. Experimental amount, which is what you call as actual amount as well, divided by expected amount, which is what you call as theoretical amount as well, multiplied by 100. This is the formula first of all. This is the formula first of all. Now. If you look at the question, from the question itself, I'll make you understand what experimental amount means and what expected amount means. Remember it like this. Experimental amount is that amount which is given to us as per the question. Experimental amount is that amount which has been observed in the lab, which has been seen in the lab by carrying out certain experiments. So in short, remember one thing, experimental amount, this will be given to you as per the question, right? Expected amount we will try to calculate with the help of stoichiometry. We'll try to calculate with the help of stoichiometry. And how exactly? See, methylation of benzene. Methylation of benzene. When you do the methylation of benzene, what do you get? You get toluene, right? You get toluene. Perfect. When you do the methylation of benzene, what do we get? We get toluene. Perfect. Now, my dear students, what did I do? I did the methylation of it. Perfect. As per the question is concerned, methylation of 10 grams of benzene, gives 9.2 grams of toluene. This is something which is given to us as per the question. So question is only telling you, when we do the methylation of 10 grams of benzene, you get 9.2 grams of toluene over here. So this is the data which we got from the question. So it has been seen in the lab. It has been seen in the laboratory that when 10 grams of benzene undergoes methylation, 9.2 grams of toluene is formed. So this is something which has been experimentally observed. This is your experimental amount. You got the experimental amount. Now what do we have to calculate? Expected amount. How do we get the expected amount? With the help of stoichiometry. And how exactly? Try to understand, guys. Simple and basic. Stoichiometric coefficient here is 1, here it's 1. Can you let me know what is the mass of 1 mole of benzene? Mass of 1 mole of benzene means molar mass of benzene, which is 78 grams. Mass of 1 mole of benzene means 78 grams of benzene. Can you let me know the mass of 1 mole of toluene? 1 mole of toluene means, mass of 1 mole of toluene means molar mass of toluene. How much will be the molar mass of toluene? How much will be the molar mass of toluene? See, C6 means 72, 72 plus 5 is 72 plus 5 is 77, 77 plus 3 is 77 plus 3 is 80, 80 plus 12 is 80 plus 12 is 92 grams. So 92 grams is the molar mass of toluene. 92 grams is the molar mass of toluene. My dear students, if I use a stoichiometry is telling me that 78 grams of benzene, when it undergoes methylation, 92 grams of toluene should get formed. Therefore, 1 gram of benzene should produce 92 divided by 78 grams of toluene. Therefore, 10 grams of benzene should produce these many grams of toluene. Right? So what is this particular term? I'm telling you, this is the mass of toluene which should have got formed. This is the mass of toluene that should have got formed. Right? So this amount, this particular amount which I got from here, which is 920 divided by 78, this amount is something which I call as expected amount. This is something which I was expecting to get formed with the help of stoichiometry. This is my expected amount. This is my experimental amount. So what is the yield? Yield will be expected amount divided by expected multiplied by 100. Right? Experimental amount divided by expected multiplied by 100. We are done. And when you solve this exactly, 9.2 divided by this multiplied by this, at the end you get the answer as 78%. Am I clear, people? Say yes or no once. This was one more type of the question which can be asked. Okay? Which can be asked. One more type wherein you might do a mistake. Can you look over this particular question carefully? Quickly, guys. Everyone. Quickly, guys. Done? Done. It is simple, guys. 0.44 grams of the colorless oxide of nitrogen occupies 224 ml at STP. The molecular formula will be. It's a simple and basic question. See how. As per the question, 224 ml of the gas has got the mass of 0.44 grams. 224 ml of the gas has got the mass of 0.44 grams. Tell me, what is the mass of 1 ml of the gas? Mass of 1 ml of the gas will be this much. It will be this much. So what is the mass of 22400 ml of the gas? 0.44 divided by 224 multiplied by 22440, right? So this value comes out to be 44 grams. What is meant by this 44 grams? This is the mass of 22400 ml of the gas. I'll say this is the mass of 1 mole of the gas. This is the mass of 1 mole of the gas. This is the mass of 1 mole of the gas, right? And the mass of 1 mole of the gas is what you call as molar mass of the gas. So this is the molar mass of the gas. This is the molar mass of the gas. Tell me which of the 4 options, right, has got the molar mass of 44. Quickly. If you look at N2, this is 14, 14, 28, 28 plus 16 is 44. Done. Dusted, right? Isn't it simple? Isn't it simple, guys? Perfect. Absolutely done. Wonderful. Good job done. Okay. This is one more type of question which can be asked. But before solving this question, remember this particular reaction. If you take the hydrocarbon, if you do its combustion, it always leads to the formation of carbon dioxide and water. Now, how do you balance this? There's a particular way of balancing this. This is X, so this has to be X here. This is Y, this has to be Y by 2 here. And the coefficient of O2 has to be X plus Y divided by 4. This is the general way of balancing this particular reaction, number one. Number two, if you have got the reaction in this format, CXHYOZ, CXHYOZ, and if you are doing its combustion, you lead to the formation of carbon dioxide, and with that carbon dioxide, you get water. If this is X, make the coefficient here is X. If this is Y, make the coefficient here is Y by 2. What will be the coefficient of O2 here? It will be X plus Y by 4 minus Z by 2. This is how you balance these sort of reactions. You need to remember them directly. The way I have remembered, in the similar way, you have to remember it as well. Okay? Now, I'll be solving the question. I hope you have taken a note of it. Now I shall be solving the question. Understand? We are taking butane, C4H10. We are doing its combustion and it leads to the formation of what? Carbon dioxide, and with carbon dioxide you get water. It's time to balance the reaction first. How do we balance it? This is 4, X is 4, so 4. Y is 10, 10 by 2 is 5, right? X plus Y by 4. 4 plus 10 divided by 4. So 4 plus 5 divided by 2. 4 2s are 8, 8 plus 5 is 13. So 13 by 2 is the coefficient. X plus Y by 4. Now the question says, for the combustion of benzene, 72 grams of water is produced. As per the question, 72 grams of water is produced. That means how many moles of water is produced? Mass of water produced divided by molar mass of water. So as per the question, 4 moles of water is produced. 4 moles of water is produced, right? The amount of butane taken initially is, in order to produce 4 moles of water, how much butane is consumed here? How much butane was taken here? That is the question. Use the stoichiometry. Stoichiometry coefficient here is 1, and it is 5. Can I say, as per stoichiometry, 5 moles of water are produced. 5 moles of water are produced from 1 mole butane. From 1 mole butane. Therefore, 1 mole water is produced from 1 by 5 moles butane. Therefore, 4 moles of water are produced from 1 by 5 multiplied by 4. So 0.8 moles of butane. So as per the question is concerned, 0.8 moles of butane, 0.8 moles of butane are required to produce 4 moles of water. 0.8 moles of butane are required to produce 4 moles of water. 0.8 moles of butane are required to produce 4 moles of water. Now tell me, are we supposed to calculate moles of butane? No, we are supposed to calculate mass of butane. Do you know how do we convert moles into mass? I'll say mass of butane is equal to moles of butane multiplied by. What is the molar mass of butane? Molar mass of butane. 12 into 4 is 36. 36 plus 10 is? 36 plus 10 is 46. So multiplied by 46. Solve it. This is the mass of butane which is taken initially. Right, people? So even this sort of equation should not be a problem for you when it is asked. Right? The questions based on stoichiometry is done and dusted. Okay. Just a second. One good question I'm giving you. One good type of the question. A good one. A good one. Look at the question carefully. 50 ml of 20.8% weight by volume BaCl2 and 100 ml of 9.8% weight by volume H2SO4 solution are mixed. The molarity of SO4 die negative in the final solution. Remember the procedure of solving, guys. Remember the procedure of solving. Understand how exactly I'm going to approach to this sort of equation. Remember how I'm going to approach to this sort of equation. As per the question is concerned, you have got BaCl2. BaCl2 aqueous. You are making it to react with H2SO4. You are making it to react with H2SO4. So first of all, they'll react for sure. What they are going to form? They are going to form BaSO4. And remember, BaSO4 is a solid. BaSO4 plus HCl. BaSO4 plus HCl. And I'll say it's going to be 2 times HCl. This is the reaction, first of all. Yes, this is the reaction. This is the reaction. Now, before solving the equation, can you let me know the molarity of BaCl2 solution here? Do you remember one result I had given you? Molarity is equal to 10 multiplied by weight by volume percentage of solute divided by molar mass of solute. I hope you remember this result. Perfect. Weight by volume percentage over here is given, right? Weight by volume percentage of BaCl2 is given. Molar mass of BaCl2, let me find molar mass of BaCl2. I don't exactly remember. Just a second. Molar mass of BaCl2 is 208. Okay, let's use this. Is 208. This is 208. This is 208. So this particular term is given, this particular term is given, right? Multiplied by 10. So let's try to solve it first of all. It is 10 multiplied by weight by volume is 20.8 divided by 208. So the value is 1. So basically, molarity of this particular solution is 1. Molarity of this particular solution is 1. What is the volume of this particular solution? Volume of this particular solution is 50 ml. Correct? So first of all, I calculate the molarity of the first solution. What is the molarity of H2SO4? Molarity of H2SO4 will be 10 multiplied by weight by volume percentage, that's 9.8, divided by molar mass of H2SO4 is 98. The value comes out to be 1. So its molarity is also 1. And its volume is given as 100 ml. So first of all, my dear students, what I did, I calculated the molarity of both these solutions. Right? I calculated molarity of both these solutions. How did I calculate molarity? Molarity is equal to 10 multiplied by weight by volume percentage of solute divided by molar mass of solute. Okay. Now try to understand. Molarity multiplied by volume in ml. Remember, molarity multiplied by volume in ml, that gives me millimoles of solute. Right? So this multiplied by this will give me the millimoles of BaCl2, which comes out to be 50. So basically, I am given with 50 millimoles of BaCl2. How many millimoles of H2SO4 am I given with? This multiplied by this 100. 100 millimoles of H2SO4. Initially, this will be 0, this will be 0, right? Both of them will be 0 initially. Now, people, if you look carefully, I calculated the millimoles of both of them. I calculate millimoles of both of them. If I ask you one thing, which concept am I going to use now? You should know, I told you, whenever the amounts of all the reactants are given, we use the concept of limiting reagent. Now, my first point is here to identify the limiting reagent. How do I do that? Millimoles by stoichiometric quotient, 50 by 1, 100 by 1. This value comes out to be less, so BaCl2 is my limiting reagent. If BaCl2 is limiting reagent, it's completely consumed. I'll be left with nothing. After some time. Right? Now, guys, understand. 1 mole reacts with 1 mole. So 50 millimoles would have reacted with 50 millimoles. I have taken 100. Out of 150 are reacting. So I'll be left with 50 millimoles. So 50 millimoles of H2SO4 will be left in the container at the end. Right? Similarly, 1 mole gives 1 mole. So 50 millimoles would have given 50 millimoles. Similarly, 1 mole gives 2. 50 would have given 100 millimoles. 100 millimoles of HCl. Now, finally, when the reaction has stopped, what all things are in the container? We are left with 50 millimoles of H2SO4. We are left with 50 millimoles of BaSO4 have got formed. 100 millimoles of HCl have got formed. So these are the things which are finally present in the container. Right? What do we have to calculate? We have to calculate molarity of SO4 dinegatives. My dear students, this is in solid form. BaSO4, it is the precipitate which has settled at the bottom. And this precipitate, it does not contribute towards the molarity of ion. It has settled. So I've got nothing to do with this. I have to do only with the things which are present in aqueous phase. What do I have to calculate? Molarity of SO4 dinegatives. In the container, there are 50 millimoles of H2SO4 left. I'll say the remaining H2SO4 which is left, it would have got dissociated into its ions. So I was left with 50 millimoles of H2SO4. This will be 0, this will be 0. Now this is 0, this is 100, and this will be 50. Correct? Its contribution towards SO4 dinegatives is nil, nothing. It is not going to give SO4 dinegatives. Only this will give, only H2SO4, the remaining H2SO4, only it will give SO4 dinegatives in the final solution. This is not going to contribute because this is precipitate. Now, the millimoles of SO4 dinegatives in the final solution. millimoles of SO4 dinegatives in the final solution is equal to 50. Therefore, molarity of SO4 dinegatives will be equal to millimoles of SO4 dinegatives divided by total volume in ml, that is 100 plus 50, that comes out to be 150. The value is 1 upon 3. 1 upon 3 is 0.33. Even this sort of a question can be asked. Did you get the idea of how exactly I solved this particular question? I just want yes or no in the chats quickly. I just want yes or no in the chats quickly. I just want yes or no in the chats. This sort of a question can also be asked. This sort of a question can also be asked. Right? Right, people? One simple and basic question. One simple and basic question. 14.2 grams of Na2SO4 is present in 10 raised power 2 kg of water. Its concentration in ppm should be. Its concentration in ppm should be. My dear students, if you remember, how do we calculate ppm of solute? How do we calculate ppm of solute? ppm of solute, simple result. Mass of solute in grams divided by mass of solution in grams multiplied by 10 raised power 6. Multiplied by 10 raised power 6. Right? Multiplied by 10 raised power 6. Multiplied by 10 raised power 6. Right? Okay. Now, can I write it like this as well? Mass of solute in grams divided by mass of solution means mass of solute plus solvent. Mass of solute plus solvent multiplied by 10 raised power 6. What is the mass of solute? 14.2 grams divided by what is the mass of solution? This plus this. How much that comes out to be? 10 raised power 2 kg. That means 10 raised power 5 grams. This is your solvent. 10 raised power 5 grams. Solute is 14.2 grams. Right? So I'll say 14.2, it is far less than this term. So mass of solute plus mass of solvent will be approximately written as mass of solvent. 10 raised power 5. 10 raised power 5, right? Multiplied by 10 raised power 6. The value comes out to be 142 ppm. Isn't it simple? Guys, do not indulge in the calculation here. Do not write the mass of solution exact value 10 raised power 5 plus 14.2. That is going to make the calculation worse. Right? Just do one thing. Do the neglection. That's all. Do the neglection. That's all. That's all, people. That's all. Okay. One more type of the question which is frequently asked. An aqueous KCl solution has the density of this much. Molality of this much. Calculate its molarity. My dear students, there is one direct result which you can remember. Molality is equal to 1000 multiplied by molarity of the solution divided by 1000 multiplied by density of solution minus molarity multiplied by molar mass of solute. This is the result which all of you should know from now onwards. Whenever in a question molality is given, molarity is calculated, or molarity is given, molality is calculated, this is the result which you have to remember. Okay. As per the question, molality is given as 3.3 is equal to 1000. Molarity has to be calculated divided by 1000. Density of solution has to be given 1.2 minus molarity, I'm supposed to calculate multiplied by molar mass of solute, molar mass of KCl, that is 74.5 grams per mole. So this is one equation, one unknown. From this particular equation, just cross multiple things and get the molarity of the solution. Right? This is one more type of equation which can be asked in the mole concept, and when you solve it, the answer comes out to be option A. Am I clear? Am I clear, people? Am I clear? Am I clear? Look at one more. This is asked question as well. If 3.01 into 10 raised power 20 molecules are removed from 98 mg of H2SO4, calculate the moles of H2SO4 left. So how many milligrams? We are given with these many milligrams of H2SO4, which is 98 into 10 raised power minus 3 grams. These many grams of H2SO4 are given to us. So if I divide it with molar mass, that means these are the moles of H2SO4 which were given to us. These are the moles of H2SO4 that were given to us. Now, you are removing how many molecules? 3.01 into 10 raised power 20 molecules. If I divide this with Avogadro's number, these are the moles of H2SO4 which are removed. I was given with these many moles of H2SO4. I'm removing these many moles. So this minus this. Is this going to give me the number of moles of H2SO4 left? Yes, it's going to give me number of moles of H2SO4 left. Simple, guys. Nothing you have to do here. Just a matter of calculation and we are done. Right? Moles of H2SO4 left will be this minus this. The answer will be 0.5 into 10 raised power minus 3. As simple as that. Perfect. Okay. There can be one question directly based on empirical molecular formula. You have got an alcohol that contains carbon, its percentage is given. Hydrogen, its percentage is given, right? Carbon, its percentage is given. Hydrogen, its percentage is given. Therefore, this plus this is not coming out to be 100. If this plus this is not coming out to be 100, there has to be one more element. And as per the options are suggesting the other element has to be oxygen. So what will be the percentage of oxygen? Percentage of oxygen will be 100 minus this plus this. 100 minus this plus this, right? So first of all, you will be calculating the percentage of all these elements. You got the percentage, right? Got the percentage. Now, divide these percentages by their respective atomic masses. 40 divided by atomic mass of this, 6.7 divided by this divided by this, right? This divided by this. You got the value exactly as 3.33, 6.7, 3.33. Now tell me which is the least number among all these three. 3.33 is least. So divide throughout by 3.33. When you divide throughout by 3.33, this will 1, this will be 2, this will be 1. So 1 is to 2 is to 1 is the simplest whole number ratio. And it's going to be the empirical formula. That's all. So there is a simple procedure to be followed. Number 1, whatever percentage is given, divide with the atomic mass. You'll be get the atomic ratio. Now, what do we get? Whatever numbers we get, the least number, all the numbers you are going to divide with the least number, you'll be getting the simplest whole number ratio. Simplest whole number ratio means the empirical formula. I hope I'm clear. Similarly, you can solve this sort of equation as well. You are given with the compound which has got element X and Y. Their percentage is given, I believe, 50%. This is also 50. First thing, divide the given percentage by the respective atomic weights. So 50 divided by atomic mass of X is 10. 50 divided by 10 is 5. This 50 divided by 20 is 2.5. Which one is least? 2.5. So I'll be dividing this with 2.5. I'll be dividing this with 2.5. This value comes out to be 2. This value comes out to be 1. So X2, Y1 is the empirical formula. X2, Y1 is the empirical formula. That's all. That's all, people. Right? That's all. So these were the different types of the questions which can be asked from the chapter mole concept. Am I clear to everyone? Am I clear to everyone? Am I clear to everyone, people? Am I clear to everyone? Say yes or no in the chats. Everyone in the chats, quick. Quickly, people, everyone. Yes? Perfect. This was your mole concept. This was your mole concept. This was your mole concept. All the questions done and dusted? Should we move on to one more chapter? Should we move on to one more chapter? I want everyone to say it in the chats. Let's move on to the chapter redox reactions. Okay. Again, in this particular chapter, I'll be giving you those questions which are going to be asked. Right? Those questions which can be asked in the upcoming NEET 2024. All those types of the questions. Let's start with the first question which is on your screen. And this is the asked question, by the way. This is the asked question, by the way. Look at the question carefully. Look at the question carefully. What is the change in oxidation number of carbon in the following reaction? What is the change in the oxidation state of carbon in the following reaction? You tell me this question. I'm not going to solve this. You only tell me the answer of this question. Oxidation state of carbon here. See, if the oxidation state of carbon here is X, right? Hydrogen will show +1. There are 4 hydrogen atoms. Net charge is 0. So the value of X is -4. So carbon here is in +-4 oxidation state. If you talk about the oxidation state of this carbon, let it be X. Chlorine is more electronegative, so -1. There are 4 chlorine atoms. Net charge is 0. So X value is +4. So -4 to +4. -4 to +4 is the change in the oxidation state of carbon in this particular reaction. It is simple. Basic question. Again, one question which was asked in NEET 2020, the same year. The oxidation number of underlined atom in the following species is given. Identify the incorrect option. Identify the incorrect option, people. What do you think is the incorrect option among all? Think over it. Think over it. Think over it. Think over it. This is Cu2O here, right? If you look at it carefully, this is Cu2O, right? You would have studied in class 8, 9, crisscross thing. This one has to be the charge here. This 2 has to be the charge here. The oxidation state of copper here is +1, but they have mentioned it as -1. So this is incorrectly matched. This is incorrectly matched, right? Just crisscross it and get to know. That's all. That's all, right? That's all. That's all. This is one more question which was based on oxidation state. So you can expect a lot of questions from oxidation state. Oxidation state of chromium in CrO6. 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 This is the structure. Remember it? Butterfly is CrO5. This is CrO6. This is CrO6. Now, between chromium and oxygen, which one is more electronegative? Oxygen. So it will have -1. This will have +1. Again, due to this particular bond, -1, +1. Due to this 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 bond, -1, +1. So the total charge on chromium here is 1, 2, 3, 4, 5, 6. So +6 is the oxidation state of chromium in CrO6. In CrO6. In CrO6. Look at this particular question. Again, the question asked in 2019, right? Which of the following reactions are disproportionation reactions? How do you check whether the substance is undergoing disproportion or not? Let's say I've got A2 here. It gives A positive plus A negative. Let's say its oxidation state here is 0. Here it is +1. Here it is -1. 0 to +1 means increase in the oxidation state. 0 to -1 means decrease in the oxidation state. Whenever oxidation state of same element increases as well as decreases simultaneously. Increases as well as decreases simultaneously. Whenever oxidation state of same element increases as well as decreases simultaneously, we say that element undergoes disproportionation. Disproportionation. Look at the reactions now. The first reaction says that you have got Cu positive. It gives Cu di positive plus Cu. So it is +1 here. This is +2. This is 0. So +1 to +2 means increase. +1 to 0 means decrease. So oxidation state of same species is increasing as well as decreasing simultaneously. So this is undergoing disproportionation. So 1 is the answer. 1 is the answer. 1 is the answer. Right? 1 is the answer. Perfect. So it is option 1, option 2. In both these options, 2 is given. So let me not check 2. 2 automatically is. 2 automatically is because 2 is given here. Now let's check 3. Let's check 3. KMnO4, manganese oxidation state, when you calculate it's +7. Here, it's going to be how much? +6. Here, it's going to be +4. So +7 to +6, decrease. +7 to +4, again decrease. No, this is not. So 1, 2 is the answer. That's all. Is it clear, people? Say it in the chats. Is it clear? Is it clear? Look at this particular question. Look at this particular question, Redox is a very simple chapter. It's a small chapter too. It will get done quickly. Either the question will be on oxidation state, or the question will be on balancing, or the question will be on titration. I'll show it to you. I'll show it to you. Oxidation state of phosphorus here. Phosphorus, let's call it as X. Oxygen is going to show -2. There are 4 oxygen atoms. Net charge is -3. So X value will come out to be +5. So this +5 here. Right? Sulfur. X, oxygen will show -2. 4 oxygen atoms. Net charge -2. X value will come out to be +6. So this +6 here. Call it as X. So this is 2X plus oxygen shows -2. There are 7 oxygen atoms. Net charge is -2. X value is +6. So +6 here. Done and dusted, right? So oxidation states are calculated. +5 +6 +6. +5 +6 +6. So option 4 has to be the one. Option 4 has to be the one. Simple and basic. Look at this particular question, guys. Look at this particular question. Substances that are oxidized and reduced. Substances that are oxidized and reduced. If I ask you the oxidation state of nitrogen here, you will say it's -2. When you calculate it, 2x plus 4 is equal to 0. It's -2. If I ask you the oxidation state of nitrogen here, it's 0. So -2 to 0 increase. -2 to 0 increase. Increase means oxidation. So this particular species is undergoing oxidation. So I'll say this particular species is oxidized. It is oxidized. If this is oxidized, automatically this is reduced. It will undergo reduction. This is reduced. What I was supposed to check? Substances that are oxidized and reduced. N2H4 is oxidized. H2O2 is reduced. N2H4 is oxidized. H2O2 is reduced, right? This is one more type. This is one more type wherein you have to check whether the substance is oxidized or reduced. So simple, check the change in oxidation state, that's all. Check the change in oxidation state, that's all. All right. Calculate the N factor of ferrous oxalate in this reaction. Calculate the N factor of ferrous oxalate in this particular reaction. Can you give it a try? Can you give it a try? Can you let me know what will be the N factor of ferrous oxalate in this particular reaction? All those students who have watched the marathons recently, which I took, you should be remembering it by now. You should be remembering it by now. Yeah? Have a look, people. Try to understand. This iron here is in dipositive oxidation state. Carbon here is in +3 oxidation state when you calculate. This is in +3 oxygen state. This carbon is in +4. If you check carefully, +2 to +3, increase in the oxidation state. +3 to +4, increase in the oxidation state. You know, whenever oxidation state of more than one element increases simultaneously or decreases simultaneously. Whenever oxidation state of more than one element increases simultaneously or decreases simultaneously. How do you calculate this N factor? It's going to be N1 plus N2. It's going to be N1 plus N2. Now, we have to calculate N1, we have to calculate N2. Now, how do you calculate N1 and N2? Have a look. +2 to +3. +2 to +3. What is the change in oxidation state? Final minus initial. The value comes out to be 1. 1 is the change for one atom, and I've got only one atom here. N1 is 1. +3 to +4. Change is 1. 1 is the change for one atom, but I have 2. 1 is the change for one atom, but I have 2. So N2 value is 2. So 2 plus 1 comes out to be 3. So 3 is the N factor of this particular species. Remember it directly. Remember it directly. Let me give you one more question. Let me give you one more question. What do you think is the N factor of Cu2S in this particular reaction? Cu2S. This question, I mean, you should tell me the answer of this particular question. Chalo, one thing I'll give you. I'll give you the oxidation states. This is +1. This is -2. This is +2. And this is +4. Tell me the N factor now. Quick. Again, you should remember it. Those students who have watched my marathons, they will be already remembering it. They'll be already remembering it. Quickly, my dear student. Quickly. Everyone, quickly. If you look carefully, +1 to +2. +1 to +2, increase. -2 to +4, increase. Again, its N factor will be what? It will be N1 plus N2. Now, what is N1? What is N2? +1 to +2. Change 1. 1 is the change for one atom. I have 2. So N1 value is 2. Plus. -2 to +4. What is the change? minus 2 to plus 4. Final minus initial. So 4 minus minus 2. 4 minus minus 2 is 6. 6 is the change for 1. I now 1, right? So n2 is 6. The value exactly comes out to be 8. Done. Simple. And my dear students, it is not necessary that they'll ask you the n factor. They can ask you the equivalent weight. And you know, if you got its n factor, you can calculate its equivalent weight. Molar mass of this divided by n factor of this. That's all. Right? That's all, people. I hope I'm clear. Okay. One more type of question which can be asked. Either they'll ask you directly the n factor of Br2 or they'll ask you the equivalent weight of Br2. And this has been asked many a times. Br2 gives BrO3 negative plus what? Plus Br negative. Check it out. Check it out, guys. Its oxidation state here is 0. Oxidation state of bromine here is plus 5. Here it is minus 1. If you look carefully, 0 to plus 5 increase. 0 to minus 1 decrease. So oxidation state of same element is increasing as well as decreasing simultaneously. How do you calculate its n factor? You should know it by now. It is going to be n1, n2 divided by n1 plus n2. Whenever you need to calculate the n factor of the species which undergoes disproportionation, how do we do it? n1, n2 divided by n1 plus n2. Now you tell me what is the value of n1 and what is the value of n2. How do we check it? Understand? 0 to plus 5. What is the change? 5. 5 is the change for 1 atom. I have 2. So 5 2s are 10. Right? 5 2s are 10. So n1 value is 10. n1 value is 10. n1 value is 10. Right? 0 to minus 1. 0 to minus 1. What is the change? Final minus initial. The value comes out to be 1. 1 is the change for 1 atom, but I have 2. n2 value is equal to 2. So it is just going to be 10 multiplied by 2 divided by 10 plus 2. So 20 divided by 12. 4, 5, 4, 3. So 5 by 3 is basically going to be the n factor of Br2 in this particular reaction. They can ask it like this as well. Or if they do not ask about the n factor, they'll ask you about the equivalent weight. Molar mass of Br2 divided by n factor of Br2. That's all. That will give you the equivalent weight of Br2. I believe it's clear. I hope it's clear. I hope it's clear. All right. Look at this particular question. It has been asked many a times in NEET 2018, in AIEEE 2013, in JEE 2021. Right? See how basic question this is. Balancing. I told you, either the question will be from oxidation state, or the question will be from balancing, or the question will be from equivalent weight, or the question will be from redox titration. Right? Can you check it? Can you check it? Oh, this question was asked in AIEEE 2013. In 2013, I wrote AIEEE. That means this question was asked when I wrote JEE examination. Quickly, people. Quickly. In 2013, I wrote JEE examination. Exactly 10, 11 years before. My God. Too old. Okay, a lot of people are coming up with option B. Is that? My JEE main score was 261 out of 360. Quick, people. Quick. It's a simple question, guys. See, I'll show you how do we balance the reactions. Okay, let me show you how do we balance the reactions. This is MnO4 negative as per the question. Understand and remember, MnO4 negative plus what? Plus oxalate ion, C2O4 dinegative. In acidic medium, it's giving what? It's giving Mn di positive plus carbon dioxide. First of all, you should know the n factor of these two. You should know n factor of these two. See, manganese here is in plus 7 to plus 2, change is 5, so its n factor is 5. Carbon here is in plus 3 to plus 4, plus 3 to plus 4, plus 3 to plus 4, change is 1. 1 is the change for 1 atom of 2, its n factor is 2. Number 1. I calculate n factor of the reactants, right? Now crisscross these n factors. Take this 2 here, take this 5 here, crisscrossed. I'll crisscross these. After crisscrossing these, balance all the atoms except hydrogen, oxygen. So 2 manganese. Oh, what did I do? 2 manganese here, 2 manganese here. 5 to the 10 carbon, 10 carbon. So I have balanced all the atoms except hydrogen, oxygen. Now, in acidic medium, we are going to balance oxygen. 4 to the 8, 5 to the 20. 28 oxygen on left side. How many oxygen on right side? Only 20. Left side 28, right side 20. So right side is oxygen deficient. How many oxygen deficiency? 8. Oxygen deficiency is equal to 8. So add 8 water molecules to that side which is oxygen deficient. Done. Now, talk about hydrogen. 8 to the 16 hydrogen on this side. No hydrogen on this side. So this side is hydrogen deficient. How many hydrogen deficiency? 16. Add 16 H positives on this side. This reaction is balanced now. So first, get the N factor of both the reactants, crisscross them, balance all the atoms except hydrogen, oxygen, then balance oxygen with the help of water, then balance hydrogen with the help of H positive. We are done. This sort of equation can be asked, people. It can be asked, okay? It can be asked. Surely it can be asked. Surely it can be asked. All right. This sort of a question was never asked in the NEET examination, but this year I believe this sort of a question can be asked, right? Based on titration, based on equivalent concept. And you should be in a position to solve this question. You should be in a position to solve this particular question. And how do we exactly do it? How do we exactly do it? As per the question is concerned, your K2Cr2O7 is going to react with Na2C2O4, sodium oxalate. First of all, in acidic medium, I would want you guys to remember their N factors. N factor of this particular species you must be knowing is 6. N factor of this particular species you must be knowing that is 2. That is 2. Their N factors. Number 1. Number 2. What is the molarity of K2Cr2O7? It is 0.2. What is the volume of K2Cr2O7? That's to be calculated. What is the molarity of sodium oxalate? That is given, 0.3. What is the volume of sodium oxalate? That is 50 ml. That is 50 ml, right? My dear students, the first thing, molarity multiplied by N factor, that gives me normality. So normality of first one is 1.2. Normality of second one is this multiplied by this, 0.6. 0.6. How do we solve the question? Since these two are reacting, I can say milli-equivalents of this substance reacted has to be equal to milli-equivalents of this substance reacted. So milli-equivalents of this is equal to milli-equivalents of this. How do we calculate milli-equivalents? Normality multiplied by volume. So milli-equivalents of first means normality of 1 multiplied by volume of 1 in ml is equal to normality of 2 multiplied by volume of 2 in ml. Right? What is normality of 1? 1.2. Volume of 1 is to be calculated. This is 0.6 and this is 50. So V1 will come out to be 25 ml. What is the meaning of this 25 ml? Can you let me know in the chats? It means that 25 ml of 0.2 molar K2Cr2O7 is required to oxidize 50 ml of 0.3 molar sodium oxalate in which medium? In acidic medium. Is it done? Can you solve this sort of equation? It is just if you remember the N factors, if you know how to calculate the N factors, you are sorted. This sort of equation can be easily done. Guys. Right? One more similar type of question I'm giving you. Then I'll move ahead. It is a similar type. This is not a different type of question. It's similar type. It is similar type. As per this particular question, your KMnO4 is reacting with what? It is reacting with FeSO4. Right? First of all, you know their N factors. N factor of this is 5. N factor of this is 1. Correct? Because you know KMnO4 in acidic medium gets converted into Mn dipositive. Mn dipositive plus 7 to plus 2 changes 5. FeSO4, Fe dipositive gets converted into Fe tripositive. So plus 2 to plus 3 changes 1. So I'm not going into the N factors right now. See, molarity of KMnO4 is given 0.1. Volume of KMnO4 needs to be calculated. Molarity of FeSO4 0.2. Volume of FeSO4 100 ml. The first thing which I'm asking you to calculate, what is that? Molarity multiplied by N factor. That gives me normality. So normality of 1 here is 0.5. Normality of 2 here is 0.2. Right? You got the normality. Now what do we need to do? Just equate their milli-equivalents. I'll say milli-equivalents of KMnO4 reacted has to be equal to milli-equivalents of FeSO4. Milli-equivalents of KMnO4, normality of 1 multiplied by volume of 1 in ml is equal to normality of 2 multiplied by volume of 2 in ml. So my dear students, what is N1? N1 is 0.5. What is V1? Needs to be calculated. What is N2? 0.2. What is V2? 100. So V1 will be equal to 0.2 multiplied by 100 divided by 0.5. What will be V1? V1 will come out to be 40 ml. So what is the meaning of this 40 ml? I'm asking you. It means that 40 ml of 0.1 molar KMnO4 is required to oxidize 100 ml of 0.2 molar FeSO4 in which medium? In acidic medium. I hope I'm clear to every one of you. Yes? Right, people? These were the types of the questions which can be asked from the chapter redox reactions. Question based on oxidation state. Number 2. Question based on balancing. Number 3. Question based on N factor equivalent mass calculation. Number 4. Question based on titration. That's all. Nothing else. Nothing else, guys. So are you ready for atomic structure now? Are you ready for atomic structure now? Are you ready for atomic structure now? Yes? Quick, 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 quick. All right. Let's move on. And tell me the answer of the first basic question, which you all will be remembering, I'm pretty much sure. Your cathode rays. Cathode rays. Cathode rays. Cathode rays. What are cathode rays? The fast moving beam of electrons. Right? Fast moving beam of electrons. Guys, just give me a second. Guys, just give me a second, okay? Just a second. Okay. I think everyone has solved this, right? Okay, there was no need to solve this question, by the way. Which of the following is never true for cathode rays? What do you think? Cathode rays, they have got kinetic energy, right? They're electromagnetic. They're not. It's a simple question, guys. I don't want to discuss all this stuff. Okay, moving ahead. So the first type of the question that can be asked. First type of question that can be asked. What do you think? The value of Planck's constant is given. Speed of light is given. Wavelength we have to calculate. Of the light, which have got frequency this. Frequency this. How do we calculate frequency? Frequency, guys. Frequency is equal to C divided by lambda. Right? Frequency is equal to C divided by lambda. Correct? Frequency is equal to C divided by lambda. What is C? How much is C? How much is C? What is the wavelength in nanometer? Okay, we have to calculate wavelength in nanometer. Okay, so C I have to take as 3 into 10 raised power 17 nanometer second inverse. Divide by, what is lambda? What is lambda? Lambda is 6 into 10 raised power 15. Right? Lambda is this lambda or what is given? Just a second. Okay, I'm writing reverse. Just a second, guys. Just a second. What do we have to calculate? Wavelength we have to calculate, lambda. So lambda is nothing but C divided by frequency. Right? C, as per the question, is given 3 into 10 raised power 17. This is nanometer second inverse. Divided by frequency. Frequency is 6 into 10 raised power 15 second inverse. So second inverse cancelled here only. Right? So this will be 100 into 3 is 300. 300 divided by 6 is 300 divided by 6 is 50. And the answer is going to be in nanometers. Isn't it simple? Right? You can solve this sort of equation easily. Easily, this sort of equation can be solved. There is no need to think a lot about this particular equation, number one. Number two, look at this particular equation. Similar type of equation, but slight changes. Calculate the energy in joules corresponding to light of wavelength 45 nanometers. You know, energy is equal to, energy of the photon is equal to, energy of the photon is equal to hc divided by lambda, right? What is the value of lambda? Value of lambda is 45 nanometers. hc value I'll be using as 1240 electron volt nanometer. So nanometer cancel. The value comes out to be 1240 divided by 45 electron volt, right? But, am I supposed to get it in electron volt? No, I'm supposed to get it in joules. And you must be knowing now, 1 electron volt is, I'll be writing it like this, 1240 divided by 45. 1 electron volt is 1.6 into 10 raised power minus 19 joules, right? This is how you calculate energy. Simple. Correct? Correct, people? Correct? Done? All right. Look at one more question, one more type of equation which can be asked from Planck's quantum theory. A bulb is emitting electromagnetic radiation of 660 nanometer wavelength. The energy of the radiation is this. The number of emitted photons will be. The number of emitted photons will be. The number of emitted photons will be. You know, E is equal to NHC divided by lambda. You just have to get the value of N. So N is nothing but it is E multiplied by lambda divided by H multiplied by C. Right? Energy is given to us, I believe, in joules, 3 into 10 raised power minus 18. Since you have taken energy as per SI system, you have to take lambda as per SI system as well, which is 660 nanometers, means 10 raised power minus 9 meters, divided by H value as per SI system 6.6 into 10 raised power minus 34. C value as per SI system 3 into 10 raised power 8. Just the matter of calculation and get the value of N. Simple and basic question. Simple and basic question this was. Right? I've shown you these sort of questions many a times. Right? I'm not going to waste a lot of time here. Okay. Look at this again. One more basic question. Just kill it. The question says the energies E1 and E2 of the two radiations are 25 electron volt and 50 electron volt respectively. The relation between their relative wavelengths, lambda 1 and lambda 2. What is going to be the answer? You know, E is your hc divided by lambda. E is hc divided by lambda, right? So energy and wavelength, they are inversely proportional. So can I say E1 divided by E2 has to be equal to lambda 2 divided by lambda 1? E1 is 25, E2 is 50. So this is 1 by 2 is equal to lambda 2 divided by lambda 1. But am I supposed to calculate lambda 2 by lambda 1? Right? So lambda 2, what did I write here? Lambda 2 divided by lambda 1. So lambda 2 is, 2 times lambda 2 is your lambda 1. 2 times lambda 2 is your lambda 1. Option B is the simple correct answer of this particular equation. Correct? This sort of a question can be asked, and it has been asked as well. Right? Now, tell me the answer of this question. Photoelectric effect, every one of you have studied. Photoelectric effect, right? I just want answer of this particular question. What do you think? What do you think of this one? The energy of the emitted electron, the energy of the ejected electron, it'll be what? Energy of the ejected electron, it'll be greater than incident photon? Nope. Same as incident photon? No. Smaller than incident photon, right? Energy of the incident photon has nothing to do with the intensity of the incident photon. Energy of the emitted electron, energy of the emitted electron has nothing to do with the intensity of the photons, has nothing to do with the intensity of light. Correct? Energy of the emitted electron is always smaller than the energy of the incident photon. Correct? Perfect. Tell me the answer of this particular question. Simple, again, formula based, same formula you'll be using. Calculate the energy of 100 photons. You know, E is equal to NHC divided by lambda. How many photons are we given with? 100. HC value is 12400 electron volt angstroms divided by lambda is given as 2000 angstroms. So angstrom cancel, right? So 000 and this 000 cancelled. Perfect. 000 and this 000 cancel. So E will be equal to 620 electron volts, right? But do I have to get the answer in electron volts? No, I have to get the answer in joules. So, but you know, 1 electron volt is equal to 1.6 into 10 raised power minus 19. Then the answer will come in joules, right? Simple. Simple and basic question this was. Can be asked. Can be asked. Do you remember this sort of a question? In atomic structure, I have given you all these types of the questions. How many photons are emitted per second? How many photons are emitted per second? Number of photons emitted per second. Basically, we are supposed to calculate rate of emission of photons. Rate of emission of photons, right? We have got the laser which is operating at 5 milliwatt, which is 5 into 10 raised power minus 3 watts. This is the power of the laser, right? Perfect. The wavelength which this laser is emitting, that is 620 nanometers. This also given. What do we need to calculate? Number of photons emitted per second. You know, power is energy transmitted divided by time. E is nothing but NHC divided by lambda. And this has got T over here. We just need to get the value of N by T. And over here, if you can see, N divided by T is equal to P multiplied by lambda divided by H multiplied by C. So what is P? P is 5 into 10 raised power minus 3. What is the lambda? What is lambda? What is lambda? 620 nanometers. So 620 multiplied by 10 raised power minus 9 divided by H is 6.6 into 10 raised power minus 34. What is C? 3 into 10 raised power 8 meter per second, right? So just you need to solve this particular thing and get the value of N by T, which I was supposed to calculate. And this is how you guys are going to solve this type of the question. This is how you guys are going to solve this sort of a question. Am I clear? Am I clear, people? Am I clear? Am I clear? Am I clear? Quickly. Tell me the answer of this particular question. You have got different series, you know it. Lyman series, Balmer, Paschen, Brackett, Fund. These are the different series which we have. You know it, correct? Remember, U, V, I. This is ultraviolet. This is visible. This is infrared. This is far infrared. Far infrared. This is also far infrared. Now tell me the answer of this question. Anything can be asked. Over here in this question, they are asking about what? Which of the following series of transition in the spectrum of hydrogen falls invisible? Which one falls invisible? It's the Balmer series which falls invisible, right? Option B. Remember this particular table? Done. It is sorted. Moving ahead. Moving ahead. Tell me the answer of this particular question. This is something which all of you should answer, right? First of all, energy of the nth Bohr's orbit. Energy of the electron in the nth Bohr's orbit is equal to minus 13.6 z square by n square. You know the formula. Radius of the electron in the nth Bohr's orbit is equal to r naught n square divided by z. These are the results. Even velocity is equal to v naught z by n. Time period is equal to t naught n cube upon z square. Frequency is equal to v naught z square upon n cube. Now anything can be asked. You are done. Don't need to think a lot, right? Perfect. So your energy is inversely proportional to n square. Perfect. And radius, it is directly proportional to n square. Radius is directly proportional to n square. So option B is the one which is correct. This sort of a question even is asked. I'm moving ahead. I am moving ahead. Tell me the answer quickly. I told you the formula right now. The energy of the electron in the nth Bohr's orbit is equal to minus 13.6. Minus 13.6 z square divided by n square for hydrogen. Correct? Correct. It is complete formula based. It was complete formula based. Tell me the answer of this particular question quickly. I believe you would have solved this particular question many a times. Quick. Quick, guys. Many a times we have solved the similar question. First of all, radius of the nth Bohr's orbit, you know, it is r naught n square divided by z. So I can say r1 divided by r2 has to be n1 square divided by n2 square. This is z2. This is z1. z2, this is z1. Right? Correct, guys? Now, we are given it two single electron species, He positive and Be tripositive. Be tripositive, right? Okay. Now, first of all, N1 here is 2. N1 here is 2. Its atomic number is 2. Correct? R1 is its radius. N2 here is 3. Z2 is hydrogen, helium, lithium, beryllium, right? R2 we'll have to calculate. As per the question, what do we have to calculate? Calculate the radius ratio. R1 by R2 value we have to calculate. R1 by R2. So R1 divided by R2 will come out to be nothing as N1 square. So 2 ka square is 4 divided by N2 square. 3 ka square is 9. Z2 is 4. Z1 is 2. So it is 16 divided by 18. So 8 is to 9 is the answer. 8 is to 9 is the answer. That's all. That's all, people. Am I clear? Am I clear? So when the question is based on the radius ratio, this is the approach which you'll be using in order to solve the question. Okay. Similarly, there is one more question. I believe this sort of a question we have already solved as well, right? You know, velocity of the electron in the nth Bohr's orbit is equal to v naught z divided by n. And if you want to compare v1 by v2, it has to be equal to z1 divided by z2. This is going to be n2 divided by n1. Okay. Now, we are given with hydrogen atom as well as we are given with Li di positive. Atomic number of hydrogen, that is 1. Perfect. Which orbit they are talking about for hydrogen? That is 1. Velocity of the electron over here is equal to v as per the question. What is the atomic number of lithium? Hydrogen, helium, lithium. What is the orbit number which they are talking about? The third orbit number. Let the velocity here be v2. Correct? Right, people? Now, solve it. v1 is v divided by v2 is equal to z1. What is z1? That's 1. What is z2? 3. What is n2? 3. What is n1? 1. So, as per the question, v divided by v2 is equal to 1, which means that v2 is equal to v. Which means that v2 is equal to v. Which means that v2 is equal to v. Am I clear? Am I clear, people? Am I clear? Yes. The question can be based on radius, question can be based on velocity, question can be even based on time period as well, right? So do remember all these types of the questions which can be asked. Okay, one more type. This is the conceptual one. You have got nothing to do over, you don't have to solve this question. It's a conceptual one, proper one. According to the Bohr's theory, which of the following transition of the hydrogen atom will give rise to least energetic photon? Least energetic photon. For example, this is n is equal to 1, right? Let's say this is n is equal to 2. Let's say this is n is equal to 3. Let's say this is n is equal to 4. You know, as we go up, right? As we go up from n is equal to 1 to 2, 3, 4, the successive energy gaps, that decreases. Successive energy gaps decreases. They are asking about the least energetic, not most energetic. If it is 6 to 1, 6 to 1 energy gap is maximum. That will be highest energetic photon. Highest energetic photon, right? So as you go up, successive energy gaps decrease, decrease, decrease. So where will be the energy gap minimum? Energy gap will be minimum from 6 to 5, right? When the electron makes a transition from 6 to 5, energy gap is minimum. Least energetic photon will be released. Least energetic photon will be released, right? So you are going to solve this question in that manner. I hope I'm clear. Okay, be careful with all these things. Be careful with all these things. Be careful with all these things. Okay. What do you think about this one? What do you think about this one? If n is equal to for He positive, we are given He positive, right? N is equal to Z for helium is 2. Find out wavelength lambda. Find out wavelength lambda. Well, first of all, can I calculate radius over here? Radius of the second orbit of He positive, r naught n square divided by Z. So r is equal to, r naught is 0.529. What is n ka square? 2 ka square is 4. Z is 2. So 0.529 multiplied by 2. This is the radius first of all. What do we have to calculate? Wavelength? You know your 2 pi r is equal to n lambda. 2 pi r is equal to n lambda. So 2 pi is your 22 by 7. What is r? R is 0.529 multiplied by 2. N value. What is n value? N value is 2. And from here you can calculate lambda. So 2 to cancel. Matter of calculation. Get the lambda. That's all. Is it difficult or something? Easily, my dear students, you can solve these sort of questions. Just remember their approach and we are done. We are sorted. Yeah? Remember the approach and we are done. Okay. Look at the question. What is the maximum wavelength? What is the maximum wavelength of the line of Balmer series? In Balmer series, electron makes a transition from higher energy state to shell number 2. Higher energy state to shell number 2, right? So it can be 3 to 2, 4 to 2, 5 to 2, infinity to 2. What do we have to calculate? I'm talking about the Balmer series. I'm talking about the Balmer series. What do we have to calculate? Maximum wavelength. Do you know energy gap? It's inversely proportional to lambda. If this is maximum, this has to be minimum. Now, which is the minimum energy gap? For the lambda to be maximum in Balmer, energy gap has to be minimum. Now, which is the minimum energy gap when it comes to the Balmer? I would take this as the transition. The transition has to be 3 to 2, right? The transition has to be 3 to 2. Perfect. The transition has to be 3 to 2. So this is your lower energy state. This is your higher energy state. Now, my dear students, as per Rydberg's formula, 1 by lambda is equal to rz square, 1 upon n1 square minus 1 upon n2 square. So 1 divided by lambda is equal to r. 9 minus 4 is 5 divided by 36. So lambda is equal to 36 divided by 5 multiplied by 1 by r. And it's going to be 36 divided by 5. 1 by r value is 911.5 angstroms. Here the answer will come in angstroms. Then you can convert into nanometers as well. Yes? Am I clear? Am I clear, people? This sort of a question can be asked. It is simple. It is simple, guys. I'm moving ahead. I am moving ahead. Okay, what do you think about this one? There is no formula or something. It is just your common sense which will work here. The spectrum of helium is expected to be similar to what? Spectrum of helium Helium has got 2 electrons. Check which of the following has got 2 electrons. Li positive. So their spectrum will be similar. Their spectrum will be similar, right? So no need to think a lot about this particular equation as well. Okay? No need to think a lot about this particular equation as well. Just a second. All right. One more type of the question that can be asked. What is that? Spectral lines. When the electron is excited from ground level to fifth, the number of spectral lines obtained in the Bohr spectrum. So your higher energy state here is 5. Your lower energy state here is 1. Now, when the electron makes a transition from higher to lower, right? How many maximum spectral lines are obtained? There's a formula for that. Maximum spectral lines produced is equal to N2 minus N1. This is N2 minus N1 plus 1 divided by what? Divided by 2. Right? Tell me what is the value of N2? 5 minus 1. This is 5 minus 1 plus 1 divided by 2. This term cancel. 5 4 20. 20 divided by 2 is 10. So in total, maximum 10 spectral lines will be obtained. Okay? Perfect, guys. Perfect. Look at one more type of the question that can be asked. One more type of the question. The de Broglie wavelength associated with the photon varies with the frequency of the light. Okay. Varies with the frequency of the light. Nice. You know, your lambda is equal to h upon p. You know, your lambda is equal to h upon p. Perfect. Can I write it like this? Lambda is equal to h upon, instead of p, can I write under root of 2m kinetic energy? Correct? This is the de Broglie wavelength in terms of kinetic energy. Because you know, p is equal to under root of 2m kinetic energy. Now, if you remember, as per your photoelectric equation is concerned, EI is equal to phi naught plus KE max, right? Plus KE max. So this was h nu is equal to h nu naught plus KE max. Or I can say KE is equal to h nu minus nu naught. So over here I can say lambda is equal to h divided by under root of. This is 2m. What is KE? K is going to be h nu minus nu naught. Perfect. So your lambda, I can clearly say lambda is inversely proportional to under root of nu minus nu naught. Is there any option like this? Is there any option like this? Have a look quickly. Is there any option like this? This is the answer. Option D is the correct answer of the question. This sort of a question can be asked as well from the chapter Atomic Structure. Guys, different types of the patterns I'm showing to you, okay? Different types of problem patterns which can be asked. See, this is a very simple question. I believe you can, without solving it, you can go for it. Lambda is equal to h upon p, right? This is one of the result. Or lambda is equal to h upon under root of 2mke. One more result. One more result, right? Or you can say lambda is equal to h upon under root of 2m. Instead of kinetic energy, you can write charge multiplied by potential difference. If the charge is accelerated under the potential difference of v. Correct? So lambda and this MEV or MQV, they are inversely proportional. So what is the answer of this question? What has to be the answer of this question? What has to be the answer of this question? What are we supposed to calculate? We are supposed to calculate h by lambda. We are supposed to calculate h by lambda. So h divided by lambda is equal to under root of 2m if this is E and this is V. Under root of 2m EV. Option C is the one which has to be the correct answer of this question. Right? So be careful with these sort of questions as well. I am moving ahead. This sort of a question from Heisenberg's uncertainty principle can be asked as well. Okay? And you know, as per your Heisenberg's uncertainty principle is concerned, you know your delta x dot delta v, it has to be equal to greater or equal to h upon 4 pi m. You should know it. You should know it. Right, people? You should know it. This is just a second. There is a small change. Uncertainty in velocity. It should not. Okay. If uncertainty in position and momentum are equal. All right. If uncertainty in the position, if uncertainty in position is equal to momentum. Is equal to momentum. If uncertainty in position and momentum are equal. All right. Right? So delta x will be equal to, what is P? What is P? P will be simply equal to M multiplied by V. Right? I think, guys, just a second. This question should not be in this manner. If uncertainty in position and momentum, uncertainty in position, delta x, uncertainty in momentum. This is okay. All right. It is this. You know, your one of the result, delta x dot delta p is greater or equal to h upon 4 pi. Now, uncertainty in position and momentum, if they are equal, what do you get over here? Instead of delta p, you can write delta x. So delta x ka square is greater or equal to h upon 4 pi. So delta x will be greater or equal to under root of h upon 4 pi. Now, you can put this delta x over here, right? You can put this delta x over here. Perfect. Or I can say delta v is greater or equal to h upon 4 pi m, and delta x, what is delta x? Delta x is under root of h upon 4 pi. Correct? Now the question is done. Now the question is done. Now the question is done. Correct? Now it's just a matter of calculation. If I use the equal sign in between, just to make the calculations easy. Okay? So this h upon, I'll take the root common. Let me take the root common. Let me take the root common. Already in the root, it is h upon 4 pi. H upon 4 pi. Okay? Now this 4 pi m I'm inserting in the root. So this will be 4 pi m ka square. I hope you are fine with the calculation which I'm doing. So 4 pi is cancelled. Right? So it's going to be h upon under root of. One of the 4 pi gets cancelled. So it's 4 pi h m square. 4 pi h m square. Now, if I again take the root common, this h becomes h square, one of the h gets cancelled out. So it becomes h divided by 4 pi m square. So the final answer is going to be 1 divided by m under root of h upon 4 pi. Is there any option like this? Is there any option like this? 1 by m under root of h upon 4 pi. Or if you want to take 4 as common as well, 4 out, it will be 1 upon 2m. 1 upon 2m under root of h upon pi. 1 upon 2m under root of h upon pi. So it has to be option A. It has to be option A. It has to be option A. Am I clear with this? Is that clear, people? Is it clear? Let's move on to one more thing. Just a second. Okay. These sort of questions you can expect, right? These sort of questions you can expect in this year's NEET examination. Psi square versus R graphs or psi versus R graphs. They were not asked in NEET examination. But this year they have clearly mentioned in the syllabus that psi square versus R and psi versus R for S and P orbital. So expect a question from here. Expect a question from here. Okay? And let me tell you some quick tricks. Psi square versus R, or psi versus R. For the S orbitals, they start from the top. Psi square versus R or psi versus R. In case of p orbitals, they start from the bottom. Just remember it. This for S, this for p, number 1. So look at this particular graph. Is it starting from the top? Yes, so it's for S. For sure it's for S. For sure it is for S. Okay. Now which S it's going to be? First of all, look here. Psi square value here is 0, so it's a node. Psi square, 0 node. So how many total nodes we have? Total nodes are calculated with the formula n minus 1. N minus 1 is 2. So n is 3. So it is 3s basically. So this graph is valid for 3s, right? This graph is valid for 3s. Total nodes n minus 1 is equal to 2. So n value has to be 3. Okay, perfect. Perfect, guys. Wait, have we done something wrong here? Wait. I did a mistake. Total number of nodes is 1 only. I wrote 2. Sorry. This is 1. N minus 1 is 1, so it has to be 2s. Okay? It has to be 2s. So 2s is the orbital. I hope I'm clear. All right. How do you calculate the total number of nodes? Tell me that. Total number of nodes is calculated by the formula n minus 1. You know it, right? How do you calculate the angular nodes? The value of L. How do you calculate the spherical nodes? N minus L minus 1, right? N minus L minus 1. These are the respective formulas which you will have to remember for sure. Number 1. Now, if you talk about your 2s, n value is 2, L value is 0. Okay. Now, put it here and check. Right? What do we have to check? A certain orbital has no angular node. So, L value has to be 0. L value can be 0 for S only. Right? So, it can be this or this. Right? No angular nodes. 2 radial nodes. So, it has to be 3s. 3s has to be the answer of the equation. Right? 3s has to be the answer of the equation. Okay? Perfect. You can check for 3s. N is 3. N is 3, L is 0. So 3 minus 1 is 2. L is 0. It is 0. So this will be also 2. Done. And sorted. So this can be one more type of the question that can be asked. And I believe you can easily solve it on the base of nodes if the question is asked. Right? Just a second. Let me show you one more type of the question that will be asked from here. Just a second. Okay. Tell me the answer of this one. This is again one short question that's asked frequently. Orbital angular momentum. How do you calculate orbital angular momentum? Under root of L into L plus 1. H upon 2 pi. In case of P, L value is 1. If L is 1, orbital angular momentum has to be equal to under root of 1 into 1 plus 1, h upon 2 pi. 1 plus 1 is 2, so root of 2, h upon 2 pi, which is going to be h upon root of 2 pi. Right? This is the formula. This is the answer, h upon root of 2 pi, which I believe you all would have solved already. So remember this particular formula, you're done, right? L value you have to remember. For S it is 0, for P it's 1, for D it's 2, for F it's 3. That's all. That's all, my dear students. What kind of different types of the questions can be asked? Look at this one. This is the asked question. The correct set of 4 quantum numbers for the last electron of rubidium. If you talk about rubidium, it's group 1, right? You know, your lithium, sodium, potassium, rubidium. Perfect. Outermost configuration of lithium is 2s1. This is 3s1. This is 4s1. This is 5s1. So, in case of rubidium, the last electron is in 5s1. So, n value here is 5. Right? N value here is 5. L value for S is, for S subshell, L value is 0. If L is 0, the M has to be 0 only, because M is minus L to plus L. S can be either plus 1 by 2 or minus 1 by 2. Right? So, which option satisfies? Option C is the one which is going to be the correct answer. This is the asked question. And these sort of questions you can expect again. These sort of questions. Okay, one simple basic question. Total number of atomic orbitals in 4th energy level. Total number of atomic orbitals in a particular shell, that's always equal to n square. Total number of maximum orbitals in a particular shell, that's n square. N value here is 4, 4 ka square is 16. Right? 4 ka square is 16. Correct? I'm not solving or something. Okay. Even this type of the question can be asked. And you would have seen this sort of a question in the books as well. Which of the following set of quantum numbers is not possible? Is not possible. Let's check one by one. N is 3, L is 0. L can have the values from 0 to n minus 1. 0 to n minus 1, right? Let me first of all write all these things. L can have value from 0 to n minus 1. And remember, your magnetic quantum number M, it can have values from minus L to plus L. S can have only two values, either plus 1 by 2 or minus 1 by 2. Plus 1 by 2 or minus 1 by 2. Okay? So N is 3 here, L is 0, which is correct. M is also 0. This quantum number is correct. This set of quantum numbers is correct. See, N is equal to 2, L is 2, but L is from 0 to n minus 1. So 0 to 2 minus 1. It can be 0 or 1. Wrong. 4, 3. Minus 2, this is correct. 1, 0. This is minus 1. Whereas we know M is from minus L to plus L. So M can have only 0 value over here. So this is wrong. 3, 2, this is also wrong. Minus L to plus L. So minus 2 to plus 2. 3 does not come in that. So 1, 1, 4 and 5. 1, 4 and 5. 1, 4 and 5. Sorry, 2, 4 and 5. 2, 4 and 5 are incorrect ones. Right? 2, 4 and 5 are incorrect ones. 2, 4 and 5 are incorrect ones. 2, 4 and 5 are incorrect ones. What do you think about this particular question? This question, again, you should be able to solve. This question you should be able to solve. For which of the following set of 4 quantum numbers an electron will have highest energy? Highest energy. An electron will have highest energy. First of all, look here. This is your 3D. This is your 4D. This is 4P. This is 5S. Right? Get the N plus L value. N plus L here is 5. N plus L here is 6. N plus L here is 5. This is 5. So where is the N plus L value maximum? Here. So B is the answer. N plus L is maximum here. So B is the answer. Correct? So B is the answer. So B is the answer. I hope I'm clear with all of these things. Right? Next chapter is going to be chemical bonding, but it will be done after the break. So I'll see you exactly at you have your lunch. Okay, I'll be back on time. And I would want every one of you to be back on time as well. Okay? I'll be back by 1:15. I'll be back by 1:15 sharp. Okay? Yes, it's a comparatively long break. It's comparatively long break. Perfect, guys. So I would want every one of you. I would want every one of you to be back exactly at 1:15. Perfect. Chalo, I'll see you guys. Take care. Is everyone back, people? Yes. Is everyone back? Is everyone back? Is everyone back? Let me know in the chats quickly. Call up everyone. Call up everyone. Call up everyone. Perfect, perfect, guys. Perfect. Is HSP sir in the chats? HSP. Is he in the chats? Is he in the chats? All right. Chalo then, let's get started with the new chapter, that is chemical bonding, right? We shall be solving almost like 30 to 40 questions from this particular chapter itself, right? And all are different types of the questions which can be asked from this particular chapter. And in this chapter, expect 3 to 4 questions for sure in the NEET 2024 examination. I'm telling you 3 to 4 questions minimum from this particular chapter you can expect in the upcoming NEET examination, right? Perfect. All right, people. So let's get going then. Let's get started. Let's get started. Let's get started. The first basic question, which I believe everyone can easily solve. Cation and anion combines in a crystal to form which type of the compound? You know, in your ionic compounds, right? In your ionic compounds, your cation and anion interact, right? And that interaction between the cation and anion is something which you call as the ionic bond. And any such compound wherein ionic bond exists, you call that particular compound as the ionic compound. One basic question this is. Second one, my dear students. Second one. When a metal atom combines with a non-metal atom, when a metal atom combines with a non-metal atom, the non-metal atom will, if you take the case of NaCl, what happens in NaCl? Sodium, which is metallic in nature, it loses one electron, gets converted into Na positive, and that one electron is completely gained by chlorine, and chlorine gets converted into Cl negative. Once Na positive and Cl negative is formed, after that, there will be interaction between them, and you call this interaction as the ionic bond. Perfect. Now here what happens basically, when metal atom loses electron, its size is decreased. And when non-metal atom gains electron, its size is increased, right? Its size is increased. So what has to be the answer of this particular question? You know, when metal atom loses electron, size decreases. When non-metal atom gains electron, its size increases. Perfect. So the answer of this particular question is the non-metal atom will gain electron and its size will increase. Right? Perfect. Simple and basic question this was. All right. What do you think about this particular question? As per this particular question is concerned, which of the following is not the correct representation of the Lewis symbols which are given to us? My dear students, we are given with carbon, we are given with oxygen, neon, beryllium, and boron, right? First of all, if you talk about carbon, in case of carbon, how many valence electrons are there? Sorry. How many valence electrons are there in carbon? There are 4 valence electrons. And if you look over here, all those 4 valence electrons are mentioned. So it is the correct symbol. In case of oxygen, there are 6 valence electrons, but out of 6, they have mentioned only 1, 2, 3, 4, and 5. So this is not the correct one, right? In case of neon, there are 8 valence electrons, and they have shown already only 6. So not the correct one. In case of beryllium, there are 2 valence electrons and all of them are shown. In case of boron, there are 3 valence electrons and all the 3 are shown, right? So which of the following does not represent? So 2 and 3 is going to be the answer of this particular question. It's again simple and basic, right? So the question can be asked on the base of Lewis structures as well. All right. Now, questions can be asked on the base of Fajan's rules as well. On the base of Fajan's rules, right? And as per Fajan's rules are concerned, covalent bond formation is favored by smaller sized cation and larger sized anion, right? Smaller sized cation and larger sized anion. Smaller sized cation and larger sized anion are going to favor the covalent bond formation. Correct? And do remember, few things I'm going to tell you here. Covalent character in an ionic compound. Covalent character in an ionic compound. It depends on 2 factors. One is polarizing power of cation. Number 1. One is polarizability of anion. Polarizability of anion. And remember, polarizing power of cation is directly proportional to charge on cation, inversely proportional to size of cation. Polarizability of anion is directly proportional to charge on anion, also directly proportional to the size of anion. These are the few things which you just need to remember. You can solve all the questions which are based on the Fajan's rules, right? Covalent character directly proportional to polarizing power of cation as well as polarizability of anion, right? Remember them. Now, if you remember them, tell me the answer of this particular question. Order of polarizability of anions. Order of polarizability of anions. We are given with the anions I negative, Br negative, Cl negative, F negative, right? F negative, Cl negative, Br negative, I negative. Tell me one thing. On moving from top to the bottom, size increases, right? And polarizability of anion is directly proportional to size of anion. More the size, more the polarizability. So I negative will have maximum polarizability among all. As simple as that. Right? As simple as that, people. I hope this is clear. Right? Perfect. Now, moving ahead. Let me give you one more question. What do you think about this particular question? What do you think about this particular question? Quickly. Quickly. Spammers have come. Spammers have come to the channel. Welcome, spammers. Welcome, welcome, welcome. What do you think about this particular question? It's a simple and basic one. It's simple and basic one. We are given with LiCl, BeCl2, BCl3 and CCl4, right? The covalent character order. Covalent character order. My dear students, if you look carefully, the charge on the cation here is +1, the charge on the cation here will be +2, the charge on the cation here will be +3, and the charge on cation here is +4. More the charge on cation, more the polarizing power of cation. And more polarizing power means more covalent character. So where do you see covalent character maximum? It is CCl4, where the covalent character will be maximum, right? So this is the order of the covalent character. Sometimes, my dear students, they'll ask you about the ionic character order. Do remember, ionic character, that will be just inversely proportional to covalent character. Ionic character will be just inversely proportional to what? Covalent character. Right? Perfect. I hope this is clear. Okay, solve one more question based on the same. Based on Fajan's rules, you will be getting the question, and this is basically the question. Look at the question carefully. The maximum covalent character is shown by. Maximum covalent character is shown by. If you look at all the substances that are given to us, try to understand. Aluminium here is in +3 oxidation state, +3 charge, +2 charge. Cesium, +1 group first element. This is +2. More the charge on cation, more the polarizing power, more the covalent character. More the covalent character. So it's AlCl3 which will have the maximum covalent character among all. Okay. Few more questions on the same. Right? What about this one? What do you think about this one? What about this one? What about this one? Quickly. You should be answering this particular question now. Select most ionic and most covalent. Most ionic and most covalent. First of all, in case of CrO5, what is the oxidation state of chromium? +6, butterfly structure. Butterfly structure CrO5, right? Manganese here, if you calculate its oxidation state, it is Mn2O7. It will be +7, right? Here, lead is in +2 oxidation state. Iron, +3 oxidation state. Tin, +4 oxidation state, right? More the charge on cation, more the polarizing power, more the covalent character, right? So which one will be maximum covalent? Maximum covalent will be Mn2O7. This will be maximum covalent. Maximum covalent. Which one will be maximum ionic? Maximum ionic means least covalent. Which one is least covalent? Lesser the charge, lesser the covalent character, more the ionic character. So this is most ionic, this is most covalent. So answer of this particular question has to be option B. Right? Right, people? Am I clear to everyone? Am I clear to everyone quickly in the chats? Right? Perfect. Moving on to one more. Similar sort of question I'm going to give you. And this is going to be the last question of the Fajan's rules. Look at the question. Tell me the answer of this particular question. Same things you need to remember. That's all. Same things you'll be remembering. That's all. Arrange the following in increasing order of covalent character. Increasing order of covalent character. Increasing order of covalent character. This is Na positive. This is Rb positive. Mg di positive. Al tri positive. So more the charge on cation, more the polarizing power of cation, more the covalent character. So AlCl3 will have the maximum covalent character. AlCl3 will have the maximum covalent character. Followed by MgCl2, right? Followed by MgCl2. Now, among NaCl and RbCl, charge on both the cations is same. Now talk about size. Lesser the size of cation, more the polarizing power. More the polarizing power means more the covalent character. So one will come here and here will be the 2. So this is the increasing order of the covalent character, right? This is the increasing order of the covalent character. I hope I'm clear to everyone. Moving ahead, my dear students, moving ahead. Questions can be asked from the dipole moment as well. Questions can be asked from the dipole moment as well. From dipole moment as well. First of all, remember few things. Whenever you see the molecule of the type Ab2L0, Ab3L0, Ab4L0, Ab5L0, Ab6L0, Ab4L2, and Ab2L3. Whenever you see these type of the molecules anywhere, remember their net dipole moment is 0. Those molecules wherein net dipole moment are 0, they are considered to be non-polar molecules. They are considered to be non-polar molecules. Now, I believe you can easily solve this particular question. So first of all, if you talk about BF3, if I want to check the type of the molecule, how do I check the type of the molecule? Have a look first of all. Boron, its valence electrons are 3. How many surrounding atoms it has? It has 3 surrounding atoms. Number of surrounding atoms is equal to the number of sigma bonds. Number of surrounding atoms is equal to the number of sigma bonds, right? Now, boron had 3 valence electrons and it has utilized all the 3 valence electrons to form 3 sigma bonds. That means there'll be no lone pair on boron. No lone pair. Now, if I ask you the type of the molecule, it's going to be A. A is the central atom, which is B, right? Now, sigma is 3, so it is Ab3. Lone pair 0, so it is Ab3L0. And Ab3L0 comes in this category wherein net dipole moment is 0. Similarly, if you talk about BF2, BF2 comes in the category of Ab2L0, dipole moment 0, net dipole moment 0, right? Similarly, carbon dioxide, CO2. CO2 again comes into the category of Ab2L0, right? When you check it, again dipole moment 0. And 1,4-dichlorobenzene, it already has the net dipole moment of 0, right? Perfect. I hope I'm clear to every one of you. So correct answer of this particular question is absolutely going to be option C. One more question I'm giving you on the basis of dipole moment. Let me see if you can solve this one or not. First of all, how do you check the dipole moment? You check the electronegativity difference. You check the electronegativity difference. Generally, in majority of the cases, more the electronegativity difference, more is the dipole moment. More the electronegativity difference, more is the dipole moment. Now, over here, if you look at all these cases, OH, NH, NF, BF, where do you see the electronegativity difference the maximum? Electronegativity difference is maximum in case of water, right? Between O and H, right? Between O and H, perfect. More the electronegativity difference, more is going to be the dipole moment. So water will be having the maximum dipole moment. Water will be having the maximum dipole moment. Now, among NH3 and NF3, if you talk about NH3, this is your NH3, and over here, let me write NF3 as well. Perfect. Over here, nitrogen has got the lone pair. Nitrogen has got the lone pair. First of all, you should be knowing lone pair also contributes towards the moment, and the direction of moment due to lone pair is towards the lone pair. Right? Nitrogen, hydrogen. Less electronegative, more electronegative. Dipole moment direction will be from less electronegative to more electronegative. From less electronegative towards more. From less towards more. Similarly, more electronegative, less. From less to more. From less to more. From less to more. If you check both, here all the four moments, they are converging in one direction. Here there will be cancellation because one is upside, other ones are downside. So cancellation will happen here, cancellation will not happen here, right? So I would say net dipole moment will be maximum in case of NH3, right? Among NH3 and NF3, it's going to be NH3 where the dipole moment will be more. Okay? In case of NH3, dipole moment will be more than that of NF3. So first of all, I'll give priority to water, then I'll give priority to NH3, then I'll give priority to NF3. BF3 will be having zero dipole moment because its type is AB3L0. Okay? Its type is AB3L0. I hope I'm clear with this particular question as well. All right, now you tell me the answer of this particular question. It's very simple and basic. What do you think about this one? You have got a neutral molecule XF3, which has zero dipole moment. What is X? You saw it a few minutes back. It is BF3. Wherein the net dipole moment is zero. Correct? So, X has to be B. Done? Again, this is one simple and basic question which can be asked from the dipole moment part. Okay, which of the following molecule is polar? I told you a few minutes back, those molecules wherein net dipole moment is zero, that is non-polar. And those molecules wherein net dipole moment is non-zero, those are what you call as polar molecules. First of all, my dear students, I would want you guys to check the type of the molecules. This is AB3L0. When you check the type of this molecule, it will be AB4L2. This will be AB4L0. And this will be AB4L1. AB4L1 type. You can check it out too. See how do we check. For example, SF4. Sulfur is the central atom. So how many valence electrons it has? It has got 6 valence electrons because it belongs to oxygen family, right? Now, how many sigma bonds it's forming? It's forming 4 sigma bonds. Out of 6 valence electrons, 4 are used to form 4 sigma bonds. So there are 2 electrons left as such on sulfur in the form of a lone pair. So 1 lone pair. So type of the molecule will be AB4L1. AB4L1. This is how you check the type of the molecule. Already I've told you these 3 types, right? They'll be having net dipole moment 0. So they'll be non-polar. This will be polar. Its net dipole moment will be non-zero. Correct? I hope this sort of equation you can solve from now on. Again, which of the following molecules possesses the dipole moment? So what do you have to do? Just check the type. Just check the type. Just check the type of the molecule. Check the type of the molecule everywhere. Everywhere. First of all, in case of SF6, when you check the type of the molecule, it will be AB6L0. SO2. This will be AB2L1. When you check it, H2S. 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 It will be AB2L2. Right? SF4. It will be AB4L1. AB4L1. Which of the following molecules possesses the dipole moment? This will not possess the dipole moment. This will possess, this will possess, this will possess. So B, C, and D is going to be the answer of the question. So simple, whatever I told you, check the type of the molecule, then accordingly go ahead and write your answers. That's all. That's all, people. That's all. Okay. Some questions will be asked from VBT as well, valence bond theory. Right? Some questions will be asked from VBT, valence bond theory as well. PP overlapping will be observed in which molecule? PP overlapping. Is it in case of hydrogen molecule? In case of HBr? In case of HCl? In case of Cl2? Right? In case of H2 molecule, there will be SS overlapping because 1s of hydrogen and 1s of hydrogen, they'll do the SS overlapping. In case of HBr, hydrogen, it's 1s, and bromine, it's p orbital, outermost p orbital, they'll do the overlapping. This is sp overlapping. Similarly, over here in this particular case, this is going to be sp overlapping. But in case of Cl2, one chlorine, one more chlorine, one chlorine's p and another chlorine's p, they'll do the pp overlapping here. So it is Cl2 molecule wherein you'll observe the pp overlapping. Right? Yes. If you want to see it in the detailed form, have a look again. If I talk about Cl2 molecule, this is one Cl, this is one more Cl. If I ask you about the outermost configuration of Cl, it is 3p5. Here also the outermost configuration, you know, it is 3p5. Now, my dear students, 3p5 configuration, when you make it, 1, 2, 3, 4, 5. In the similar way here, 3p5, 1, 2, 3, 4, 5. Let's call this as px, or let's call this as pz, let's call this as px, let's call this as py. Similarly, let's call this as pz, let's call this as px, let's call this as py. Right? Okay. This is the internuclear axis, which is generally your z-axis. Your internuclear axis. If you talk about this chlorine atom, right? This is its pz containing 1 electron, right? This is its py containing 2 electrons, and this is its one more p containing 2 more electrons. Similarly, this particular p, it is pz containing 1 electron, which has overlapped here, 1 p containing 2 electrons, and one more p containing 2 electrons. Do you see over here, head-on overlap has happened, right? Axial overlap, which leads to the formation of which bond? It leads to the formation of sigma bond. So what kind of overlapping I'll be calling it? I'll be calling it as PP overlap, right? I'll be calling it as the PP overlapping. I hope I'm clear. I'm moving ahead. I am moving ahead. What do you think is the answer of this particular question? This everyone should at least, I mean, this is pretty much simple. The angle between the overlapping of 1s and 1p. This is 1s and this is p. S and p. S and p. How they are going to overlap? At an angle of 180. At an angle of 180. Which of the following represents zero overlap? Zero overlap. See guys, how do we check it? First of all, positive, positive. Same sign, same side. Same sign, same side. Same sign, same side means positive overlap. Opposite sign, same side. Opposite sign, same side means negative overlap. Do you see any case of overlap here? Here the orientation is different. There will be no overlap. Zero overlap. Right? So it is zero overlap. The more questions can be asked wherein you have to check where is the positive overlap happening, where is the negative overlap happening. Perfect. Be careful with those questions as well. Okay. One simple and basic question, which I believe everyone will easily solve. Which of the following is having maximum bond energy? Maximum bond energy. See guys, see here we have got 3 bonds, 2 bonds, 1 bond. More the bonds, more the attraction. More the attraction means more energy is needed to break it. So C triple bond C will have maximum, followed by C double bond C, followed by C single bond C. Right? It's again one simple basic question. Okay. All right. This is one more. And guys, bonding questions are considered to be very easy, right? And less time consuming. Okay. Minimum 3 to 4 questions from this chapter. The molecule not having pi bonds. The molecule not having pi bonds. See guys, you already know this structure, right? This is CO2. This is N2. This is O2. And this is Cl2. So where you are not seeing any pi bond, it's Cl2. Right? You already know their structures. You already know their structures. All right. From left to right. sp2, sp2, sp, sp. Where? Where exactly? If you look at the second option, my dear students, if you look at the second option, here carbon is forming 3 sigma bonds. 3 sigma bonds means sp2. Here carbon is forming again 3 sigma bonds. One with this carbon, one with this carbon, one with hydrogen. So sp2. 2 sigma bonds, sp. 2 sigma bonds, sp. So sp2, sp2, sp and sp. Correct? Why would you write option D? In option D, here carbon is forming 3 sigma bonds. This sp2, this is sp2, this is sp2, even this is sp2, right? 3 sigma bonds everywhere. All right. Tell me the answer of this particular question. In the octahedral structure, the pair of d orbitals involved in the hybridization. Let me tell you. In case of sp3d hybridization, which d orbital participates in the intermixing? It's dz square. In case of sp3d2, which two d orbitals participate in intermixing? Do remember it is dx square minus y square and dz square. In case of sp3d3 hybridization, which d orbitals? It is dx square minus y square, it is dz square and it is dxy. Remember, anything can be asked out of these three. Anything can be asked out of these three. Anything can be asked out of these three. And in case of this, we have got option A. Option A. See, look at this particular question. Now, I believe you should be in a position to solve this question on your own. ASF5. ASF5. Correct? ASF5. This is your central atom, which belongs to nitrogen family. How many valence electrons it has? 5. How many sigma bonds? 5. How many lone pairs? 0. How do you calculate the steric number? Steric number is 5 plus 0. That is 5. This plus this gives you the steric number. If steric number is 5, you know hybridization is sp3d. If hybridization is sp3d, it is going to be s orbital, 3 p orbitals, which includes px, py, pz, and which d orbital? It is going to be dz square, which will participate in the hybridization. Right? Which will participate in the hybridization. I believe it's clear. I believe it's clear. Right? The questions can be based on the hybridization as well. Questions can be asked on the basis of hybridization as well. And for sure, question will be asked from hybridization. And how do you check the hybridization? Steric number, sigma plus lone pair. If steric number is 2, sp. If it is 3, sp2. Steric number 4, sp3. Steric number 5, sp3d. Steric number 6, sp3d2. Steric number 7, sp3d3. That's all. The correct geometry and hybridization of XCF4. Check it once again so that you get familiar with the hybridization concept. XCF4. This is your central atom. How many valence electrons? 8. How many sigma bonds? 4 sigma bonds. So out of 8 valence electrons, 4 of the valence electrons have been used to form 4 sigma bonds. So there'll be 4 valence electrons left as such on xenon. Left as such on xenon in the form of how many lone pairs? In the form of 2 lone pairs. So steric number has to be 4 plus 2, that is 6. Hybridization has to be sp3d2. And the geometry predicted through hybridization, sp3d2, it has to be octahedral. Geometry, it has to be octahedral. Octahedral geometry, right? Octahedral geometry. Octahedral geometry. Now, if they ask you about the shape, since the type of the molecule is AB4L2, AB4L2 means square planar. Square planar, right? Square planar. Guys, I'm going to modify this question. It should not confuse you. Write it as the correct shape. The correct shape and hybridization of XCF4. It is going to be square planar and sp3d2. Okay? Perfect. I hope this is clear. All right, one more similar type of question which you can solve. In case of which species you will find the bond angle 120. Bond angle is 120 in case of AB3L0. Bond angle is 120 in case of AB3L0. Correct? In case of AB3L0, bond angle is 120. Now, which one is AB3L0 type? Which one is AB3L0 type? This one is AB3L0 type. So done. Right? Absolutely, you're all perfectly right. Good going. Okay. You know the expected bond angle in case of water. Since water undergoes sp3 hybridization. So expected bond angle is 100, 928 minutes. But its actual bond angle is 104 degree 5 minutes. Reason? Reason is lone pair repulsion. Right? Reason is your lone pair repulsion. So remember this in case of water. Why the bond angle completely shrinks from 109.28 to 104.5? What is the reason? Because of the lone pair repulsions. Okay? All right, what do you think about this particular question? Look at it. Select the correct statement regarding the shapes of PCl5. So one molecule is your PCl5, one more is your BRF5, one more is your IF7. One more is your IF7. Okay. If you look at the type of this molecule, this is AB5L0. This is AB5L1 when you check. This is AB7L0. Right? AB5L0 means trigonal bipyramidal. AB5L1 means square pyramidal. Square pyramidal. And AB7L0 means pentagonal bipyramidal. Correct? Pentagonal bipyramidal. Now tell me the answer. All are square pyramidal? No. All are trigonal bipyramidal? No. One of the given compound is square pyramidal? Yes. So option C has to be the correct answer of this question. Yes. Option C has to be the correct answer of this particular question. Okay, one more simple question, which I believe you can easily solve. Which of the following molecules has more than one lone pair? More than one lone pair. Carbon here will be having 0 lone pair, forming 4 bonds. Silicon, 0 lone pair. Xenon, 3 lone pairs. Correct? Sulfur, 1 lone pair. Correct? So what has to be answer? Answer has to be option B. Absolutely. Absolutely. Okay, question can be asked in terms of isostructural compounds. The question says XCF2 is isostructural with. See how do we check it? What is the type of this XCF2? It is AB2L3. AB2L3. Now check which of the following is of the same type. How do I check it? ICl2 negative. Iodine is the central atom. So how many valence electrons? Iodine has got 7. There's a negative charge as 1. So 7 plus 1 comes out to be 8. How many surrounding atoms? 2. So sigma bonds 2. How many lone pairs? Out of 8 valence electrons, 2 have been used. So there'll be 6 valence electrons left as such on iodine in the form of 3 lone pairs. So the type of the molecule here is AB2L3, right? What was the given type of the molecule? That is AB2L3. This one is also AB2L3. So they are going to be isostructural. So basically, you need to check the type of the molecule. If the type of the molecule is same, definitely isostructural. Okay, definitely isostructural. Just a second. Tell me the answer of this question. These sort of questions are also asked in which you have to match columns. Identify the wrongly matched pair. You have to identify the wrongly matched pair. What do you think? What do you think about this one? Be very quick. Identify the wrongly matched pair. Quickly. Exactly. If you see PCl5 has got a type AB5L0. So it has to be trigonal bipyramidal. But over here they mentioned as trigonal planar, which is not the case. Rest everything is same. Everything is correct only. What do you think about this one? This again, you should easily solve. Which type of hybridization is involved in XeOF4? Check it out quickly. See, xenon is the central atom, so 8 valence electrons. How many surrounding atoms? 4 plus 1, 5. Number of surrounding atoms is equal to number of sigma bonds. Now, how many lone pairs? Check. Out of 8 valence electrons, right? How many valence electrons have been utilized in bonding? 4 for this, 2 for this, because oxygen is divalent. So 4 to 6. Out of 8, 6 are used. So 2 valence electrons are left as such in the form of one lone pair. So steric number is 5 plus 1, 6. Type of the molecule is AB5L1. Hybridization involved is sp3d2, right? sp3d2. Absolutely, you all are perfectly right. It's option C, which is the correct answer of this question. Which of the following are isoelectronic and isostructural? The question is and isostructural. Isoelectronic as well as isostructural. We'll check the isostructural ones accordingly. I mean, the question is and isostructural. Isoelectronic and isostructural. Perfect. What do you think? What do you think? You're super quick. People are saying option B. Wow, nice. What is the type of both of them? Type of this molecule is AB2L3. Type of this molecule also is AB2L3. Correct? So they are going to be isostructural, and when you check their electrons, they are going to be isoelectronic at the same time. Yes, 2023 PYQ. Right? Tell me the answer of this question. Tell me the answer of this question. Tell me the answer of this particular question. Match 1 with 2. XEF4. XEF4 means AB4L2. Square planar. XCF6. AB6L1. AB6L1. Distorted octahedral. Right? XCO3. AB3L1. AB3L1 means pyramidal. Right? And here you can attach with this. Done? Done, people? Is it clear? I believe this particular question is also clear to you. Okay, this is one more question which was asked last year in the JEE Mains. Simple question, this is basic question. NO2 negative, NO2 positive, NH4 positive, hybridization. Quickly. Quickly, people. What do you think about this one? NO2 negative, NO2 positive, NH4 positive. How do you check this? First of all, I'm writing over here as NO2 negative. NO2 negative. How many valence electrons nitrogen has? 5. 5 plus 1 makes it 6. Sigma bonds? 2. Lone pairs? Out of 6, 4 have been used because oxygen is divalent. Right? 4 have been used. So 2 electrons as such means 1 lone pair. Steric number 2 plus 1, 3. So this sp2. In case of your NO2 positive, here the hybridization will be sp. In case of your NH4 positive, here the hybridization will be sp3, right, for nitrogen. Okay? It's again a simple question which was given to us. All right. What do you think about this one? Think over it. Think over this particular question. Which of the following structure is most stable? Which is most stable among all? Which one is most stable among all? Which one is most stable? The molecule is ClF3, first of all. The molecule is ClF3. If I ask you, what is the type of this molecule, ClF3? What is the type of this molecule? This is AB3L2. AB3L2. What is the shape of AB3L2? It is T-shaped, right? Which one of the following is T-shaped? Which of the following is T-shaped? If you hide these lone pairs, it is T-shaped. So this is the most stable one, right? As per VSCPR, molecule tries to acquire that shape wherein repulsions are minimum, stability is maximum. And in case of AB3L2, that shape is T-shaped, right? So T-shaped one is the most stable one among all, right? Perfect, guys. All right, which of the following is not expected to exist? Which of the following is not expected to exist? That particular species whose bond order comes out to be less or equal to 0. Less or equal to 0. That molecule does not exist. That is non-viable. Does not exist. Non-viable. And how do you calculate this bond order? It is half of number of electrons in bonding minus number of electrons in anti-bonding. Right? So first of all, you need to know how to write the molecular orbital configuration. First, when you write the molecular orbital configuration, after writing the molecular orbital configuration, you'll have to use this formula, get the bond order. Accordingly, you can decide whether the molecule exists or not. For example, look here. He2 positive, He2 positive. There'll be how many electrons? In one helium atom, 2 electrons. In 2 helium atom, 4 electrons. But there's a positive charge, so 4 minus 1, 3. So in total, 3 electrons. So the molecular orbital configuration comes out to be sigma 1 is 2, sigma star 1 is 1. So there are 2 bonding electrons, 1 anti-bonding. So 2 bonding minus anti-bonding divided by 2. The bond order here is 1 by 2, right? Here you have got only bonding electron, right? 1, anti-bonding is 0 divided by 2. Here also 1 by 2. In case of B2, bonding, so 4 bonding minus, how many anti-bonding? 4. So 4 minus 4 divided by 2. The value comes out to be 0. And wherever bond order is 0, that molecule does not exist. Perfect? Am I clear with this? Am I clear with this? In this particular molecule, I mean, which of the molecule does not exist here? What do you think? If you talk about He2, in case of He2, how many electrons are there in total? 2 to 4. 4 electrons. So sigma 1 is 2. Sigma star 1 is 2. So 2 bonding to anti-bonding. So 2 minus 2 divided by 2. 2 minus 2 divided by 2. The value will be 0. Bond order 0 means does not exist. Bond order 0 means does not exist. All right. There is one more set of questions that's asked. Which of the following species is paramagnetic? Which of the following species is paramagnetic? First of all, in order to check whether the species is paramagnetic or not, what are you supposed to do? You are supposed to write the molecular orbital configuration. You are supposed to write the molecular orbital configuration. And once you write the molecular orbital configuration, just check are there any unpaired electrons? Are there any unpaired electrons? If there are unpaired electrons, directly paramagnetic. If there are unpaired electrons, directly what? Paramagnetic. For example, if you talk about O2, when you write this molecular orbital configuration, there will be 2 unpaired electrons. There will be 2 unpaired electrons. You can check it out. There will be 2 unpaired electrons in case of O2. One in pi star 2px, one in pi star 2py. There are 2 unpaired electrons. If there are 2 unpaired electrons, then it is supposed to be what? It is supposed to be absolutely what? Paramagnetic. I hope this is clear. I hope this is clear. I hope this is clear. Okay. One more question can be asked here. Remember, isoelectronic species. Isoelectronic species are the ones which have got same bond order. Isoelectronic species are the ones which have got same number of electrons. Isoelectronic species, they always have what? They always have same bond order, right? Now, check which of the following are isoelectronic species. Let me first of all write it. Isoelectronic species are they have got, their bond order is same. Now, which of the following are isoelectronic? If you talk about CN negative, carbon has got 6 electrons, nitrogen has got 7 electrons, there is a negative charge, so 14 electrons in total. CO, carbon has got 6 electrons and oxygen has got 8 electrons, so 14 electrons. So both of them have got same electrons. Same electrons means isoelectronic. Isoelectronic have always same bond order. Their bond order is same. Okay? Right? And at the same time, do you remember all the 14 electron species, their bond order will be 3. 15 electron species, their bond order will be 2.5. 16 electron species, their bond order will be 2. 17 electron species, their bond order will be 1.5. 18 electron species, their bond order will be 1. Similarly, 13 electron species, bond order 2.5. 12 electron species, bond order 2. 11 electron species, 1.5. 10 electron species, bond order 1. So you can remember this particular order as well, just as the shortcut. Just as the shortcut. Okay, just as the shortcut. What do you think about this one? You should be answering this particular question as well. You should be answering this particular question as well. The common features among the species, Cn negative, CO, NO positive. First of all, they are isoelectronic. They have got 14 electrons. They have got in total 14 electrons. They are isoelectronic. Number one. If they are isoelectronic, they have got 14 electrons. That means their bond order will be 3. Right? Perfect. So all of you have come up with option A. Absolutely, it's option A. Bond order 3 as well as isoelectronic. Yes? Perfect. Perfect, guys. What should be the answer of this question? Guys, you know, your bond order is directly proportional to bond dissociation energy, right? Which is inversely proportional to what? Which is inversely proportional to bond length. In short, more the bond order means more the bonds. Correct? More will be the bond dissociation energy and lesser absolutely will be the bond length. What do you think? What do you think? See, O2, it's a 16 electron species. This is 17 electron species. This is 14 electron species. 14 electron species will have the bond order of 3. 16 electron species 2. This will have 1.5. Right? We have to arrange them on the basis of bond dissociation energy. More the bond order, more the bond dissociation energy. So N2 will have maximum, followed by O2, followed by O2 negative. So it has to be option C. It has to be option C. Right? It has to be option C. What do you think about this particular question? It's simple. Again, it's simple. Again, very simple. N2 is a 14 electron species and N2 positive is a 13 electron species. So its bond order is 3. Its bond order is 2.5. More the bond order, more the bond dissociation energy. More the bond order, more the bond dissociation energy. Right? Absolutely, all of you are perfectly right. It has to be option C. Wonderful. Good job. Right? So with this, your chemical bonding is over. So in chemical bonding, remember the question will be either asked from Pajan's rules or from dipole moment or from valence bond theory or from hybridization or from MOT, wherein you have to check the bond order, etc., etc. I hope I'm clear with all these things. Are all these things clear? All these things clear? Yes or no in the chats, quick? I'm moving on to the chapter. Let's move on to the chapter thermodynamics. Recently, we have completed the chapter thermodynamics. Have you watched that? Have you watched thermodynamics, by the way? Have you watched thermodynamics? Say yes or no once in the chats. I want to know. I want to know. Right? It's going to be easy. If you have watched the thermodynamics chapter, you can easily solve all the questions which I have come up with. Easily you can solve. The first and the basic question. Out of all these terms, internal energy, boiling point, pH and EMF, intensive properties are, see, internal energy. First of all, what are extensive intensive properties? You should be knowing it now. What are extensive intensive properties? Extensive properties are the ones which are size dependent, right? Extensive properties are the ones whose value changes on changing the size of the system, whose value changes on changing the amount of substance present in the system. Intensive properties are the ones whose value does not change when you change the size of the system or the amount of substance in the system. Internal energy, it is the example of extensive property. Extensive. Boiling point, it is the example of intensive property. Right? pH, it is the example of intensive property. EMF, it is the example of intensive property. So it is basically boiling point, pH and EMF. Here are the examples of what? They're intensive properties. We have discussed this in detail if you remember. Okay, number 1. Number 2, which of the following are not the state functions? Are not. They are saying which of the following are not state functions. See, Q plus W is internal energy. Internal energy is the state function, right? Heat is a path function. Work is a path function. H minus Ts gives free energy. That's the state function. That's the state function, right? So Q, heat and work, they are the examples of the path functions. I was asked to check which of the following are not state functions, right? Are not state functions means which of the following are path functions. It is heat and work, which are the examples of what? Which are the examples of path functions. I believe it's clear. What do you think is the answer of this particular question? What do you think? When freezing of liquid takes place, during freezing of liquid, when liquid freezes, heat is absorbed or released? Just tell me that. When liquid freezes, heat is absorbed or released? Just tell me that. When a liquid freezes, heat is released by the system. And when heat is released by the system, Q value is taken to be negative. Q value is taken to be negative. Two sign conventions, guys, if you remember. When heat is absorbed, Q value is positive. When heat is released by the system, Q value is negative. Whenever there is expansion, work is done by the system and W value is taken to be negative in chemistry. Whenever there is compression, work is done on the system and W value as per sign convention is taken to be positive. All these things I believe you already know, right? Okay, moving ahead. What about this particular question? What about this particular question? 3 moles of an ideal gas. 3 moles of an ideal gas are expanded in vacuum. The work done is 3 moles of ideal gas are expanded in vacuum. Work done is. Expansion in vacuum is what you call as free expansion, right? Expansion in vacuum is what you call as free expansion. In free expansion, W is always 0, correct? W is always 0. All right. A given mass of the gas expands reversibly from state A to state B. From state A to state B. By these 3 paths, 1, 2, and 3. If W1, W2, W3 respectively be the work done by the gas along these 3 paths, magnitude of work. Where is the magnitude of work more? To path 1, path 2, or path 3? You know, area under the PV curve. Area under the PV curve. Area under the PV curve. It gives us the magnitude of work. It gives us the magnitude of work. Now, area under which curve is maximum? Area under which curve is maximum? Area under this third curve is maximum, right? Followed by second one, followed by first one, right? More the area under curve, more is going to be the magnitude of work. So 3 to 1 is going to be the answer. Perfect. 3 to 1 is going to be the answer. Perfect. All right. What do you think about this particular question? Look at the question. 1 mole of an ideal gas at 25 degrees centigrade expands from 1 liter to 4 liters at constant temperature. What work is done if the gas expansion is happening in vacuum? You are not supposed to solve this question. I told you a few minutes back only. Expansion in vacuum is called as free expansion. In free expansion, W value is 0. In free expansion, W value is 0. Right? Okay. Look at this one. An ideal gas is allowed to expand from 1 liter to 10 liters. From 1 liter to 10 liters. Against a constant external pressure of 1 bar. Expansion of the gas is happening against a constant external pressure. If external pressure is constant, should I be calling this process reversible or irreversible? I'll be calling this particular process irreversible, right? Irreversible. And in case of irreversible process, how do we calculate W? W irreversible is simply minus P external multiplied by delta V, which is V2 minus V1. Correct? So minus, what is P external? External is 1 bar. V2 minus V1, 10 minus 1 is 9. Right? So the value comes out to be minus 9. Pressure was in bar, volume in liter. So it is bar liter. Minus 9 bar liter. So W is equal to minus 9 bar liter. Perfect? Minus 9 bar liter. But wait, do we have to calculate it in bar liter on kilojoules? I have to calculate it in kilojoules. You must be knowing 1 bar liter is equal to 100 joules. Right? Now the answer is in joules. If I divide it with 1000, now it comes in kilojoules. Right? So the answer is going to be minus 0.9 kilojoules. So this is the answer. Option 3 is the one. Option 3 is the one. I hope I'm clear. I hope I'm clear. Yes? Are you finding thermodynamics easy now or difficult? If you have watched the session of thermodynamics, which I've taught in detail, right, you can easily, my dear students, solve these sort of questions. I'm moving ahead. I am moving ahead. I am moving ahead. Look at this particular question carefully. Look at this particular question carefully. The molar heat capacity of water at constant pressure, molar heat capacity at constant pressure is given as 75 joules per Kelvin per mole. Okay. When 1 kg of heat is supplied, when heat is supplied means Q value positive. So 1 kilojoule. When 1 kilojoule of heat is supplied to 100 grams of water. 100 grams of water means how many moles of water? Given mass of water divided by molar mass of water, which is free to expand. The increase in the temperature of the water, delta T, we have to calculate. Delta T, we have to calculate. Can't we solve this? Can't we solve this? My dear students, heat absorbed or released at constant pressure is represented by QP. Heat absorbed or released at constant pressure is represented by QP. And QP, you already know, it is equal to NCP delta T. QP is equal to 1000 joules, is equal to N value is 100 by 18. CP value is 75. Delta T, we have to calculate. That's all. So this cancel. It's going to be 180 divided by 75. 180 divided by 75 is the value of delta T, right? Which comes out to be 2.4 Kelvin. Which comes out to be 2.4 Kelvin. Simple. See, heat absorbed or released at constant pressure is QP. Heat absorbed or released at constant volume, you know, that is QV, which is equal to NCV delta T, right? Which is equal to NCV delta T. And you should be doing one more thing. Heat absorbed or released at constant pressure is something which you call as delta H. And heat absorbed or released at constant volume is something which you call as delta U. So they could have asked the question in terms of directly delta U or delta H as well. Perfect. This question you already know. For 1 mole of ideal gas, Cp minus Cv is R. For 2 moles of ideal gas, Cp minus Cv is 2R. Cp minus Cv is 2R. Correct? Look at this question. In the closed insulated container, closed insulated. So Q value 0, no heat exchange because it's insulated. A liquid is stirred with a paddle to increase its temperature. Which of the following is true? Which of the following is true? Q is equal to 0. If you use delta U is equal to Q plus W. Delta U is equal to Q plus W. Since Q is 0, so delta U will be equal to W. Since we are stirring the liquid, so work is done on the system. Work is done on the system. So some work is done on the system. So W is non-zero. W non-zero, that means delta U will be non-zero, but Q is 0. So look at the options. Delta U is equal to W, both are non-zero, but Q is 0. So option A has to be the correct answer of this particular question as well. Right? Moving ahead. Moving ahead. Simple and basic question. Okay, let's not solve this. Wait, I'm going to different question. Look at this one. Look at this one. During the compression of the spring, you are compressing a spring. Work done is 10 kilojoules. First of all, we are compressing the spring. So is work done by the spring or on the spring? Work is done on the spring. Work is done on the system. Whenever work is done on the system, W value is taken to be positive. So W is equal to plus 10 kilojoules. Right? 2 kilojoules of heat escape to the surroundings. 2 kilojoules of heat is escaping to the surroundings. That means heat is absorbed or released. Heat is released. It is released by the system. It is going towards surroundings. Right? Heat is released by the system. And whenever heat is released by the system, Q value is taken to be negative. So it's minus 2 kilojoules. So you got the W, you got the Q. You know your delta U. Delta U is nothing but Q plus W. And delta U is equal to Q plus W. Q is minus 2. W is 10. The value comes out to be 8 kilojoules. So the value of delta U comes out to be 8 kilojoules over here. I hope it's clear. I hope it is clear again. Right? I hope it's clear. Moving on to one more. Look at this particular question. An ideal gas expands against a constant external pressure. Constant external pressure simply tells you the process is irreversible. From 20 liters to 40 liters and absorbs this much. What is the change in internal energy? It's again simple. So you can use the first law of thermodynamics. Delta U is equal to Q plus W. Delta U is equal to Q plus W and W here is irreversible. So first of all, my first thing, I'll be calculating W. I will be calculating W. W irreversible is equal to minus P external delta V. W irreversible is equal to minus P external delta V. What is P external? P external is 2 atm. Delta V, change in volume. 40 minus 20 comes out to be 20. So W irreversible is equal to minus 40 atm liter. Minus 40 atm liter, right? So you all must be knowing 1 atm liter is what? 101.3 joules. So this is the value of W. Since you got the value of W, Q value is given to us. It is mentioned that system absorbs 10 kg of heat. If system absorbs 10 kilojoules of heat, heat absorbed in the system means Q positive. Q is 10 kilojoules, right? So delta U has to be equal. Delta U has to be equaled. Q is 10 kilojoules, so 10,000 joules. W is this much. W is minus 40 multiplied by 101.3, right? So solve this, get the value of delta U, which you were supposed to calculate. Is it clear? Again, one simple question based on first law of thermodynamics, right? Based on first law of thermodynamics. Tell me the answer of this question. What do you think? Tell me the answer of this question. Delta U is equal to, delta U is equal to Q plus W. Delta U is equal to Q plus W. Actually delta U is equal to Q plus W. Now, when delta U will be equal to W? Delta U will be equal to W when Q is 0, right? So can I say, in short, delta U is equal to W adiabatic? Delta U is equal to W adiabatic. So delta U is basically equal to adiabatic work. Yes. Delta U is equal to what? It is equal to adiabatic work. Moving on. Look at one more question. Let's see what the question says. When 1 mole of the gas is heated at constant volume, 1 mole of gas is heated at constant volume. Constant volume means isochoric. Isochoric means W value 0. W value 0, okay. Temperature is raised from this to this. If heat is supplied to the gas, so the gas is absorbing heat. So Q value is plus 500. Then which statement is right? Again, question based on first law. Delta U is equal to Q plus W. Correct? W is 0. So delta U is equal to Q, and Q already, that's 500 joules. So Q is equal to delta U is equal to 500, and W already is 0. Find the option. Delta U is equal to Q is equal to 500, and W value is 0. So this is the answer. Yes? Simple? And guys, these sort of questions are asked in your NEET examination. These basic, simple questions. I don't know why people find thermodynamics tough. Okay. What about this one? What about this one? You are given with the graph between enthalpy versus temperature. You are given with the graph between enthalpy versus temperature. And this graph, it is valid for 1 mole of ideal gas. It is valid for 1 mole of ideal gas. Now you have to check where Cp value is more. Is Cp more at A or Cp more at B? Where is the Cp value more? At A or B? Quickly. I need to turn the light off because the electricity cut. Where is the Cp value more? At A or B? As you know, your dH is equal to n Cp dt for an ideal gas. If you'll be having 1 mole of ideal gas, then n is 1. So I'll say Cp is equal to dH upon dt. What is meant by dH upon dt? dH upon dt gives you the slope of tangent at a point on enthalpy versus temperature curve. So more the slope of the tangent, more the Cp value. What you need to do over here is just draw the tangent here. Let's say it's making the angle theta A. Draw the tangent here. Let's say it is making the angle theta B. Now, which angle is more? Theta A. Where is the slope of the tangent more? Slope of the tangent is more here. More the slope of the tangent, more the Cp value. So Cp at A will be more than that of Cp at B. Correct? Cp at A will be more than that of Cp at B. I hope this particular question is again clear to every one of you. All right, look at this question. Again, one simple and basic question. We are given with a reaction which is carried out at constant temperature. delta H minus delta U value we have to calculate. First of all, for a gaseous phase reaction carried out at constant temperature, you know delta H is equal delta U plus delta NGRT. So delta H minus delta U has to be equal to delta NGRT. We have to get the value of this delta H minus delta U. Now, delta Ng first of all. Delta Ng is number of moles of gaseous products. This is the gaseous product minus number of moles of gaseous reactant. So 1 plus 5. 1 plus 5 is 6. So the value is minus 3. So the value comes out to be minus 3 RT. Simple. Option C is the one. Yes, delta H is equal to delta U plus delta NGRT, right? Perfect. One simple and basic question that was. All right. Look at this particular question. Look at this particular question. You have got the reaction when calculate the work done when 4.5 grams of H2O2. Okay. Reacts against a pressure of 180 by 25 degrees centigrade. We have to calculate work done. How do you calculate it? First of all, understand. This result already you must be knowing W is equal to minus delta NGRT. Correct? So first of all, if I ask you about the delta Ng value for this particular reaction, number of moles of gaseous product, that is 1, minus 0. There is no gaseous reactant. So delta Ng is 1 first of all. If delta Ng is 1, W is equal to minus 1, right? R value will be equal to 8.314 joules per Kelvin per mole. Temperature is 25 degrees centigrade, that means 298 Kelvin. Here the W value will come in joules, right? But, this is the value of W. This is the value of W when 2 moles of H2O2 are undergoing what? When 2 moles of H2O2 are participating, right? In the reaction, you are starting with 2 moles of H2O2. This is the value of W for 2 moles of H2O2. But as per the question, we are given with 4.5 grams of H2O2. That means how many moles of H2O2? It will be given mass of H2O2 in grams divided by molar mass of H2O2 will be 34, right? So these many moles we have. So W value for 2 moles of H2O2, is how much? Minus 8.314 multiplied by 298 joules. That means W value for 1 mole of H2O2 will be minus 8.314 multiplied by 298 divided by 2 joules. Therefore, W value for these many moles of H2O2, will be equal to how much? Minus 8.314 multiplied by 298 divided by 2 multiplied by 4.5 divided by 34 joules. Solve this, and this is going to be the value of W. As simple as that. Am I clear? Am I clear with this? First of all, with the help of this particular formula, you got the value of W, right? For the decomposition of 2 moles of H2O2. But we are not given with 2 moles of H2O2. We are given with 4.5 grams. We are given with these many moles of H2O2. Remember the approach of solving these questions, guys. Remember the approach. Okay. One more. Look at this question. Look at this particular question. A gas expands against a variable pressure. Variable pressure. Variable pressure means the process is reversible. The process is reversible. P is given to us as 20 divided by V. Pressure is in ATM, volume in liters. During expansion from volume of 1 liter to 10 liters. So initial volume is 1 liter. Final volume is 10 liters. The gas undergoes a change in internal energy of how much? 400 joules. 400 joules. How much heat is absorbed by the gas during the expansion? So Q value we have to calculate. Q value we have to calculate, right? How do you solve this, guys? How do you solve this? First of all, I'll be calculating W. In case of reversible process, how do we calculate W? Minus V1 to V2, P gas multiplied by dV. This is the expression which we use when the process is reversible. Okay? So W will be equal to minus from initial volume is 1 liter to 10 liters. P gas is how much? 20 divided by V dV. So minus 20. This will be ln of V. This will be ln of V. Right? Under the limits what? Under the limits 1 to 10. Under the limits 1 to 10. Which will be minus 20. Right? This is going to be ln of V2 divided by V1. Correct? I believe you can solve this now. This is ln of V2 divided by V1. So this will be ln of 10 divided by ln of 1. Ln of 10 is how much? 2.303. 2.303. This is the value of W. This is the value of W, guys. But if you look carefully, here volume is in liters. So W value here will be in ATM liter, first of all. W value will be in ATM liter. Correct? Ln of 10. Ln of 10 is 2.303. Okay. So W value here will be in ATM liter. ATM liter. What do we have to calculate? We have to calculate Q. Use the first law of thermodynamics. Delta U is equal to Q plus W. Delta U is 400 joules. Is equal to 400 joules. Q plus W. W is in ATM liter. Convert it into joules. 1 ATM liter is what? 1 ATM liter is 101.3 joules. Multiply it with 101.3. Then it will come in joules, right? Then Q plus W. W is what? Minus 20 multiplied by 2.303 multiplied by 101.3. Now this is in joules. This is in joules. From this particular equation, you can get the value of Q in joules as well. Okay? Did you understand how exactly I approached? The pressure was variable, so it's a reversible process. I got the W in ATM liter, converted into joules, then use the first law of thermodynamics. After using the first law of thermodynamics, I can get easily the value of Q. Over here, delta U was in joules. That's why I took W in joules, so that Q comes in joules as well. I hope I'm clear. I hope I'm clear. All right, look at this particular question. Standard enthalpy of vaporization. Standard enthalpy of vaporization. Right? Standard enthalpy of vaporization of water at 100 degrees centigrade is this much. The internal energy of vaporization of water. It is a simple question, guys. Right? Since you are vaporizing water, so basically you are converting H2O liquid into H2O gas. You are converting H2O liquid into H2O gas. As per the question, delta H for this particular process, how much? 40.66 kilojoules per mole. This is the value of delta H. What am I supposed to calculate? I'm supposed to calculate delta U for the vaporization of water. First thing, my dear students, if I ask you what is the delta Ng for this reaction, delta Ng is number of moles of gaseous product minus number of moles of gaseous reactant. The value is 1. Now I can use the equation. Delta H is equal delta U plus delta NGRT. Now from here you can calculate delta U. Delta U is nothing, that is delta H minus delta NGRT. Delta H minus delta NGRT. So delta U will be equal. What is delta H? It is 40.66 kilojoules minus. Delta Ng is how much? Delta Ng is 1. R value I'll be using as 8.314 joules per Kelvin per mole. Temperature is given to me as 100 degrees centigrade, that means 373 Kelvin. Since I've taken the value of R as in joules, right? But I'll be dividing it with 1000. I'll be dividing it with 1000 so that this term also comes in kilojoules, because I've used this term in kilojoules, therefore this particular term has to be in kilojoules as well. And when you solve it, I believe the answer will be 37.5 kilojoules. Okay? This is how. I've solved this sort of equation before also. I hope you remember. Right? Yes? Is it clear? Is it clear? Tell me the answer of this particular question quickly. A relation between delta H and delta U. Quick. Quick. If you calculate delta Ng for this particular reaction, it is number of moles of gaseous products, which is 1 plus 1, 2. Minus number of moles of gaseous reactant, which is 1. So delta Ng is 1. Now you know delta H is equal delta U plus delta Ng RT, right? So delta U is nothing but, I can say delta H is nothing but, it is delta U plus RT. From this particular equation, you can categorically say delta H is greater than delta U. By how much of amount? By this much of amount, right? Delta H is greater than delta U. Perfect? Perfect, guys? I hope it's clear. I hope all of these things are clear. All right, look at this particular question. Look at this particular question. Look at this particular question. 1 mole of a non-ideal gas means real gas, right? 1 mole of a non-ideal gas undergoes a change in state. Pressure 2 atm, volume 3 liters, 95 Kelvin temperature, to 4 atm, 5 liters, 245 Kelvin. With a change in internal energy of this one, the change in the enthalpy of the process. Change in the enthalpy of the process. What is the general relation between delta H and delta U? Delta H is equal to delta U plus delta of PV, right? This is the general relation between delta H and delta U. I can say delta H is equal delta U plus delta of PV. What is meant by delta of PV? It is going to be P2V2 minus P1V1, correct? So I'll say your delta H is equal. Delta U is how much? 30 atm liter. P2V2. This is P2, this is V2. 5 4s are 20. Minus P1V1. 3 2s are 6, right? So this comes out to be 14. So 44 atm liter is going to be the value of delta H. Is there any option as 44? Yes. Option 3 is the one which is correct. Right, people? Since pressure is also changing, volume is changing. And you know when pressure, volume both change, which equation do we use? P2V2 minus P1V1. Already discussed. Right? I'm moving ahead. Let's see a few more questions. Simple basic formula based question. Simple basic formula based question. 2 moles of an ideal gas. 2 moles of an ideal gas at 27 degrees centigrade. 2 moles of an ideal gas at 27 degrees centigrade expands isothermally and reversibly. So the process is reversible isothermal. The process is reversible isothermal. We have to calculate work done in this reversible isothermal process. It is equal to minus 2.303 nRT log of V2 divided by V1. This is the expression which I believe you all will be knowing. So W reversible is equal to minus 2.303. What is N value? 2 moles of gas, right? R value 8.314. Correct? Temperature how much? 27 degrees centigrade means 300 Kelvin. Log of V2 by V1. V2 is 40. V1 is 4. So 40 by 4 is 10. Log of 10 is 1. Correct? This value over here you'll be getting in joules, but you need the answer in kilojoules. So you have to divide it with 1000. Then only the answer will come in kilojoules. Simple formula based question this is. Simple formula based question this was. Right? Formula based question. What do you think about this one? What do you think about this one? Calculate Q, W, delta U and delta H. When 2 moles of an ideal gas are expanded reversibly and isothermally. You know when the ideal gas undergoes isothermal process. When the ideal gas undergoes isothermal process, it's delta U as well as delta H. Both are 0. So 2 questions are done here only. Correct? Now what do we have to calculate? Q and W. Q and W are to be calculated. Alright, the process is reversible isothermal. Initial pressure is how much? 10 atm. Final pressure is how much? 5 atm. Temperature is 25 degrees centigrade. So, since the process is reversible isothermal, how do we calculate work done in reversible isothermal process? W reversible is equal to minus nRT ln of P1 divided by P2. This is one of the results which I believe all of you will be remembering now. What is N value? 2. R value. Do we have to calculate everything in calories or atm? I mean calories or joules. We have to calculate everything in calories. Okay. So R value is 2. Temperature is how much? Temperature is 27 degrees centigrade means 300 Kelvin. Ln of P1 by P2. P1 by P2. 10 by 5 is 2. Ln of 2 is given to us as 0.7. So this is 0.7. This value will come out to be minus 840 calories. So since W is equal to 840 calories, since W is equal to minus 840 calories, therefore Q, as per first law, delta U is equal to Q plus W. Delta U is equal to Q plus W. Delta U right now is 0. So Q has to be equal to minus W. So Q has to be equal to plus 840 calories. Q has to be equal to plus 840 calories, which I believe all of you will be knowing whenever the ideal gas undergoes isothermal expansion. Whenever the ideal gas undergoes isothermal expansion, heat is absorbed by the gas. And whenever the ideal gas undergoes isothermal compression, heat is released by the gas, right? All those things you must be knowing already. That is the reason why W value came out to be negative and Q value came out to be positive. Is it clear? Yes? I hope I'm clear with this. I hope I'm clear with this. Can you tell me the answer of this question? During isothermal expansion of an ideal gas, isothermal expansion of ideal gas, that means delta U 0, delta S 0. These are the two things which are coming into my mind, which means internal energy will remain constant. Enthalpy also won't change, it will remain constant. Internal energy, nothing, no. Enthalpy remains unaffected, correct? Right? Guys, from these mathematical equations, I mean, you can get everything when it comes to thermodynamics. You know, when the ideal gas undergoes isothermal process, it's delta U as well as delta H. Both are 0. Delta U 0 means internal energy is not changing. Delta H 0 means enthalpy also is not changing. Okay. What do you think about this one? Again, a statement-based question. Again, a statement-based question. Adiabatic expansion of an ideal gas is accompanied by adiabatic expansion of an ideal gas. So Q value is first of all 0, right? Expansion means W is equal to negative. First of all, if I use first law, delta U is equal to Q plus W. So delta U has to be equal to W because Q is 0, right? Now, as per the equation, W is negative. If W is negative, what does that mean? That means delta U is negative. Delta U negative means internal energy of the system is decreasing, correct? Adiabatic expansion of an ideal gas is accompanied by decrease in internal energy. Decrease in internal energy means decrease in temperature. Yes? Decrease in internal energy means decrease in temperature. What should be the answer of this particular question? This is your PYQ as well. The correct option for the free expansion. First of all, they are mentioning the free expansion. Free expansion means W is equal to 0. Right? I think I'm going to fall ill. Adiabatic condition means Q value is equal to 0. Use the first law. Delta U is equal to Q plus W. Q is 0, W is 0, so delta U has to be 0. Delta U 0 means NCV delta T has to be 0, which tells you that delta T has to be 0. So delta T is 0, delta U is 0, Q is 0, W is 0. Now find your options. Right? This is the option 4 is the one which is correct among all. Yes, option 4 is the one which is correct among all. All are 0. Perfect. All right. What about the cyclic process? Cyclic process you all must be knowing. Cyclic process. During a cyclic process, change in the value of any state function, that is 0. So delta U has to be 0, delta H has to be 0, delta S has to be 0, delta G has to be 0, right? But during the cyclic process, work done 0? No. During the cyclic process, magnitude of work done is equal to area enclosed by the loop. Area enclosed by the loop. And when the cycle is clockwise, W value is taken as negative. When the cycle is anti-clockwise, W value is positive. So for the cyclic process, which of the following is not true? This is not true. This is not true, right? This is not true here. I believe I'm clear. This question, it is a cyclic process which is given to us. You have to calculate what? You have to calculate heat absorbed. First of all, during the cyclic process, delta U net has to be 0. You know it. Delta U net is equal to 0. Therefore, Q net plus W net has to be 0. Which is simply telling you Q net has to be equal to minus times W net. Q net has to be equal to minus times W net. Right? Q net has to be equal to minus times W net. Right? So first of all, how do we calculate the magnitude of W net? magnitude of W net is equal to area enclosed by the loop, right? Area enclosed by the loop, it is circular. So area enclosed is pi r square, right? Pi r square. So it is 10 to 30, 20. 20 is the diameter of the circle. Divided by 2 is 10, right? Divided by 2. So r is 10, pi r square. Perfect. So it is 100 pi over here. It is 100 pi over here. This is kilopascal. This is in liters. Kilopascal. This is in liters. Now you just need to do the conversion. That's all. This is the magnitude of W here. This is the magnitude of W here. Is it clear, guys? We have discussed all these things in detail, if you remember, in the regular marathons, right? I've discussed all these things in detail. All these things. Correct? So finally, when you solve this, what is the answer which you'll be getting? The answer is going to be 10 raised power 2 pi joules. Okay? Let me see some. Okay. In which case, change in entropy is negative. Change in entropy negative, matlab delta S negative. Delta S negative means entropy decreasing. During which process entropy is decreasing? During which process entropy is decreasing? First of all, evaporation of water. Evaporation of water means liquid into gas. Liquid into gas. Liquid into gas is expansion, right? Liquid into gas is expansion. So disorderness increases, randomness increases, entropy increases. So entropy increases in this process. Expansion. Whenever there is expansion, entropy automatically increases. So increases. Sublimation of solid into gas increases. Yes. Look at this one. In this particular last case, 2 times H gas. It gives you H2 gas. This is the reaction. Stoichiometric coefficient here is 2, here is 1. Right? So 2 moles during the process, 2 moles are giving 1 mole. 2 moles are giving 1 mole. If 2 moles are giving 1 mole, are the particles increasing or decreasing throughout the process? Particles are decreasing. Particles decreasing means disorderness decreasing. Disorderness decreasing means entropy decreasing. Entropy decreasing means delta U negative. So option 4 is the one which has to be the correct answer of this question. Right, people? All right. If entropy is the criteria for spontaneity, if entropy is the only criteria for spontaneity, then what do we say? We say delta S total has to be greater than 0. Right? If entropy is the only criteria for spontaneity, then delta S total has to be greater than 0. Delta S total will be simply delta S system plus what? Plus delta S surroundings. This term has to be greater than 0. Correct? This term has to be greater than 0. This term has to be greater than 0. Okay? All these types we have already solved. Just a second. All these types are done. All right. Look at this question. It is also frequently asked. The reaction will be spontaneous at. For the process to be spontaneous, you know, delta G for the system at constant pressure and temperature. It has to be negative. For the process to be spontaneous, delta G for the system at constant pressure and temperature. It has to be negative. And you know, delta G is nothing, it is delta H minus T delta S. So this term has to be negative. Correct? This term has to be negative. We are given the process whose delta H is given, delta S is given. Right? I'll say delta H has to be less than T delta S, or I can say T delta S has to be greater than delta H, which tells you that temperature has to be greater than delta H upon delta S. Now, what is delta H and what is delta S? Delta H is 35.5 into 10 raised power 3 joules divided by delta S is 83.6 joules per Kelvin. So solve this term. You'll be exactly getting the value of temperature. So whatever value you get from here, perfect. Temperature has to be greater than this value. Temperature has to be greater than this value. Then only I can say the process is spontaneous. Okay, a lot of people are coming with the option A, right? So option A has to be the answer only then. Right, people? Clear? Temperature has to be greater than 425 Kelvin, then only I'll say the process is going to be spontaneous. I hope this is also clear. Similar sort of question, I believe you can solve this on your own. You are given with a reaction A plus B gives C plus D, delta H naught is given, delta S naught is given, minimum temperature at which it becomes spontaneous. Now again, for the process to be spontaneous, delta G for the system at constant pressure temperature, it has to be negative. So I'll say delta H minus T delta S has to be negative. What is delta H? It is 80,000 joules minus T. What is delta S? Delta S is 2T joules per Kelvin per mole. So this has to be less than 0. So 80,000 minus 2T square should be less than 0, or I will say 80,000 should be less than 2T square, or you can say 2T square has to be greater than 80,000, or T has to be greater than, this will be 40,000. That means 200 Kelvin. So temperature should be greater than 200 Kelvin. Temperature should be greater than 200 Kelvin, then only the reaction will be spontaneous, right? Okay. Right, people? So these sort of questions can be solved easily, provided you know the concepts. That's all. So let's move on to the next chapter then. This was your dynamics part. Let's move on to the chapter chemical equilibrium. Right? Let's move on to the chapter chemical equilibrium. Just give me a second. I'll sit for 2 minutes. Oh, I'm continuously sneezing. I don't know what's wrong. Guys, all these things are clear till here? Yes? All these things are clear? What are you asking? Oxidation state of KMnO4 in alkaline medium. Oxidation state of KMnO4 will remain same everywhere, right? I mean, oxidation state of manganese in KMnO4, be it whatever medium, it's going to be +7 only. Right? It's going to be +7 only. Now, which chapter do you want the next? Which chapter the next? Let's move to equilibrium first. Right now, I have completed the dynamics part. Dynamics part I have completed. After equilibrium, we'll do GOC. After equilibrium, we'll do GOC. Okay? Should we start then? Perfect. So let's start with the chapter chemical equilibrium then. Let's start with the chapter chemical equilibrium. The first set of questions that can be asked. The first set of questions. The first set of questions, which is based on characteristics of chemical equilibrium. Characteristics of equilibrium constant. As per the reaction is concerned, we are given with a reaction. A reaction is N2 plus 3 times H2 in equilibrium with 2 times NH3. Equilibrium constant for this particular reaction is given to us as 49. And as per the question, we are supposed to calculate equilibrium constant for this particular reaction. Can't we solve this? My dear students, how do we approach to these sort of basic questions? The reaction whose equilibrium constant is given. From this particular reaction, we have to calculate equilibrium constant of this particular reaction. How you are going to approach this particular question, this sort of a question? That particular reaction whose equilibrium constant is to be calculated. That particular reaction whose equilibrium constant is to be calculated. We will try to make that reaction. We will try to make that reaction out of the given reaction. We will try to make that reaction out of the given reactions. How exactly? What I'll be doing, I'll reverse this reaction first. When I reverse this reaction, it becomes 2 times NH3 gives N2 plus 3 times H2. And when you reverse the reaction, equilibrium constant is inversed. When you reverse the reaction, equilibrium constant is inversed, right? Number one. Number two, if I multiply this reaction by 1 by 2, it becomes NH3. This becomes 1 by 2 times N2. This becomes 3 by 2 times H2. So when I multiply this reaction by number 1 by 2, right? You get this particular reaction. Since you multiplied the reaction by number 1 by 2, you have to keep that 1 by 2 to the power of the equilibrium constant as well, right? So this value comes out to be 1 by 7. Now, my dear students, look at this particular reaction and look at this particular reaction. They were same. They are same, right? They are same. So I would say the reaction whose equilibrium constant was to be calculated, it came out to be 1 by 7. So few things you have to remember while solving these questions. Number one, when you reverse the reaction, equilibrium constant is inverse, number one. Number two, when you multiply a reaction by a number, that number goes to the power of equilibrium constant. When you multiply a reaction by a number, that number goes to the power of equilibrium constant. Number three, when you add two reactions, their equilibrium constants are multiplied. That's all. And the reaction whose equilibrium constant is to be calculated, we need to make that reaction out of the given reactions. That's all. That's all, people. Am I clear? Let's move on. Let's see. Let's see some other questions so that it becomes clear to you. Other questions of similar type so that it becomes clear to you. For example, you have got one basic question like this of the similar type. Check it out. We are given two reactions, equilibrium constant K1. One more reaction, equilibrium constant K2. We have to relate K1 and K2. How you guys are going to relate it? Look at this particular equation. What I'll be doing, first of all, I'll be reversing this reaction. When I reverse this reaction, it becomes 3 times A2 plus 3 times B2 in equilibrium with 6 times AB. When I reverse the reaction, the equilibrium constant is inversed. Now it is 1 upon K2. Now it is 1 upon K2. Correct? Now, people, I'll be multiplying this particular reaction by the number 1 by 3. When I multiply this reaction by a number 1 by 3, it becomes A2 plus B2 in equilibrium with 2 times AB. And when I multiplied the reaction by number 1 by 3, that 1 by 3 has to go to the power of equilibrium constant as well. So it is raised power 1 by 3. Now, if you look at this particular reaction and this particular reaction, aren't these reactions same? Yes. So their equilibrium constant will be same as well. So I would say K1 is nothing. It is 1 upon K2 whole raised power 1 upon 3. This is the relation between your K1 and K2 which you were supposed to calculate. Am I clear? Simple. So these sort of questions are asked, guys. They are asked. They are asked. For example, who believes that this is the asked question in NEET? Read the question. Read the question. Read the question. You are given with a reaction. The reaction is 2 times A. This is B and this is C. Correct? The equilibrium concentration of A, B, C is given. So the concentration of reactant products at equilibrium, they are given to us. What are we supposed to calculate? Equilibrium constant. How do you write the equilibrium constant expression? How do you write the equilibrium constant expression? You'll write concentration of B at equilibrium raised power stoichiometric coefficient, concentration of C at equilibrium raised power stoichiometric coefficient, divided by concentration of A at equilibrium raised power stoichiometric coefficient. All these terms are given to us. What is concentration of B at equilibrium? That is 2 into 10 raised power minus 3 whole raised power 1. Concentration of C at equilibrium is what? 3 into 10 raised power minus 3 whole raised power 1. Concentration of A at equilibrium is how much? That is 1 into 10 raised power minus 3. 1 into 10 raised power minus 3 whole raised power 2. Correct? So 3 2s are 6. Right? 3 3 6. So this term and this term cancelled. So 3 2s are 6 is the final answer. So equilibrium constant of the reaction which I was supposed to calculate is nothing but 6. Yes, is nothing but 6. Again, one simple and basic question this is. You can expect these. Now, there is one result which you all must be familiar with. That is your Kp is equal to Kc RT raised power your delta Ng. I believe you know this result. Now, my dear students, if delta Ng is equal to 0, if delta Ng is equal to 0, anything it is for 0 is 1. At that point of time, Kp will be equal to Kc. And if delta Ng is the non-zero, at that point of time, you can say Kp is not equal to Kc. What do we have to check? In which of the following Kp and Kc are not equal? Not equal means you have to select that reaction whose delta Ng is non-zero. You have to select that reaction whose delta Ng is non-zero. And which reaction is that? This one. Right? This is the reaction whose delta Ng is non-zero. Delta Ng is number of moles of gaseous product 2 minus gaseous reactant 1. So 2 minus 1 comes out to be 1 only. Correct? Right? One again basic question. What do you think has to be the expression of Kp for this reaction? Expression for Kp. Expression for Kp. Start with the product. Solid, nothing to do with this. Gas, I'll write partial pressure of carbon dioxide at equilibrium raised power 1 divided by. This is solid, nothing to do with this. So, the expression is only Kp is equal to partial pressure of carbon dioxide at equilibrium. Right? One simple and basic question again. One simple and basic question again. Okay. This sort of a question, it has been asked many a times now. Many a times the same question have been asked in your JEE examination. Now say exactly what the question is. As per the question is concerned, we are given the reaction A gas plus B gas in equilibrium with 2 times C gas. This is the reaction that's given to us. Initially at time t is equal to 0, we are starting with 2 moles of A, 1 mole of B and 1 mole of C. They are placed in the container, right, whose volume is 10 liters. Correct? Now, when the reaction starts, equilibrium is established in the reaction. When the reaction starts, equilibrium is established. And it's observed that concentration of C at equilibrium is how much? 0.2 mole. Concentration of C at equilibrium is 0.2 mole. What are we supposed to calculate Kc? What are we supposed to calculate Kc? First thing, how do I write the Kc expression? How do I write the Kc expression? It is going to be concentration of C at equilibrium raised power 2 divided by concentration of A at equilibrium raised power 1, concentration of B at equilibrium raised power 1. So first of all, in order to get the Kc value, I need the concentrations of reactants and products here. I need the concentrations of reactants and products here, right? Now, how do I get the concentrations of reactants products here? It's simple, guys. At equilibrium, if I ask you how many moles of A will be left in the container, you will say 2 minus X. How many moles of B will be left in the container? You will say 1 minus X. How many moles of C? Already there was 1 plus 1 mole gives 2 moles, so X would have given 2X. So I basically got the moles of reactants products present in the container at equilibrium. I got the moles of reactants products in the container at equilibrium. Right? Since I got the moles, what about the concentration? Divide the moles by the total volume. Divide the moles by the total volume. Divide the moles by the total volume. What did I get? I got the concentration. Now, people, if I ask you, what is the concentration of C at equilibrium? Concentration of C at equilibrium is nothing but, concentration of C at equilibrium is nothing but 1 plus 2x divided by 10, which is 2 by 10, right? 10, 10 cancel. X value will be 0.5. If X is 0.5, if X is 0.5, we are done. If X is 0.5, that means the concentration of each reactant product at equilibrium will be equal to 2 minus X. 2 minus 0.5 is 1.5. 1.5 divided by 10 is 0.15 molar, right? 1 minus 0.5. 0.5 divided by 10, 0.05 molar, right? And this value already, you know, that is 0.2 molar. Now, Kc, you can calculate from here. Kc is equal to concentration of C at equilibrium, that is 0.2 raised power 2 divided by concentration of A at equilibrium is 0.15 raised power 1. Concentration of B at equilibrium is 0.05 raised power 1. Solve this and get the value of Kc. That's all. Right? This is how you calculate Kc for a certain reaction which will be given to us. Okay? For example, guys, there is one more question. There is one more question. Similar type of question. For the reaction, X plus Y in equilibrium with 2 times Z. As per the question, initially at time t is equal to 0, we have got 1 mole of X, we have got 1.5 moles of Y, and we are given with 0.5 moles of Z. We're taken in a vessel whose volume is 1 liter, allowed to reach equilibrium. At equilibrium, the concentration of Z was, at equilibrium, the concentration of Z was how much? 1 molar, right? And the equilibrium constant Kc is equal to X divided by 15. We have to get the value of X. We have to get the value of X. Now, how exactly you'll be solving this? Try to understand. Initially, this is 1.50. Now, at equilibrium, tell me, how many moles of X will be left in the container? 1 minus X. This will be 1.5 minus X. This will be 0.5 plus 0.5 plus 1 gives 2. So, X gives 2X. Right? These are the moles. Perfect. Now, volume is 1 liter. If I divide with 1 liter each, what do I get? I get concentration. So, this is the concentration of X, this is the concentration of Y, and this is the concentration of Z at equilibrium. I got the concentration of each reactant product at equilibrium. Now, what is the concentration of Z? 0.5 plus 2x is equal to 1. So, 2x is equal to 0.5. X is equal to 0.25. So, you got the value of X, 0.25. Now, put the value of X here. 1 minus 0.25 is 0.75 molar, right? This will be 1.25 molar. And this particular term is already given to us as 1 molar. So, you got the concentration of each reactant product at equilibrium, correct? Now, if I write the Kc expression is concentration of Z at equilibrium, that is 1, raised power stoichiometric coefficient 2, divided by concentration of X at equilibrium, that is 0.75, raised power 1, multiplied by concentration of this 1.25, raised power 1, and this value is nothing but X divided by 15. Now, it is just the matter of calculation, do the cross multiple stuff, and get the value of X from here. And as far as I remember, the value of X you'll be getting as 16. The value of X you'll be getting as 16. Right, people? Am I clear with this? Am I clear with this quickly? Yes? Is it clear? I believe all the things are clear till here. Okay, moving ahead. Moving ahead. As per the question, on starting with 1 mole of HI, we are starting with 1 mole of HI. Calculate the concentration of each species at equilibrium if Kp for the decomposition of Ki. First of all, how HI undergoes decomposition? HI undergoes decomposition in this format: H2 gas plus I2 gas. This is how HI undergoes decomposition. First of all, balance it. This 1 by 2, this 1 by 2. Because, or let me just write it like this. Let me write the reaction like this. This 2 times, this 1, this 1. Correct? This is the reaction first of all. This is the reaction first of all. First thing, as per the question, we are starting with 1 mole of HI in the container whose volume is 2 liters. So this will be 0, this will be 0 initially. Correct? This will be 0, this will be 0. Now guys, if you look at the reaction carefully, what about delta Ng? Delta Ng for the reaction will be 1 plus 1, 2, 2 minus 2, 0. So delta Ng is 0. If delta Ng is 0, I would say Kp as well as Kc for the reaction are same. And you know, as per the question, it's given as 16. As per the question, it's given as 16. So Kp, Kc both are same and they are 16. Now, at equilibrium, what do you think will be the moles of HI? 1 minus x. This will be 2 gives 1, 1 gives 1 by 2, x gives x by 2. Even this gives x by, this is x by 2. So these are the moles of reactants products in the container at equilibrium. In the container at equilibrium. Now, volume of the vessel is how much? 2 liters. So concentration of HI at equilibrium is 1 minus x divided by 2 liters. This will be x by 2 divided by 2. So x by 4. Even this will be x by 4. So I got the concentration of each reactant product at equilibrium. Number 1. I got the concentration of each reactant product at equilibrium. Okay. Now guys, Kc value is 16. We got to know Kc value is 16. If I use the same Kc, Kc is 16. How do I write the expression for Kc? Concentration of H2 x by 4 multiplied by concentration of I2 x by 4, which comes out to be x square by 16 whole divided by concentration of Hi, that is 1 minus x divided by 2 whole raised power stoichiometric coefficient, that's 2. This value is equal to 16. Correct? So x square divided by 4 multiplied by 1 minus x ka square is equal to 16. Or I'll say x divided by 2 multiplied by 1 minus x whole raised power 2 is equal to 16. Correct? So it can be x divided by 2 minus 2x is equal to 4. So I'll say x is equal to 8 minus 8x, or you can say 9x is equal to 8, or x is equal to 8 by 9. You got the value of x? If you got the value of x, can't you calculate the concentration of each reactant product at equilibrium? If you got the value of x, right? Correct, people? So I would say concentration of H2 as well as concentration of I2 at equilibrium, both are equal to what? Both are equal to x by 4. X by 4. X is 8 by 9 divided by 4. So which comes out to be 8 divided by 9 for 36 molar. This is the concentration of H2 as well as I2 in the container at equilibrium. I believe with this, you can easily solve this particular question. Right? Let me move ahead. Let's try to solve a few more. Let's try to solve a few more. What do you think about this one? Give it a try. What do you think about this one, people? Quickly. Will you be able to solve this one? Will you be able to solve this one? Will you be able to solve this one? You are given with the reaction, and as per the question, initially you are starting with 1 mole of ethyl alcohol, 1 mole of ethyl alcohol, 1 mole of acetic acid, and 1 mole of water. So initially this is the scenario. Initially this is the scenario. At equilibrium, 20% of acid is esterified. 20% of the acid is esterified. What does that mean? At equilibrium, this is your acetic acid. 20% of the acid is esterified. That means 20% of the acid has reacted. I had 1 mole. Out of 1 mole, I'll say 0.2 moles have reacted. Out of 1 mole, 0.2 moles have reacted. So I'll be left with 1 minus 0.2, 0.8 moles. 1 mole reacts with 1 mole. So 0.2 moles of it would have reacted with its 0.2 moles as well. Correct? So I'll be left with again 0.8 moles of ethyl alcohol. Right? 1 gives 1, 0.2 would have given 0.2. This will be 1 plus 0.2. I hope you got to know how I calculate the moles. I hope you got to know how I calculate the moles here. Right? Now people, the volume of the vessel, assume that is V liters. If the volume of vessel is V liters, then this is the concentration of reactant products at equilibrium. What are we supposed to calculate? Kc. How do I calculate Kc? Kc is concentration of this, that is 0.2 divided by V whole raised power 1 multiplied by. This is going to be 1.2 divided by V raised power 1 divided by 0.8 divided by V multiplied by 0.8 divided by V, which is square. So V cancel. So you got to know 0.2 multiplied by 1.2 divided by 0.8 ka square. Solve this and get the value of Kc, which you are supposed to calculate. Is it again simple? This sort of a question can be asked. This sort of a question can be asked. And it's a simple question. It's not difficult or something, wherein you have to think a lot. Wherein you will have to think a lot. All right. Let's see what this question is all about. The question says, if, the total pressure at equilibrium is 30 atm, partial pressure of HNO3 at equilibrium is 2 atm, calculate Kp for the reaction. Right? Calculate Kp for the reaction. How you guys are going to deal with this particular question? Try to understand. As per the question, the reaction is 4 times HNO3. Right? It gives 4 times NO2 gas plus 2 times H2O gas plus O2 gas. This is the reaction. Right? My dear students, as per the question, let's assume the initial pressure is P naught. This is 0, this is 0, this is 0. Let's assume at equilibrium, this is P naught minus X. This is P naught minus X. Now, 4 mole gives 4 mole, 1 gives 1, so X gives X. Correct? 4 moles here are going to give us 2 moles. So 1 mole gives 2 by 4. 2 by 4 is 1 by 2. So X gives X by 2. Similarly, this will be X by 4. So what did I calculate right now? If you look carefully, we calculated the partial pressures of each reactants products at equilibrium. These are the partial pressures of each reactants products at equilibrium. Now guys, as per the question, the partial pressure of HNO3 at equilibrium is 2 atm. Partial pressure of HNO3 is nothing but P naught minus X. So as per the question, P naught minus X is 2 atm. Number one. Number two. The total pressure of the mixture at equilibrium. Total pressure of the mixture will be this, plus this, plus this, plus this. Total pressure of the mixture will be P naught minus X plus X by 2 plus X by 4. This total pressure is equal to how much? 30 atm. Right? But this particular term, P naught minus X is already given as 2. So this term is 2. So 30 minus 2 is 28. So on right side, I'll be writing 28. Over here, I'm taking LCM as 4. If this is 4, so this will be 4x plus 2x, 6x, 7x. So 7x is equal to 28. So 7 1, 7 4, 4 4 is 16. So x value you got to know as 16 atm. X value you got to know as 16 atm. If x is 16 atm, what am I supposed to calculate now? What am I supposed to calculate? X is 16. If x is 16, therefore P naught is 2 plus 16. That means 18. Correct? So P naught minus X was already given to me as 2 atm. Correct? X is 16. So this term is 16. X by 2. 16 by 2 is 8. And 16 by 4 is 4. Perfect. So I'll be writing the Kp expression now. Kp will be partial pressure of NO2, that's 16, whole raised power stoichiometric coefficient, that's 4. Partial pressure of water, that's 8, whole raised power stoichiometric coefficient, that's 2. Partial pressure of O2, that's 4, whole raised power stoichiometric coefficient, that's 1, divided by partial pressure of HNO3, that is 2, whole raised power stoichiometric coefficient, that's 4. Solve it, get the value of Kp, that's all. Solve it and get the value of Kp, that's all. Am I clear? This sort of equation again can be asked when it comes to your NEET 2024 as far as the chapter chemical equilibrium is concerned. Okay? Now, just a second. Look at this question, guys. Look at this particular question. The question is, if total pressure at equilibrium for the following reactions to ATM, then calculate the volume fraction of Cl2 at equilibrium. Volume fraction of Cl2 at equilibrium. This is the question. Understand what the question says exactly. First thing, I'm going to write the reaction again, which is PCl5 gas in equilibrium with PCl3 gas plus Cl2 gas. This is your reaction, right? This is your reaction. First of all, assume that I'm starting with A moles of PCl5. This is 0, this is 0. Now, at equilibrium, this is A minus X, this will be X, and this will be X. Correct? So basically, I got the moles of each reactant product at equilibrium. Now, guys, if I ask you, how many total moles are there in the container at equilibrium? Total moles. This plus this plus this. So A minus X plus X plus X makes it A plus X. So I'm dividing this with A plus X. I'm dividing this with A plus X, as well as I'm dividing this with A plus X. What did I get? I got the mole fraction of each reactant product at equilibrium. I got the mole fraction of each reactant product at equilibrium. What am I supposed to calculate? I'm supposed to calculate volume fraction of Cl2 at equilibrium. Let me tell you, volume fraction of Cl2 at equilibrium will be mole fraction of Cl2 at equilibrium. Volume fraction of Cl2 at equilibrium will be mole fraction of Cl2 at equilibrium. Volume fraction of PCl3 at equilibrium will be mole fraction of this. Volume fraction of PCl5 at equilibrium will be its mole fraction. So indirectly, they are asking you to calculate mole fraction of Cl2. And mole fraction of Cl2 is X divided by A plus X. So basically, you have to calculate this value. X divided by A plus X value you have to calculate. X divided by A plus X value you have to calculate. You are supposed to calculate mole fraction of Cl2. Let me tell you, mole fraction of Cl2 at equilibrium will be its volume fraction. Okay? One and the same. Now, since you got the mole fractions of all reactants products, if you multiply them with the pressure, total pressure of the mixture at equilibrium. What is the total pressure of mixture at equilibrium? 2 atm. So multiplying everyone by 2. What did I get? I got partial pressure. I got partial pressure of each reactant product. If I got partial pressure of each reactant product, can I write the expression for Kp? Kp expression is going to be partial pressure of PCl3 at equilibrium, which is 2x divided by this, multiplied by partial pressure of Cl2 at equilibrium, which is 2x divided by this. So it comes out to be 4x square divided by A plus X ka whole square, whole divided by partial pressure of PCl5 at equilibrium, that is A minus X divided by A plus X ka whole square. Now, matter of calculation. Kp is equal. One of the A plus X gets cancelled out. So it comes out to be 4x square divided by. Just a second, guys. Something we missed, I believe. Just a second. A plus X square cancel. So it's 4x square divided by A plus X ka square. Correct? And this Kp value, you already know, it's 2 divided by 10. It's 0.2. 2 by 10. 2 divided by 10. Did we miss out something here? Kp is equal to 0.2. Did we miss out something here? Wait, this is not square here. We did calculation mistake. So Kp is equal. I'll write Kp is equal. This is 2x multiplied by 2x, which comes out to be 4x square divided by A plus X whole square. Whole divided by PCl5 partial pressure, which is 2 multiplied by A minus X divided by A plus X. This is what I got. So one of the A plus X got cancelled out, right? Okay. One of the A plus X got cancelled out. 2, 1, 2, 2. So Kp is equal to x square divided by 2x square divided by A plus X multiplied by A minus X comes out to be A square minus X. Guys, be careful with this calculation, okay? So Kp as per the question is given to me as 0.2, which is 2 by 10. So 2 by 10 came out to be x square divided by A square minus X square. Okay? Right? Perfect. And this 2 got cancelled. So it is basically 1 by 10 is equal to x square divided by A square minus X square. Perfect. So A square minus X square is equal to 10x square. Or I'll say 11x square is equal to A square. Or x is equal to A divided by root of 11. x is equal to a divided by root of 11. If you got the value of x equal to a divided by root of 11, then mole fraction of Cl2 at equilibrium is equal to x is nothing but a divided by root 11 divided by, this is a plus x is a divided by root 11 again, so a cancel. So 1 by root 11 divided by 1 plus 1 upon root 11. So final answer will be how much? Final answer will be 1 divided by root of 11 plus 1. So this is the volume fraction of Cl2 at equilibrium. This was a bit lengthy question. This is the volume fraction of Cl2 at equilibrium, which is what you call as mole fraction of Cl2 at equilibrium as well. Okay? Perfect. I hope I'm clear with this. I hope people I'm clear with this. Right? What about this particular question? This question is also from chemical equilibrium only. Predict the direction of shift. Predict the direction of shift. Le-Chatelier principle is the short question which will be asked. Okay. So, as per Le-Chatelier principle, you already know whatever we do to the reaction, equilibrium does opposite of that. If you try to increase the amount of H2, equilibrium will try to decrease it. How? It will make the reaction to move in the forward direction. So forward shift will favor here, number one. If NH3 is increased, if you increase NH3, equilibrium will try to decrease it. So backward shift. How equilibrium will decrease it? It will make sure the equilibrium shifts backward. When temperature is increased, since it's given that the reaction is endothermic, so when you increase the temperature, equilibrium will try to decrease it. So forward. Inert gas added at constant volume. When inert gas is added at constant volume, nothing happens. Right? Nothing happens, you know it. Nothing happens when inert gas is added at constant volume. Inert gas is added at constant pressure. Tell me, what will happen over here? Forward or backward? Inert gas added at constant pressure. What will happen here? Quickly. Inert gas added at constant pressure. Which shift? Forward or backward? Forward or backward? Quickly. Quickly. Everything was discussed in the marathon if you remember. Inert gas is added at constant pressure. Perfect. Done. So these sort of questions you can easily solve from now on, right? I believe these sort of questions you can easily solve from now on. Can you let me know the answer of this particular question? Can you tell me the answer of this particular question? For the reaction, the amount of carbon dioxide can be increased by. If you want to increase the amount of carbon dioxide, what do we have to do? If you want to increase the amount of carbon dioxide, what do we have to do? If you want to increase the amount of carbon dioxide, I'll increase the amount of carbon monoxide. If I increase the amount of carbon monoxide, equilibrium will try to decrease it. How? It will make the reaction to move in the forward direction. Okay? Perfect. I hope all this stuff is clear. Right? Now, here we are going to take a break and we shall be starting the general organic chemistry. Break till break till we'll see ionic will be also done. First we'll do GOC first because a lot of problems right from past 3 hours I'm only solving the questions, right? So something you also have to do, and in GOC I don't require pen paper, right? You know it. So it's 3:25. What time you guys will be back? What time? So, break till. Let's get back at 4 p.m. You have your tea and everything, right? Have your tea and everything, and after that, we shall be doing the rest of the chapters. Okay? Perfect. But be back, because GOC is again high weightage. Whatever questions I'll be giving you from that, minimum 4 questions from GOC for sure you'll get. Minimum 4 questions for sure. Okay? Right? Chalo, I'll see you exactly at 4. Till then, you carry on. Bye bye. See you. See you guys. Take care. Is everyone back on time? Is everyone back on time? Yes? Is everyone back on time? Let me know in the chats. Let me know in the chats quickly. So, people, I hope whatever we discussed till now, everyone is clear with all those things. Yes, I hope everyone is clear with all those things. Right, people? And now we are going to start the general organic chemistry. Do you want to start with GOC first or electrochemistry? Which one do you want to start first? GOC or electro? Quick. GOC or electro? Quick. GOC or electro? Quick, 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 quick. Everyone. A lot of GOC fans we have, huh? A lot of GOC fans we have here. A lot of GOC fans. Hello, we'll start with GOC only. Call up everyone. Let them know we have started. Call up everyone. Let them know the break is over. Yeah. Electro will start. We'll do after GOC, okay? Since majority is asking about the GOC right now, so we'll do the electro afterwards. Afterwards, we shall be doing GOC. I mean, afterwards, we shall be doing the electro part. Perfect. So, people, in the general organic chemistry, let me tell you how many types of the questions can be asked. The first type of the question is going to be based on carbocation stability. That will be the first type of the question. Second will be carbanion stability, right? Third one will be questions based on acidic strength. Next will be questions based on basic strength. Next will be stability of resonating structures. Next will be aromatic, how to, check whether the compound is aromatic, non-aromatic, anti-aromatic. Perfect. Right? All these different types of the questions can be asked in general organic chemistry. Okay? So let's exactly see how do we deal with such type of the questions. My dear students, before showing you the questions, I'm going to write few lines over here. Number one, stability of the carbocations. Stability of the carbocation. Let me tell you, stability of carbocation, it depends on the electron donating groups as well as it depends on the electron withdrawing groups. Do remember electron donating groups. They stabilize the carbocation. They increase the stability of carbocation. And electron withdrawing groups, they destabilize the carbocation. Right? This is point number one. Point number two. If you talk about the stability of carbanion, let me tell you, carbanions, they are stabilized by electron withdrawing groups and they are destabilized by electron donating groups. First of all, we shall be doing the questions based on the stability of carbocation and the stability of carbanion, right? Okay. So people, without wasting any sort of time, let's get going and let's get started with our first question. This is our first question and this is our second question. We have to arrange these three carbocations on the basis of the stability order. On the basis of the stability order, right? What do you think? Which one is more stable? First, second, or third? First of all, my dear students, if you see, this is the carbocation, right? These are all the carbocations, positive charge at every carbon on the top, right? This CH3, as you all must be knowing, it's electron donating group. CD3, it's also electron donating group, right? And this nitro, it is electron withdrawing group. It is electron withdrawing group, okay? So these groups are basically present at the meta positions. And at the meta position, CH3 is going to operate plus I effect. This is also going to operate plus I effect. And this is going to operate what? This is going to operate minus I effect, right? At the meta position. Now, you know all the plus effects, they are electron donating, right? Okay, plus means electron donating, minus means withdrawing. Plus means donating, minus means withdrawing, right? Now, as I told you, electron donating groups, they stabilize the carbocation. Now, which one is more donating, CH3 or CD3? CD3 is more donating. CD3 is more donating. CD3 shows more plus I. It shows more plus I than CH3. So I'll say maximum stable is B, followed by A, and C is going to be the least stable among all. So this is the order over here. I believe it's clear. Look at the next question. Look at the next question. Over here, again, you are given with carbocations. Again, you are given with carbocations. Here you have got the nitro group, electron withdrawing, right? Perfect. Electron withdrawing groups, they decrease the stability of the carbocation. So which one is going to be least stable? My dear students, if you look at all these three compounds, here the electron withdrawing group is more closer towards the positive charge, right? So over here, withdrawing nature will be more. Stability of this is going to be least. C's stability will be least. Then B. In case of A, there is no withdrawing group attached. So A is going to be maximum stable among all. I hope I'm clear with this. First question. Second question, my dear students. I mean, this is going to be the third question and this is going to be the fourth question. Look at the third one. I want you guys to let me know the answer of the third question. Again, you are given with carbocations, right? This is electron donating group, electron donating group, electron donating group. And you know, electron donating groups, what do? They increase the stability of carbocation. Now, where is the electron donating group more effective, right? Where will be the stability increased the maximum? If you look here, right, this is closer. So stability of C is going to be maximum, followed by B, followed by A, right? Because you know, inductive effect, it is distance dependent, right? Lesser the distance, more is going to be its, more is going to be its stability. Okay. Look at the next one. Look at the next one, guys. Look at the next one. Again, we have got the carbocations. You have to arrange them on the basis of the stability order, right? This is your alkyl group attached. Alkyl group attached here. Also here you have got the alkyl group attached. Now, which alkyl group? All the alkyl groups, they show they are electron donating in nature. All the alkyl groups, they are electron donating. Now, which one will be more donating, right? Look at the free valent carbon. This is the free valent carbon. Here, this is your free valent carbon. And here, this is your free valent carbon. More the branching at free valent carbon, more is going to be the plus I power. So which one is going to be having more plus I? This will have more plus I. More plus I means more donating means more stable. So B is more stable, followed by C, followed by A. Correct? I believe this clear. This was our question number 4, right? This was our question number 4. Moving on to the fifth question. This is our question number 5 and this is our question number 6. Tell me the order in case of the fifth question. First of all, my dear students, if you look carefully, again you are given with carbocations. Right? This is the alkyl group, right? It is electron donating, plus I. Perfect. Nitro group at the meta position will show minus I. CN at the meta position will show minus I, right? You know, electron donating groups, they stabilize the carbocation, so stability of A is going to be maximum. Now, nitro and CN, which one is more withdrawing? Which one has got more minus I? Quickly. Which one has got more minus I? Nitro has got more minus I. If nitro has got more minus I, then it is going to be the least stable, right? C will be at the second position. I hope it's clear. I hope it's clear. Now, my dear students, look at this one. Positive charge here at this particular carbon, positive charge here at this particular carbon, right? Now, think logically. Think logically. Over here, you have got sp2 hybridized carbons. Here, you have got sp3 everywhere. sp2 hybridized carbon. If you compare sp2 and sp3, which one has got more s character? sp2 has got more s character, more electronegativity, more electronegativity, more withdrawing here, more withdrawing here. More withdrawing means less stable. So B will be more stable than that of A. Am I clear? Am I clear, people? Am I clear with this? Right? This was our 6th question. Now, moving on to the 7th one. Just a second. Moving on to the 7th one. This is the 7th one, this is 8th, this is 9th, and this is 10th. Right? Tell me the answer of the 7th question. 7th question, guys. Quickly. Khushi, that there was no conjugation. There was no conjugation. Quickly. Quickly, people. Tell me the order, stability order. First of all, these are carbocations. You can talk in terms of hyperconjugation, right? Or if not hyperconjugation, you can talk in terms of inductive effect as well, right? Here you have got one group, 2 donating groups, and 3 donating groups. Wherever donating groups are more, stability of carbocation is more. So what is the stability order? It's going to be 4, then 3, then 2, then 1. This is the stability order over here. If you look at the next one, or else if you want to see with the help of hyperconjugation as well, you know, carbocations are stabilized by hyperconjugation, right? More the alpha hydrogens, more the hyperconjugation, more the stability of carbocation, right? Over here, look at these particular carbon atoms. If I ask you, what do I call this particular carbon as? I call this as alpha carbon because it is attached to sp2 hybridized carbon, right? This alpha carbon. And all the hydrogens attached to it are alpha hydrogens. So 3 alpha hydrogens. Over here, 6 alpha hydrogens, 3 and 3. Over here, 9 alpha hydrogens. More the alpha hydrogens, more the stability. More the alpha hydrogens, more the stability of the carbocation, right? Look at the next one. This is your sp2 hybridized carbon. This is the sp3 hybridized carbon, which is attached to sp2. So I'll be calling this alpha carbon, right? It is attached with hydrogen as well. Perfect. It's attached to hydrogen as well. So how many alpha hydrogens are stabilizing this carbocation? 1 alpha hydrogen is stabilizing. Over here, if you look carefully, two hydrogens, right? 2 hydrogens on this side and 3 hydrogens on this side. Perfect. So 3 to 5 to 7. This carbocation is stabilized by 7 alpha hydrogens. This carbocation, this is 1 over here, and these are going to be 2. So this is stabilized by 3 alpha hydrogens. More the alpha hydrogens stabilizing the carbocation, more is going to be the stability of carbocation. So which one is more stable? 2 will be more stable, followed by 3, followed by 1. Correct? 2, 3, 1. Look at the next one. CH3 positive, CH2D, CHD2, CD3. Right? Quickly. Where is the stability more? This one is maximum stable, followed by this, followed by this. You know, tritium shows more plus I, then that of deuterium, then that of protium. This is the plus I order. I hope you know this. All right, look at the next one. This is withdrawing. Now, comparatively, can you give me the order here? Which one will be the most withdrawing among all? Nitro. Nitro is most withdrawing. If nitro is most withdrawing, so A will be least stable. Now, among B and C, which one do you think is more stable? Quickly. Which one do you think is more stable among B and C? Have you seen the minus I series? In the minus I series, do we give priority to CN or F? Which one is more withdrawing as per minus I series? Which one is more withdrawing? Tell me quickly. Which one is more withdrawing as per minus I series? Which one is more withdrawing as per minus I series? You know it already. That's great. That's great. Perfect. The one which is more withdrawing, that carbocation will be more stable or less stable. Quickly in the chats. More stable or less stable? That will be less stable. Correct? Perfect. So the order will be? Order will be? Order will be 3, 2, 1. Yeah? Perfect. I'm moving on. I am moving on, guys. Tell me the answer of this particular question. This was asked in your NEET 2019. The most stable carbocation. Again, what you'll be doing? Again, what you'll be doing? You'll be finding the alpha hydrogens. More the alpha hydrogens, right? More is going to be the stability. So where do you find more alpha hydrogens? I can see in the last one, there are 3 to 5. 5 alpha hydrogens are stabilizing. 5 alpha hydrogens here are stabilizing. Okay, 5 alpha hydrogens here are stabilizing this. And more the alpha hydrogen stabilizing a carbocation, more is going to be the stability of carbocation. So it has to be option D, which has to be the correct answer of this particular question. Okay, moving ahead. Moving ahead, just a second. Just a second. Can you tell me the stability order of these 3 carbocations which I have come up with over here? Can you let me know quickly? Can you let me know quickly? Quickly. If you look carefully, this is pi sigma positive. So this carbocation is resonance stabilized. This carbocation is not resonance stabilized. But this one is also pi sigma positive. This one is also resonance stabilized. Right? So in first and third, due to resonance, carbocations are stabilized. Now, where is more resonance? First one or third one? Where is more resonance? In the third one, resonance is more. Right? So stability of third is maximum, followed by first, followed by second. Right? Because first and third, they are resonance stabilized carbocations. Right? And in the third one, more resonance means more stability. Done? Dusted? Right. Moving ahead. Moving ahead, people. Moving ahead. Now come to carbanions. Okay, carbanions. Carbanions are stabilized by electron withdrawing groups. Carbanions are stabilized by electron withdrawing group. Right? You have got the carbanions here. They are stabilized by electron withdrawing. This is electron donating. Right? This one is also electron donating group. This one is also electron donating. Now, which one is the less donating? The one wherein you have got less donating group attached, stability will be more. Which one is less donating? This is less donating, so more stability, followed by A, followed by C. Right? Clear, people? All of you are perfectly right. Great job. All right, tell me the answer of this particular question quickly. Nitro, F, right? Nitro is more withdrawing, you know it. If it is more withdrawing, more the stability of carbanion. So B is more stable, followed by C, followed by A. So this is the order BCA. This is the order BCA. Okay, perfect. I want to give the numbering to the questions as well. Just a second, guys. Just a second. So this was our 10th question. This was our 10th question. This was 11th. Just 12. This was our 13th. Right? This is the 13th one. This is the 14th one. Okay, this is the 14th one. Now moving on. Moving on, guys. Moving on. Tell me the order of the carbanions here. Tell me the order of these two. These two. Which one? Where do you see negative charge is more stable? Where do you see negative charge is more stable? Where do you see negative charge is more stable? Where do you see negative charge is more stable? B, is that? People are saying B. I'm not sure. On what basis you are saying B? Are you saying on the basis of electronegativity? Are you saying on the basis of electronegativity? See guys, first of all, sulfur carrying negative, oxygen carrying negative. Sulfur and oxygen, they belong to same group. Whenever you need to compare the stability of charges on the elements which belong to same group, you're not supposed to talk in terms of electronegativity. You're supposed to talk in terms of volume charge density, right? You're supposed to talk in terms of volume charge density, which is basically directly proportional to charge, inversely proportional to size. And VCD is inversely proportional to stability. Now, check it out. Oxygen carrying negative, sulfur carrying negative. Oxygen carrying negative, sulfur carrying negative. Charge is same. Now, size. Sulfur has got bigger size. Sulfur has got bigger size. Bigger size means less VCD. Less VCD means more stability. So, where is the negative charge more stable? In the first case. Okay? A is more stable than B. The next one. Carbon carrying negative, nitrogen carrying negative. Carbon carrying negative and nitrogen carrying negative. Correct? Carbon carrying negative, nitrogen carrying negative. They belong to same period. In the period, you talk in terms of electronegativity. In the period, you can talk in terms of electronegativity. And you know, negative charge is more stable on more electronegative. Negative charge is more stable on more electronegative. So technically, this has to be the order. But order is not this. Order is reverse. This is sp hybridized carbon. This is sp3 hybridized nitrogen. Right? This is sp3 hybridized nitrogen. Let me tell you, electronegativity of sp hybridized carbon is more. Electronegativity of sp hybridized carbon is more. Right? And negative charge is more stable on more electronegative. So this is the order. Right? This is the order. Tell me the answer of the 17th question. What do you think? Again, these are carbanions. You can easily kill them. Quickly, people. Quickly. Negative charges. Quickly. See, first of all, this is donating, this is withdrawing, this is withdrawing. Which one is more withdrawing? NO2. Right? Electron withdrawing groups, they stabilize the carbanion. So C is more stable, followed by B, followed by A. Tell me the answer of the 18th question. This is NF3 positive. NF3 positive. This is F. This is CD3. This is donating group. This is withdrawing. This is withdrawing. Now, which one is more withdrawing? NF3 positive is more withdrawing. The one which is more withdrawing, that will stabilize the carbene in the maximum. A, B, and C. Correct? A, B, and C. A, B, and C. Check the 19th question. Check the 19th question. Quickly, you guys can check the 19th question. Quickly, people, quickly, everyone. I want every one of you to solve this. Let me know the answer quickly. Let me know the answer quickly, my dear students. People are saying BAC, is that? Are you sure? Are you sure? Absolutely, it's going to be BAC only. BAC only, correct? What about the next one? I want to see the answer of this particular question. Like what you guys will be thinking about this one. I want to see actually the answer of 20th one. I want to see the answer of 20th one. I want the answer of 20th one. See guys, if you look carefully, sulfur carrying negative, oxygen carrying negative, nitrogen carrying negative, and carbon carrying negative. Well, sulfur and oxygen, they belong to same group. Sulfur and oxygen, they belong to same group. In the group, we talk in terms of VCD, right? We talk in terms of VCD. More the size, lesser the VCD, more the stability. So A is more stable than B. A is more stable than B. Now compare this B with the rest. Oxygen carrying negative, nitrogen carrying negative, carbon carrying negative. Oxygen, nitrogen, carbon, they belong to same period. In the period, you will talk in terms of electronegativity. And you know, negative charge is more stable on more electronegative. Negative charge is more stable on more electronegative. So negative charge on this oxygen will be more stable than that of this nitrogen. So I'll say B will be more stable than C and C will be more stable than D. So the order becomes A, B, C, D. The order becomes here A, B, C and D. Correct? I believe it's clear. I believe it's clear. Tell me the answer of the 21st question. What do you think? Tell me the answer of the 21st question. Quickly. Quickly. There are a lot of people in the chats who are involved in their own stuff, asking about the Insta IDs, WhatsApp numbers, etc. etc. Do ask the Insta IDs and WhatsApp numbers in the examination hall on 5th of May. Not now. Yeah. On 5th of May, you will get a lot of time in the examination hall, right? Because you won't understand what is happening in the hall, right? So there you can do all these things. Chit chats, passing the numbers, WhatsApp IDs, Snapchat IDs, right? And then you'll come back again to this channel, preparing for NEET 2025, talking about all those who are just involved in these things right now. Okay. All right, have a look, people. This is a simple question. There is a negative charge here. There is a negative charge here, right? Now we have to check their stability order. I think you have already. Can you let me know again? I was not checking your chats, what you answered basically. Right? Can you let me know among A and B which one is more stable? Can you let me know in the chats which one is more stable? Quickly, everyone. Everyone. Perfect. A is more stable than B. Because here you have got fluorine attached, here you have got iodine attached, right? Fluorine is more withdrawing. Now, among A and B, can you tell me that? Among this one, F negative, I negative, where is the negative charge more stable? F negative or I negative? Where is the negative charge more stable? Quick. Where is the negative charge more stable? Fluorine or iodine? Fluorine and iodine, they belong to the same group. In the group, VCD plays a role. More size, less VCD, more stability, right? So, this is the stability order. Perfect. Tell me the answer of this particular question. These are all the carbanions which are given to us. Single bonded carbon, double bonded carbon, triple bonded carbon. Which has got more S character? This has got more S character. More S character, more electronegativity. And negative charge is more stable, more electronegative. So 3 is more stable, followed by 2, followed by 1. Yes? 3 to 1 is the order. 3 to 1 is the order. Okay. Let's talk about the stability of the resonating structures. Stability of the resonating structures. First, let me tell you what to do. First of all, whenever you'll be given with the resonating structures and you'll have to talk about their stability order. In short, remember like this. First of all, calculate the number of bonds. Calculate the number of bonds. More the bonds, more the stability. More the bonds, more the stability. Number 1, right? Calculate the bonds. More the bonds, more the stability. Number 2, if you are unable to differentiate in terms of bonds, then that resonating structure wherein atoms do not have any charge. That resonating structure wherein atoms do not have any charge, right? That will be considered to be more stable. This is the second thing. First, number of bonds. Second, that resonating structure in which the atoms do not carry any charge, that will be more stable, right? Third, if there are unlike charges present on this atoms, if there are unlike charges present, do remember more the distance between the unlike charges, lesser is going to be the stability. More distance between the unlike charges, lesser is going to be the stability, right? Similarly, lesser the distance between like charges, lesser the distance between like charges, lesser the distance between less like charges, lesser is going to be the stability. Just remember it like this. Okay. Now, if you look at this particular question, the first thing I'll be counting the bonds. So this 1, 2, 3, 4, 5, 6. I'm only counting these bonds. 1, 2, 3, 4, 5, 6. 6 bonds. 1, 2, 3, 4, 5, 6. 6 bonds. The bonds are same everywhere. So you're not going to decide on the basis of bonds. Leave it. Second, this is the resonating structure at which atoms do not carry any charge. So A will be maximum stable. A will be maximum stable. Now, among B and C, oxygen is carrying negative, oxygen is carrying negative. Here, oxygen is carrying positive. Here, nitrogen is carrying positive. Oxygen carrying positive, nitrogen is carrying positive. Positive charge is more stable on less electronegative. Which one is less electronegative? This nitrogen or this oxygen? This nitrogen. So positive charge is more stable on less electronegative. So C, then B. So ACB is the order. ACB is the order. ACB is the order. Tell me the answer of this particular question quickly. A, B, C. Where do you see which resonating structure is more stable among all? Quick. Quick, people. Quick, everyone. And you know, everyone means everyone. Quickly. Quickly, my dear students. Done? Done? What is the first thing? I'll be counting the bonds. Count the bonds. 1, 2, 3, 4, 5, 6, 7, 8. 8 bonds. 1, 2, 3, 4, 5, 6, 7. 7 bonds. 1, 2, 3, 4, 5, 6, 7, 8. 8 bonds. More the bonds, more the stability. More the bonds, more the stability. So, B will be the least stable. B will be the least stable. Now, among A and C, which one will be more stable? That resonating structure wherein the atoms do not carry any charge, that is more stable. So, A will be more stable, then C, then B. This is the order. This is the order, people. This is the order. Tell me the answer of these two questions. Tell me the answer of these two questions quickly. 26th. 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 Quick. Quick, people. Think over it once. Think over it once. Then answer. Look here, guys. First of all, count the bonds. 4 bonds, 4 and 3. So C is least stable. Now, among 1 and 2, which one do you see is more stable? See, positive charge on nitrogen, right? Negative on nitrogen, negative on carbon. Negative charge is more stable on more electronegative, right? So A is more stable, then B, then C. Now, this is the last question this is the last question of this particular stability of resonating structures. Okay. What about this one? Count the bonds first of all. 1, 2, 3, 4, 5. 5 bonds. 1, 2, 3, 4, 5, 6. 6 bonds. 1, 2, 3, 4, 5. 5 bonds. 1, 2, 3, 4, 5, 6. 6 bonds. Right? More the bonds, more the stability. So C and D is more stable. C and D is more stable than A and B. Now, among C and D, which one is more stable? Among C and D, which one is more stable? See, negative charge here on carbon. Negative charge here on carbon. Perfect. Positive charge on nitrogen. Positive charge on nitrogen. Correct? Right? Now, use the charge separation rule. Use the charge separation rule. Lesser the charge between unlike, more the stability. So D is more stable than C. D is more stable than C. D is more stable than C. Now, among A and B, check it out. Positive charge on carbon, positive charge on carbon. Correct? Negative charge on carbon, negative charge on carbon. But over here, you're going to lone pair as well. So repulsions, so less stable. So among A and B, more stable will be B, and at the end, I'll prioritize A. Is that clear? Is that clear, people? Is it clear to everyone? Done? Done, people? All right. Moving ahead. Moving ahead, these are similar type of questions. Similar type. Okay. All right. One more type of question. Among these two, which one is more stable? Among these two, this is 26, this is 27, this is 28, right? I think this is the numbering which we were doing. Anyways, leave the numbering aside, I forgot. Okay, tell me. Among this 1 and 2, where do you see stability is more? 1 or 2? See guys, this lone pair is in conjugation with this one as well as this one. This lone pair is in conjugation with this pi bond as well as this pi bond. So this is the case of which conjugation? Cross conjugation. Extent of resonance in cross is less, right? Lesser the resonance, lesser the stability. Done? Right? This pi bond, pi sigma pi. So this pi bond is simultaneously in conjugation with this one as well as this one, right? So this is the case of cross conjugation. In case of cross conjugation, extent of resonance is less, stability is less, right? Here in this particular case, this is pi sigma negative, pi sigma negative. Again, the case of cross conjugation, extent of resonance less, stability less, okay? So this was one more type of question. Now, do remember, if there is negative charge on oxygen and there is negative charge on carbon, we know negative charge on oxygen is more stable. But do you know by how much? Let me tell you, negative charge carrying capacity of oxygen is more than the negative charge carrying capacity of 10 carbon atoms. You can understand how stable negative charge is on oxygen. Right? You can understand how stable negative charge is on oxygen. Now try to understand. We have to check the stability order of these three. First of all, do you see any resonance here? This negative can come here, this pi bond can come here. So when the pi bond gets shifted towards here, negative charge can come on this oxygen as well. So negative charge is shared on 2 oxygen atoms here, right? Over here, negative charge is shared on only 1 oxygen atom. Rest, when resonance will happen, this negative charge will come here. When resonance will happen, negative charge comes here. When resonance is going to happen, negative charge comes here, right? Similarly, when resonance is going to happen, negative charge comes here. When resonance happens, negative charge comes here, right? It can come here as well. Over here in the first case, negative charge, we have on 2 oxygen atoms. Here on 1 oxygen atom, here no oxygen atom. And you know negative charge carrying capacity of oxygen is very high. So A is maximum stable, followed by C, followed by B. Correct? Because in A and C, we have got oxygen carrying negative. In B, there is no oxygen. ACB is the order. ACB is the order. Tell me the answer of this particular question. A, B, C, D, E, F. Give me the stability order. Quickly. Everyone. Give me the stability order, people. Quick. It's a simpler one, by the way. Give me the stability order, everyone. Are we done? Are we done with this? A lot of chatting is going on here in the chats. Someone is asking, Pinky ji, आपकी age क्या है? Wow. Wow. Good. Are we done with this question? Let's see, guys, what's going to happen here. First of all, is there any molecule wherein oxygen is present? Here oxygen is present, here also oxygen, right? But if you look carefully, due to resonance, this negative charge can come on 2 oxygen atoms. Here negative charge can come on only 1 oxygen atom, right? Here negative charge will come on 1 oxygen. and rest carbon. Correct? Now, so which one is going to be maximum stable? Without giving it a second thought, D is going to be maximum stable because negative charge is coming on two oxygen atoms. Now, among B and E, one oxygen, but over here, where is the charge dispersal more? Where, in short, where is the resonance more? Resonance is more in E. More resonance means more stability than B. So this one is done, this one is done, this one is done. Now, which all are left? A is left, C is left, F is left. Now, here you have got only carbon, here you have got only carbon, here you have got nitrogen as well. So negative charge can come on more electronegative element, and negative charge on more electronegative is more stable. So C is more stable. Now, among A and F, right? Among A and F, this negative charge can come here, it can come here, it can come here. So among A and F, there is no electronegative element, there is only carbon everywhere, right? So more resonance means more stability. So F will be more stable than A. So order here is D, E, B, C, F, A. Is it clear? D, E, B, C, F, A. I believe it's clear, right? I believe it's clear to everyone. All right, moving on to one more set of questions. Just a second. Okay. Arrange the following according to the stability order. These are again the carbocations, but here I'll tell you something. You know, stability of carbocation is directly proportional to electron donating groups, right? Inversely, electron withdrawing groups. So electron donating groups, they increase the stability of carbocation, right? Minus M here stabilizes the carbocation maximum, followed by, plus M, followed by plus H, followed by plus I, followed by minus I, followed by minus H, followed by minus M. This is going to be the order. That group which will be showing plus M will stabilize the carbocation maximum, followed by plus H showing, followed by plus I showing, minus I, minus H, minus M. Now, first of all, you have to identify the reference where the positive charge is present, correct? Now, look at all these groups. OH present at para position. Which effect it's going to operate? It's going to operate plus M. At the meta position, it will operate minus I. This will operate minus M at the para, right? At the meta, it will operate minus I. This will operate plus M at the para, right? Perfect. Now, my dear students, look carefully. I told you plus M showing groups, they stabilize the carbocation maximum. Plus M showing groups. Which one is plus M? This is plus M and this is plus M. Now, OH and SH, which shows more plus M. OH and SH, which shows more plus M. Here the overlap will be 2p overlap. Here the overlap will be 2p overlap. 2p overlap is effective. 2p overlap is effective. So 1 will be maximum stable, followed by 5. So plus M is over. Is there anyone showing plus H? There is no one showing plus H. Anyone showing plus I? No one showing plus I. Is there anyone showing minus I? Yes. This showing minus I, this showing minus I. But minus I groups, they decrease the stability. Which one among these two shows lesser minus I? OH shows lesser minus I. Lesser minus I means more stable. So 2 is more stable, right? Then comes 4, and at the end, I'll give priority to 3. 1, 5, 2, 4, 3. Anyone got this answer? 1, 5, 2, 4, 3. 1, 5, 2, 4, 3. Anyone got this answer? 1, 5, 2, 4, 3. Yes. Good job. Good job, people. Moving ahead. Okay, stability of carbanions. These are all carbanions. As you can see over here, negative charge. Remember, stability of carbanion, you know already, electron withdrawing groups are going to stabilize and electron donating groups, they are going to destabilize, right? Okay, electron withdrawing. And in electron withdrawing, you'll prioritize minus M showing group first, followed by minus H, followed by minus I, followed by plus I, followed by plus H, followed by plus M. Now, first of all, you need to identify which group shows which effect. Quick, people. So first of all, NH2 at para position, right? It is going to the lone pair, it will show plus M. At meta, it's going to show minus I. Here, it's going to show plus M. PR3, here it's going to show minus M because it has got the vacant d orbital, right? It will show minus M effect. Okay, now prioritize minus M first. There is only one which is showing minus M. So 4 is going to be maximum stable, right? Then is there anyone showing minus H? No. Is there anyone showing minus I? Yes, 2. Prioritize 2. Correct? Then this showing plus M, this showing plus M. Which one shows lesser plus M among the two? Among these two, which one shows lesser plus M? Quickly, NH2 or OH? Which one shows lesser plus M? I'm asking you. Which one shows lesser plus M? NH2 or OH? Which one shows lesser plus M? I'm asking you. OH shows lesser plus M. Right? Lesser plus M means more stable. Perfect. So 3 followed by at the end 1. So 4, 2, 3, 1 is, did anyone give this answer? 4, 2, 3, 1? Right? Perfect. Chalo. This part is done. Let's move ahead. These questions are done already. Just a second. Questions based on acidic strength. Questions based on acidic strength. Questions based on acidic strength. See guys, strength of acid is directly proportional to the stability of the conjugate base. It is directly proportional to stability of conjugate base. And conjugate base is stabilized by electron withdrawing groups, destabilized by electron donating group. Rest all the things you know. Electron withdrawing में maximum, you'll prioritize minus M, minus H, minus I, plus H, plus M. Right? This was the strength of acid. Similarly, if they ask you about the strength of base, in short, remember directly, strength of base is directly proportional to electron donating groups, inversely proportional to electron withdrawing groups. Directly remember it. Directly remember it. Strength of a base, right? And electron donating plus M, plus H, plus I, minus H, minus M. Okay? Remember these two orders as well. Remember these two orders as well. So here, let's try to solve certain questions. Let's try to solve certain questions. Arrange the following as per their acidic strengths. Arrange the following as per their acidic strengths. Look at this particular OH. From here, hydrogen is going to leave as H positive. From here, hydrogen is going to leave as H positive. Right? So where do you see acidic strength more? Acidic strength more. Right? Acidic strength more. You have got fluorine electron withdrawing. Here also you have got fluorine. Right? Electron withdrawing group is closer here. More closer, more acidic strength. Right? Okay. Perfect. Now, among these four, take H positive out, negative charge on oxygen. Take H positive out, negative charge here, negative charge here, negative charge here. Right? Now, you got the conjugate bases. Now, you know conjugate base is stabilized by electron withdrawing. Now, which ring is more electron withdrawing? 3-membered, 4-membered, 5-membered, or 6-membered? This 3-membered ring, it is under more angle strain, so it is more electronegative. More electronegative means it will stabilize the carbene. It will stabilize the negative charge the maximum, right? So this is going to be the acidic strength. This is going to be the acidic strength. Right? This is going to be the acidic strength. I believe it's clear. I believe it's clear. Right? I believe it is clear. Order of acidic strength among these. What do you think? Order of acidic strength among these. Quick. Order of acidic strength among these. Order of acidic strength among these. Quickly. So first of all, you know, when it comes to the acidic strength, I've told you already, or let me give you the order. It is directly proportional to minus N, then your minus H, then your minus I, then your plus I, then your plus H, then at the end plus M. Select your reference first of all. Select your reference from where hydrogen is going to leave as H positive. This is your reference from where hydrogen is going to leave as H positive, right? What do you think? Which effect is going to operate here? Which effect? It's not going to operate minus M, right? It's not going to operate minus M. You know it. Because there is unavailability of the vacant orbital over here at nitrogen. So it will just show minus I, right? That too, it will show weak minus I because it is at the position 1, 2, 3, 4, right? Inductive effect dies after 3 carbon atoms. Over here, this is going to show minus M because phosphorus has got the vacant d orbital, right? Here it will show inductive effect because it's at the meta position. Here also it is going to show inductive effect. Now accordingly, you can give the order. I believe these sort of questions, based on acidic basic strength, you can easily justify. Now here you might do a mistake. Here you might do a mistake. Or wait, let's not talk about this particular question first, or let's solve this one only first. Acidic strength, COH everywhere, right? COH everywhere. Now CH3 present at the para position, so it's going to show plus H. At the meta position, it's going to show plus I. This is going to show minus H. This is going to show minus H. This is going to show minus I, right? Is there anyone showing minus M? No. Is there anyone showing minus H? Yes. This shows minus H, this shows minus H. Which one shows more minus H? CBr 3 shows more minus H. More minus H means more acidic strength. So 4 is maximum acidic followed by 3. So 4 and 3 are over, right? Now comes your minus I, right? Minus I. Now plus I plus H. Plus I plus H. I'll give priority to 2 followed by 1. Yes? Is it clear? Is it clear, guys? Just the priority order which I was talking about till now. Nothing else. Nothing new. Nothing new. Nothing new. Nothing new. This is the asked question. This has been asked in your NEET. What do you think about this one? What do you think about this particular question? What do you think about this particular question? Quick. First of all, select the reference. This is your reference. This is your reference, right? Okay. This is your reference. This is going to show plus N, OR group, minus M, plus H, minus I. Acidic strength. Give priority to minus M. So 3 is maximum acidic. 3 is maximum acidic, and there's only one option which says 3 is maximum acidic. That's option C. Right? Clear? Nothing else to check. Nothing else to check. These are already done. Or this one you can let me know quickly in the chats. Where do you see? Lowest pK. Lowest pK means? Lowest pK means more Ka. More Ka means more acidic strength. Right? So acidic strength basically is directly proportional to Ka value, and Ka is inversely proportional to pKa value. Lowest pK means more Ka, more acidic. Which one is more acidic among all? Which one is more acidic among all? Which one is more acidic among all? This one, right? There is CCl3 attached. CCl3 attached. All right. Just give me a second. Can you let me know the answer of this question? Basic strength. Basic strength. Basic strength order. Plus M, plus H, plus I, minus H, minus M. Right? Give answer as per this order, quickly. Give answer as per this order, quickly. Give answer as per this order, quick. Quick, people. Give answer as per this order, quick. CX3 present at ortho or para, it shows minus H. CX3, where X is halogen. All right. So my dear students, CH3 over here, it shows present at para position. So plus H, minus H, plus I, and minus I. Correct? There is no one showing plus M, leave it. There is one showing plus H, right? So one is maximum basic. Then this is donating, so 3. Then comes your fourth one. Then comes your second one, right? Because second one is showing minus H. As per this order, I'm just looking at this order, accordingly giving my answer. 1, 3, 4, 2. Right? 1, 3, 4, 2. 1, 3, 4, and 2. Question can be based on the bond length as well. It can be asked as per bond length as well. Now, NC bond length. Compare the NC bond length everywhere. Compare the NC bond length everywhere. What do you think? NC bond length everywhere. NC bond length everywhere. What do you think about this one? NC bond length everywhere. Quick. See guys, between N and C, here you have got a pure single bond. Here you have got pure double bond. So bond length here will be maximum. Because it's pure single, it is pure double. Minimum bond length. Here you have got partial double. Here also you have got partial double. Right? You are getting partial double bond character here, double bond character here. Now, where is the resonance more? Over here, resonance is more. If resonance is more here, double bond character here will be more. Double bond character more means comparatively lesser bond length. So between 3 and 4, 4 will have lesser bond length than 3, right? So 1, 3, 4, 2 is going to be the bond length order. Am I clear? People are saying 1, 4, 3, 2. Wait, among 3 and 4, this is getting double bond character, this is getting double bond character. This is getting more double bond character means lesser bond length. So 4 will have lesser bond length. 4 will have lesser bond length than 3. I'm right, you're wrong. Yeah? Perfect. All right, moving on to a few more questions which can be asked from aromatic, anti-aromatic, etc. Aromatic, anti-aromatic, etc. I hope you know how do we check. I hope you guys know how do we check whether the species is aromatic, anti-aromatic or non-aromatic. Do you know that? Let me quickly give you the brief idea of the things. If I talk about the aromatic compounds, in case of aromatic compounds, what you will find? First of all, you will find the molecule is cyclic. Number 2, the molecule is planar. There is complete cyclic conjugation. There is complete cyclic conjugation. It is following Huckel's rule, 4n plus 2 pi electrons. 4n plus 2 pi electrons are participating in the complete cyclic conjugation. If n value is 0, that means 2 pi electrons. If n value is 1, 6 pi electrons. If n value is 2, 4 to 8 to 10, 10 pi electrons. If n value is 3, 4, 3, 12, 12 to 14, 14 pi electrons, etc. Right? This is aromatic. Now, about anti-aromatic. About anti-aromatic, the molecule is cyclic, right? It is planar as well. There is complete cyclic conjugation present. Complete cyclic conjugation. It follows there are 4 n pi electrons participating. If n is 0, if n is 1, so 4 pi electrons. If n is 2, 8 pi electrons. If n is 3, 12 pi electrons, etc., etc. Right? Then we have got non-aromatic. Non-aromatic. Those molecules which are neither aromatic nor anti-aromatic, they are non-aromatic. Which are neither aromatic nor anti-aromatic, they are non-aromatic. Right? For example, let me take certain cases here. Just a second. Let me take certain cases here. So first molecule I'm taking, this is the first question, NEET 2022. NEET 2022. First of all, 2, 4 and 6. 6 pi electrons participating in the cyclic conjugation, right? 2, 4, 6. 6 pi electrons participating here also. Only 2 pi electrons participating here, right? This is sp3. sp3 means it is non-planar. Non-planar means non-aromatic. This is non-aromatic. Number 1. Right? 6 pi, 6 pi. So this aromatic, this aromatic, this aromatic. So this one is the only one which is non-aromatic. Correct? Correct, people? I hope I'm clear. Right? I hope I'm clear. I hope I'm clear. Tell me the answer of this question. Quick. You should be able to solve this one as well. You should be able to solve this one as well. Quickly. Quickly. Among the following, the aromatic compounds are, first of all, if you look at this one, this sp3 hybridized, because there are 2 hydrogens, right? sp3. sp3 means this is non-aromatic. Non-aromatic. 6 pi electrons, aromatic. 2, 4, 6. 6 pi electrons, aromatic. 4 pi electrons, anti-aromatic. Done? anti-aromatic. Right, people? I believe it's clear. I believe it's clear. Okay, I believe it's clear. So I hope you can solve all the questions based on which can be asked from these effects. Is this clear? Let me know once in the chats if all the things are clear. Yes? Perfect, guys. Then let's move on. Just a second. Let's move on to the chapter chemical kinetics first. Have you studied kinetics? Just say yes or no. Have you studied kinetics? Kinetics or electro? Which one do you want to do first? Kinetics or electro? Kinetics or electro? You tell me. Kinetics or electro? Which one? Majority wins. Majority wins. Quickly. Kinetics, right? Okay, got it. Chalo, let's start with the kinetics then. Let's start with the kinetics. Let me show you what kind of different types of questions can be asked in kinetics, right? The first one. For the chemical reaction, the correct option is the reaction that's given to us is N2 plus 3 times H2. It gives what? It gives 2 times NH3. If I ask you to write the differential form of rate, first write it in terms of N2. N2 is the reactant, you'll start with the minus sign. 1 divided by stoichiometric coefficient is 1. Change in the concentration of N2 divided by time interval dt. With respect to H2, H2 is also a reactant, so start with minus sign. 1 by stoichiometric coefficient. Change in the concentration of H2 divided by dt. Similarly, in terms of NH3, start with plus sign. 1 divided by 2. Change in the concentration of what? NH3 divided by time interval dt. Right? Now, check your options and find the answer. Check the options and find the answer. Which one is correct among all? Which one is correct? People are coming with option C. Is that? So option C is the correct answer of the first question, which was given to you. Tell me the answer of this one then. Tell me the answer of this particular question. You are given with a reaction, right? You are given with a reaction. The rate of appearance of Br2 is related to rate of disappearance of bromide ion. So we have to relate Br2 with Br negative. Br negative is the reactant. So rate in terms of Br negative will start with minus sign. 1 by stoichiometric coefficient. Change in the concentration of Br negative divided by time taken is the equal. With respect to Br2, start with the positive sign. 1 divided by stoichiometric coefficient because it's a product, that's why positive. Change in the concentration of Br2 divided by time taken dt. Right? Now find your check your options. Check your options here. We are done. Check your options. People are saying option D. Is that? So if you take this 3 here, so it is minus 3 by 5. Minus 3 by 5. No, this cannot be the one. This cannot be the... Oh yeah, this can be the one. Minus 3 by 5. Minus 3 by 5. d of Br negative by dt is equal to this. Yes, it is option D. It is option D which is the correct one. It will be option D which is the correct one. Right? Simple and basic question this was. Simple and basic question. Tell me the answer of this particular question. One more type of question that can be asked here. You're given with a reaction A plus B, it gives products. This is the reaction whose rate constant for visible scale. Okay. Rate is doubled when the concentration of B is doubled, and rate increased by the factor 8 when the concentration of both reactants are doubled. The rate law for the reaction. How do we do it? First of all, if I write the rate law, R is equal to K, concentration of A raised power X, concentration of B raised power Y. X and Y, these are order with respect to A and B. You know it. Order with respect to A and B. I'm calling this as equation 1. Let me make the second equation. Rate is doubled. So rate is doubled. Initially it was R, now it is 2R. When it's 2R, rate is doubled when the concentration of B is doubled. When the concentration of B is doubled. So here it is going to be 2B raised power Y. Third one. Rate increased by the factor of 8. Initially it was R, now it's 8R. When it's increasing by the factor 8, when the concentration of both A and B are doubled. So here instead of A, I'm writing 2A. Here instead of B, I'm writing 2B. So how many equations I got? I got 3 equations. Now I just have to solve these equations. My dear students, if I do one thing, if I divide equation 2 with equation 1, dividing 2 with 1, so R cancel, on left side we get 2, this term cancel, B raised power Y cancel, so this is 2 raised power Y, which is telling you that Y has to be 1. Y has to be 1, right? Now if I divide equation 3 with 2, if I divide 3 with 2, right? Perfect. So R cancel, 8 by 2 is 4 is equal to K cancel, A raised power X, this term cancel, so this 2 raised power X. So what has to be the value of X? I'll say X value has to be 2, right? So X is 2, Y is 1. X is 2 here, X is 2, Y is 1. X is 2, Y is 1. X is 2, Y is 1. So it's going to be option D, which is going to be the correct answer of this particular equation. I hope this is clear to everyone, right? So just make the 3 equations, just solve them and get the actual rate law. Yeah? Perfect. I believe it's clear to everyone. Moving ahead. Moving ahead, people. Moving ahead. This type of the question you will frequently see in your books, and these sort of questions are asked as well, right? Look at the question carefully and try to solve it. Try to solve it, guys. Try to solve it. First of all, you are given with a reaction. This is your reaction. Let me try to write its rate law. R is equal to K, concentration of A raised power X, concentration of B raised power Y. I wrote its rate law. This is its rate law. Okay. Now we will try to understand. Try to understand. In the experiment second and third, concentration of A is kept constant. It is not changing. So imagine A is not here. It's not changing. A is not here. Now, what is happening to B? Concentration of B is made 2 times. What is happening to rate? Rate is getting 4 times. So when A is constant, making this 2 times. When you are doubling B, rate is becoming 4 times. When you are doubling B, when you are making it 2 times, rate is becoming 4 times. When is that possible? That's only possible if the value of Y is 2. If the value of Y is 2, because then only 2 square comes out to be 4, right? Number 1. Number 2, guys. If you look at experiment number 1 and 4, right? Concentration of B is kept constant. But what is happening to concentration of A? It is made 4 times. What is happening to rate? Rate is also increasing by 4 times. So when you are increasing this, when you are making this 4 times, rate is becoming 4 times. When you are making this 4 times, rate is becoming 4 times. That means X value has to be 1 only, right? Because if X was 2, then 4 ka square should have been 16. That's not the case here. So Y is 2, X is 1, right? Y is 2, X is 1. Y is 2, X is 1. This is 2 and this is 1, right? So it is option A which has to be the correct answer of the question. Is that? Or I wrote the reverse. Wait, X is 2. I wrote the reverse here. X is 2. So A ka power has to be, sorry, X is 1. A ka power has to be 1. A ka power has to be 1, right? And B power has to be 2. So it is option D basically, not 1. So this sort of a question is asked. So have an eye on this sort of a question as well. Now guys, what do you think about this particular question? You should not be solving this, right? It should take less than 10 seconds, less than 5 seconds, I believe, to answer. If you have watched my chemical kinetics marathon, I believe, right, you can do it easily. when the initial concentration of the reactant is doubled, half-life of the zero order reaction. What is the half-life of zero order reaction? T half. T half in case of zero order is equal to A naught divided by 2. Okay, when you double the initial concentration, half-life doubles, right? Is doubled. In short, because they are directly proportional. Someone is saying remains unchanged. No, that is for the first order, not for the zero order. That's for the first order, not for the zero order. Correct? That's for the first order. Can you look at this particular question? Can you look at this particular question? You are given with a reaction A gives B. Its rate constant is given as 0.6 into 10 raised power minus 3 moles. I mean moles per second. If the concentration of A is 5 molar, okay, then concentration of B after 20 minutes. So initially, the initial concentration of reactant is A naught. We have to check. It is mentioned that after 20 minutes, just a second. After 20 minutes, let the concentration of A be 80 and the concentration of B be BT, right? We have to calculate the concentration of B after 20 minutes. So we have to get this particular value. Right? It's simple, guys. A naught at time t is equal to 0. After 20 minutes, let the concentration of reactant is 80 and concentration of product is BT. We have to calculate the concentration of B at 20 minutes. You know, since it is a zero order reaction, right? It is a zero order reaction. Rate constant is moles liter inverse second inverse. So it is zero order. So AT is equal to A naught minus KT. You know it, correct? Can I write A naught minus AT is equal to KT? A naught minus AT is KT. Now, what is A naught minus AT? A naught is the initial amount of reactant. AT is the amount of reactant left. Initially, we start with A naught. We are left with AT. We started with A naught. We are left with AT. So A naught minus AT. Can I say that will be basically equal to BT? I start with A naught amount. Now, after some time, I'm left with AT. So A naught minus AT would have got formed, would have got converted into product. So BT is A naught minus AT, which is KT. What is K value? K value is 0.6 into 10 raised power minus 3. And what is T? T is 20. Solve it. Done. Right? Solve it. It's done. Perfect, guys. I believe you can easily solve this sort of a question. Correct? Asha, I forgot to tell you one thing. Here, it is given as 20 minutes. So multiply at the end with 60 as well. Because this is moles per liter per second. This is minutes. So convert this into seconds. So multiply this with 60 as well. Right? Be careful with that. Be careful with that. All right. Look at this particular question. Graph y versus x and its constant. I mean, parallel to x-axis. Parallel to x-axis. Now, which option do you think suggests? Which option is correct? Which option is correct? If y is rate, x is concentration. If y is rate versus concentration for a zero order. For a zero order, rate is independent of concentration, so it has to be parallel only. So this condition is satisfying. What is second? T half versus x. T half versus concentration. T half versus concentration of reactant for the first order. For the first order, T half is equal to 0.693 divided by K. So T half is also independent of the concentration, right? So it is option C only, which is the correct answer of the question. Right? Perfect. Perfect, guys. Have a look on this particular question. I believe you all should be in a position to solve this. What do you think? What do you think, people? What do you think? See, first of all, you're given with a reaction. The reaction is A gives B. Let me read the question. An organic compound undergoes a first order decomposition. Time taken for the decomposition to 1/8 and 1/10 of its initial concentration are this and this. Calculate the value of this. Right? This is the question. First of all, let's say at time t is equal to 0, the initial concentration of reactant is A naught, this is 0. As per the equation, at time t is equal to T1/8, concentration of reactant left is A naught by 8. Right? This is the concentration of reactant left at time t is equal to T1/8. Now, at time t is equal to what? T1/10, concentration of reactant left is A naught by 10. Right? A naught by 10. So, these are the two conditions which we got. These are the two conditions which we got. These are the two conditions which we got. Now, first of all, I hope you remember the integrated rate equation for the first order reactions. You know, T is equal to 2.303 divided by K. It is a log of A naught divided by 80. Log of A naught divided by 80. If I put this condition here, instead of T, I'll write T1/8 is equal to 2.303 divided by K log of A naught. What is 80? 80 is A naught by 8, right? 80 is A naught by 8. So A naught cancel, 8 comes up. 8 can be written as 2 raised power 3, right? And 2 raised power 3 can be written as 3 log 2. 3 log 2. So this is 3. And log 2 is nothing but 0.3. I'm calling this equation 1. If I put this condition in the same expression, it's going to be T1/10 is equal to 2.303 divided by K log of A naught divided by, what is 80 here? 80 here is A naught divided by 10. So A naught did not cancel. Log 10 is 1. Log 10 is 1, right? So I'm calling this equation number 2. Now, as per the equation, what do I need to get? T1/8 divided by T1/10. So if I divide them, T1/8 divided by T1/10, and then if I multiply them with 10, what do I get? Understand. T1/8 is this 2.303 multiplied by 0.9 divided by K whole divided by T1/10 2.303 divided by K multiplied by what? Multiplied by 10. So this term got cancelled. 0.9 multiplied by 10 comes out to be 9. So answer of this particular question is nothing but it is 9. Correct? It is 9. I hope I'm clear with this, right? This sort of a question can be asked. Wait. Let's see some different type of questions. These are similar, these are similar. Can you tell me the answer of this question? Simple and basic question. Quickly. Quickly, people. Sainath, it's been more than 1.5 years. I'm the part of Unacademy, right? You are not. What is the answer of this question? See, there are few expressions which you need to know. In case of the first order reactions, do remember. In case of first order reaction, time taken to complete 75% reaction is equal to 2 times the half-life. Time taken to complete 87.5% of the reaction is equal to 3 times half-life. Okay. Time taken to complete 99.9% of the first order reaction is equal to 10 times half-life. But do remember all these results, they are valid only for the first order reactions, right? So it is mentioned that the reaction is 50% complete in 2 hours, 75% complete in 4 hours, right? The order of the reaction is, what will be the order of the reaction then? 50% is complete in 2 hours, right? 50% complete in 2 hours. So this value is 2. 2 2s are is 4. 2 T75 is 4. So order of the reaction directly is 1. So it's a first order. It's following the first order kinetics. It's following the first order kinetics. There is no need to think a lot about this question. These sort of questions you would have seen in the books, and I believe you can solve these questions. For a zero order reaction, for every 10-degree rise of temperature, the rate is doubled. If the temperature is increased from 10 degree to 100 degree, the rate of the reaction will become. I've given you one expression, if you remember, R2 divided by R1 is equal to 2 raised power delta T divided by 10, right? R2 has to be equal to 2 raised power. What is delta T? Change in temperature. Final minus initial, that's 90. 90 divided by 10 multiplied by R1. So it comes out to be 2 raised power 9 times R1. 2 raised power 9 is 512, I would think, right? R2 is equal to 512 times R1. So when the temperature of the reaction changes from 10 degree to 100 degree, rate increases by the factor of what? 512. Okay? Do remember this expression, guys. This is important. It's an important expression. And frequently questions are asked in that. Okay. This sort of equation, I believe you can solve. This sort of equation, I believe you can solve. X gives Y is an endothermic reaction. X gives Y, sorry, is an exothermic reaction. Right? Exothermic. Enthalpy is 135. Since it's exothermic, delta H has to be negative. So it's minus 135 kilojoules. Correct? Activation energy for the conversion of X into Y. So activation energy of forward reaction is equal to how much? 150 kilojoules. What do I need to calculate? Activation energy of backward reaction. I believe you know your delta H is always equal to EAF minus EAB. EAF minus EAB. Delta H is minus 135. EAF is 150. EAB you have to calculate. So from this particular equation, EAB will come out to be 285 kilojoules per mole. Is there any option as to 285? Yes, option B is the one which is correct. Right? Perfect. I hope this is clear. Okay, quickly tell me the answer of this question. Few minutes back only we solved this. Read the question quickly and tell me the answer of this question. Quick. Temperatures increase by 50 degree, right? Temperature increase by 50 degree. That means delta T is 50. 50 divided by 10 is 5. So 2 raised power 5 times. So 32 times, right? 32 or 64. 2 raised power 5 is 2 to 4, 4 to 8, 8 to 16, 16 to 32. 32 times. 32 times, right? What do you think about this one? The activation energy of the reaction can be determined from the slope of which of the following graphs? You would have seen this particular equation in the Arrhenius. Ln K is equal to ln of A minus EA divided by R multiplied by 1 upon T, right? If you plot this along y-axis, if you plot this along x-axis, this becomes your M, this is minus here, and this is C, right? So, y is equal to minus mx, y is equal to minus mx plus C, y is equal to minus mx plus C is a straight line, and slope of this particular graph comes out to be nothing but minus EA divided by R. So, from the slope of this particular ln K versus 1 by T, you can get the activation energy of the reaction. You can get the activation energy of the reaction, right? You can get the activation energy of the reaction. Let me see what all different type of questions do we have here. Without solving, without using pen and paper, can you let me know the answer of this question? Without using pen and paper. When the initial concentration of the reaction is doubled, half-life is not affected. Half-life is not affected. What is the order? Half-life is not affected. What is the order? It is the first order reaction basically. For the first order reaction, T half is equal to 0.693 divided by K, right? Half-life is independent of the initial concentration. Exactly. Perfect. Perfect, guys. Can you solve this particular question? Can you solve this particular question? As per the question, let's see. You are given with the gaseous phase reaction A gives 2B plus C, right? P naught be the initial pressure of A, Pt be the total pressure at time T. Integrate rate equation is. This has been asked long back in AIMS examination, right? So first of all, at time T is equal to 0. Pressure due to A is P naught, this will be 0, this will be 0. Now at time T, this is going to be P naught minus X. 1 mole gives 2 moles. So this is going to be 2X and this is going to be X. If I ask you what about the total pressure at time T? Total pressure at time T will be this plus this plus this. So 2X plus X makes it 3X, right? This plus this plus this, which makes it P naught plus 2X, right? So X from here can be written as 1 by 2 times Pt minus P naught, correct? Now, integrate rate equation K can be written as 2.303 divided by T. It is log of. It used to be A naught by AT. A naught used to be initial concentration. Here it's going to be initial pressure divided by. It used to be AT, concentration of reactant at time t. But here it's going to be pressure of reactant at time t, which is P naught minus X. And X already you know, that is half of PT minus P naught. Now again, just a matter of calculation. So 2.303 divided by T, it is log of. This becomes 2P naught minus 1. And that 2 comes up. So 2P naught divided by, this is 2P naught plus P naught, which makes it 3P naught minus PT. Is there any option like this? 2P naught divided by 3P naught minus PT. Yes, option B is the one which is going to be correct. Right? Perfect. Kinetics of the first order gaseous phase reaction we have discussed in detail if you remember. What do you think will be the answer of this particular question? You are given with a reaction, which is first order, right? The time required to reduce from 2 grams to 0.2 grams. So reaction is, for example, like this, A gives B. Initially, the amount of reactant is 2 grams, right? At what time the reactant left will be? Reactant left is 80. It is 0.2 grams. Rate constant is also given. So you can use just the expression, that's it. You can say T is equal to 2.303 divided by K. Log of A naught divided by 80. This will be log of 10, that's 1. Perfect, log of 10, that's 1. 10 raised power 3 goes up. So this will be 1, this will be 2. 10 raised power 3 divided by 2. Correct? So 1000 divided by 2 is 500. So I'll say after 500 seconds, right, the amount of reactant will change from 2 to 0.2 grams. 2 to 0.2 grams. Okay? This can be one more type of question asked. Find out the time required for 2/3 completion. You must be knowing time required for X% completion. There is a one general expression, 2.303 divided by K. 2.303 divided by K log of 100 divided by 100 minus X. Correct? 100 divided by 100 minus X. You would have seen this particular expression somewhere, right? Now, time taken to complete 2/3 of the reaction is equal to 2.303. K is nothing but 4.3 into 10 raised power minus 4. Log of, this is 100 divided by, first of all, what is 2/3 completion? Wait, what is 2/3 completion? What is 2/3 completion? Let's not solve it like this. Wait. Let's not solve it like this. Let me show you the general procedure. For example, you have got the reaction A gives B. Initially, at time t is equal to 0, let the concentration of reactant be A naught. Right? Now, the question says, find the time required for 2/3 completion. 2/3 completion. 2/3 completion. So when 2/3 of the reaction is complete, that means 2/3 of reactant would have got converted in product. So how much reactant will be left? A naught minus 2/3 of A naught will be left. Right? And left out amount is represented by 80. So it is just going to be A naught by 3. So A naught by 3 is the amount of reactant left at this particular case. Perfect. So I'll use just the integrated rate equation. Integrated rate equation is just going to be, I'll write T 2/3 is equal to 2.303 divided by K. It is a log of A naught divided by 80. Correct? So T 2/3 is equal to 2.303 divided by K is 4.3 into 10 raised power minus 4. Log of A naught divided by 80 is what? A naught by 3. A naught is cancel. Log 3 comes out to be 0.47. Right? Log 3 comes out to be 0.47. So multiply at the end with 0.47. Right? And matter of calculation, you're done. Right, guys? You can solve this question in this way. You can solve this question in this way. I believe I'm clear. I believe I'm clear. Tell me the answer of this question. I want to see what you will do in this one. Quick. Quick, quick, quick. Quick. See guys, first thing, for the reaction whose activation energy is 0, that reaction whose activation energy is 0, you must be knowing K is equal to A e raised power minus EA divided by RT. If you will be having any reaction whose activation energy is 0, so K becomes equal to A, right? So K becomes temperature independent. So that particular reaction which has got 0 activation energy, right? Its rate constant becomes independent of temperature. So if you change the temperature, rate constant does not change. Rate constant does not change. As per the question, you are changing the temperature from 200 to 400. Rate constant will not change. It will still be 1.6 into 10 raised power 6 second inverse only. Right? It will be still the same. It will be still the same. Got it? That particular reaction which will be having 0 activation energy, for that particular reaction, rate constant is independent of temperature. So if you change the temperature, nothing is going to happen to the rate constant. Perfect? Perfect, guys? So that's all what can be asked here. One basic question which will boost you up. Tell me the answer of this one. Tell me the answer of this one quickly. Quickly, people. Done? Done with this? Absolutely, it's 32. Right? So with this, your chemical kinetics is also done and dusted. Guys, I think I'll end the session right now. Okay? The 2-3 chapters. How many chapters are we done with? We are done with mole, redox, atomic, chemical bonding, thermo, equilibrium, kinetics, GOC. Right? Okay. The remaining 2-3 chapters will come up with one more session. Okay? All the things are clear here, till here? I was checking the ionic equilibrium slides, but they are missing here. I'll have to find them. Still, guys, we have time. We have a lot of time. Chill. First of all, in coming 3 to 4 days, your whole syllabus is going to get completed, right? Because there is inorganic class 12 marathon left, which will happen on Sunday, right? Class 12 botany is left, which Ambika ma'am has planned on Tuesday, I think. And one session of class 11th physics is pending. So in total, 4 marathons are pending, which will take 4 days. And then there are going to be new sessions, amazing sessions, right? Okay. Practical chemistry, I've told HSP sir to teach. He will do that too. Okay. Okay, some people are saying solve this question. Or the reaction A gives B. Okay, this is the reaction. The order with respect to A is 2, the order with respect to B is 3. So write the rate law, R is equal to K concentration of A, order with respect to A is 2, and order with respect to B is how much? It is 3. The concentration of both A and B are doubled. So you are doubling this one as well as doubling this one. So this becomes 2 raised power 2, 4, 2 raised power 3, 8. 8 fours are 32. So rate is becoming 32 times. Rate is becoming 32 times. Right? Rate is becoming 32 times. PDF of this particular session I'll share right after the session on my personal telegram, t.me/WASSIMSIRCHEM. Right? On that, I'll be sharing that. Perfect, guys. So I hope you liked. I hope you liked the session. And guys, if we have done some 8, 9 chapters, trust me, people. From these chapters, questions directly, indirectly will be the same. Directly, indirectly will be the same. For sure. It is my guarantee. I'm giving you this in writing. Directly, indirectly, questions are going to be the same. You will see that in the NEET 2024 paper, for sure. Because I have told you, I have given you almost every problem pattern which can be asked from a particular chapter. Okay? So, chalo, with this, I'm going to take a leave. I'll see you in the next session. You guys take care till then. God bless you all. Bye-bye. Take care, guys. And let me know in the comment section, right? Let me know in the comment section how you like the session. Bye-bye.